Let us start with the basics of HVAC drafting today. And we all have the notes for the drafting behind the data book. All right. It says Introduction to HVAC Module 4. And आज तो basic complete introduction रहेगा on how to understand how the drafting actually starts and how to proceed and etc. All right. What we need to actually start doing is we have to first understand the meaning of drafting before we even enter to the world of drafting. All right. So in the earlier classes and basic classes, as I have mentioned, that drafting is nothing but it is an engineering drawing. All right. Engineering drawing, and when we are assigning the word engineering to it, जब हम जो word engineering उसके साथ add कर देंगे, what usually happens is it gets a meaning in depth. For example, civil drafting, HVAC drafting, there is electrical drafting and etc. All right. So whenever we are trying to show something in which is going to be converted into reality, depending upon your plan, depending upon your drawing, is what is going to be a drafting. Since we are dealing with the system and service design, and we are dealing with the first first segment of the mechanical engineering, that is dealing with the HVAC service, we are going to deal with the HVAC drafting. In the HVAC drafting, if we are going to get the clear synopsis, it is going to be how to do the air ducting, how to assign the duct work in SLD form and DLD form. Now, what is going to be SLD and what is going to be DLD is what you will be understanding a little further. All right. Usually the SLD is the actual duty of a design engineer or a project engineer who is going to incorporate his ideas to create a basic drawing, and that drawing is only going to exhibit the HVAC service. Normally, when until now in the course that you people have come across, which module is going on? Second module is started, ended, going on, right? So you all know the parameters on how to do the duct designing, right? You have a velocity regain method, you have a equal friction method, then you have come across the different name and nomenclature of air terminals, all right, diffusers and grills, right? So like that you'll be getting registers and different kind of volume control dampers to control the volume and etc. Now in that place, when we know that air terminal jab aata hai dimag mein, so we know ki it can be most of all the diffusers, or most of all it can be the grills. Now how to decide where to place the diffuser, where to place the grill is what you will be understanding in the drafting. Clear? So before we even go into the depth, we need to brush up some basic technical terms and conditions, some technical names of different varieties of objects, and some technical applications on where to apply the HVAC service. All right. So Yogesh, do you know the difference between different kind of false ceilings? आपने real life में भी देखे होंगे, right? So can you tell me few examples of false ceilings, different kind of false ceilings? Which all do you know? Grade. Okay. And then there is, okay, totally related to the ceilings, false ceilings. There is tiles and grids mean the same. There is going to be plain false ceiling as such. All right. Then there is going to be step false ceiling that is usually found in villas and etc. Now the material can be different. All right. कोई thermal का हो सकता है, कोई gypsum board का हो सकता है. अगर false floor लगाने वाले हैं तो woodwork का हो सकता है. All right. हाँ, puff panel, PUV panels, बहुत सारे अलग अलग, we have different kind of varieties. Now we are going to consider majorly the tiles, the plane and the step false ceiling in order to understand the placement of air terminals, that is majorly diffusers and grills. All right. Now when we are going to deal with the service study, we should know how it is going to begin with. What is the starting, the base point for you to do the drafting, or in reality when you're going to actually start doing the single line drawing, because as being a part of the engineering course, as being part of the engineering side, on being strongly affirmative on holding a BTech degree, you people can look forward for entering into a business line which is focusing more on the designer side, right? You have to focus more on giving the implementation for a building. You have to make your considerations very strong when it comes to the design segment. All right. So the single line drawing and double line drawing is not only meant for the ducting side, or it's not only meant for the drafting side, or it's not only meant for the main draftman to do. SLD की जब बात होती है, it means totally that it is a concept design. It's a flow of your art. Alright, आपका पाइप या आपका डक्ट वहां से भी ऐसा आ सकता है या बीच में से भी ऐसा गुजर सकता है, वो आप है डिसाइड करने वाले. You have to check all the physical parameters like friction, velocity, you know, and what else is there? You have roughness, alright, you have the CFM margin. All right, you have so many considerations to take place, how the airflow is moving, how the distribution is coming, if there is a lot of noise inside the circulation of the duct. All these parameters are going to help you make one particular duct. We are not talking about how to build a duct. We are only going to talk about how to draw a duct. In the drafting, we are only talking about drawing. All right, how to draw one particular thing using the AutoCAD commands. All right, लेकिन जो चीज हम draw करेंगे उसका technical parameter होना चाहिए हमको कि ये चीज ऐसे ही आ सकती है. And most of all, we are going to take all the readings in terms of millimeters. That is in regard with mm. All right. So in the basic introduction and in the basic first class that we are going to do, we are not going to go in much detail, but yes, we surely need to start getting into the detail. All right, क्योंकि अब अगर आप नहीं समझेंगे तो later on it is going to become very difficult. जब बात SLD की ये हो गई है that it is going to be a concept drawing, it's going to be as per the design, it's going to be as per your, you know, now I have 6 minds in class. Each one of you can give me a different SLD drawing. If I'm going to give you a project, it's not necessarily you can give me the same one. You have to find your own approximation on how to give the best that is going to suit all the conditions. Is it clear? So एक SLD drawing होगी जो आप as a duty you have to do. That particular conversion into the real drawing, into the real shop drawing is going to be done by a draftsman, a junior draftsman or a senior draftsman or a supervisors of draftsmen and etc. depending upon the mega structure and depending upon the, you know, psychology of the building and the construction, वो depend करता है कि कौन करने वाला है. तो एक normal SLD drawing when converted to a DLD is going to contain all the maximum details what the SLD drawing does not give. Now, if I'm making a straight line from up to this side, but there is a pillar coming in between, maybe I'll be needing a offset for that, or maybe I'll be taking my duct with a reducer or etc. That will not be shown in SLD drawing. That is to be understood by having a beam or a column in between by the draftsman that the duct cannot run in continuation. All right. So the physical parameters on how to actually look for the drawing on the real site is the meaning of your double line drawing. Clear? So a double line drawing, you have to anyway know the knowledge on how to do it is correct or not, because you are the one who's going to approve it later on being a design engineer or being the consultant side or even being on the contractor side. All right, क्योंकि जो दिखेगा वही बनेगा. Is it clear? So you have to put that in mind कि जो जैसा बनने create होगा वो वैसे ही बनेगा. Where? On the field, on the site. Fine. So for doing that, a lot of imagination is required. A lot of visualization is required. You have to feel as if you are there taking the cool refrigerated air up to you. तभी जाके आपको वो चीज thinking आएगी, अगर मैं उस corner में I'm going to stand and my supplier is on this end, how it is going to let the air revolve into that situation or until that position. Is it clear? So there is a lot of possibilities when you try to do drafting. There is a lot of ideas that are going to erupt when you're going to do the drafting. Is it clear? So you have to be very active, you have to be very sharp, and you have to come with a lot of deliveries. कि इसको ऐसे भी कर सकते हैं ना, इसको वैसे भी कर सकते हैं ना, right? So जितना powerful आपकी thinking imagination होगी उतना clear drawing बन सकती है. All right. Normally in the market when the people talk about drafting, they'll be like हमको करने की जरूरत नहीं है ये. You know, the other people can start doing it. The other people who are not on the field can actually start imagining and doing it. But if you are not going to input your powerful ideas into that, what is he going to do? He's only converting an existing drawing. उनका काम उतना ही है draftsmen का. ठीक है, उनको नहीं बुलाया जाएगा साइड पे कि ये take the measurement, start creating the building. No one is going to do that. All right. He is a person with limited amount of knowledge. You are a person with unlimited amount of knowledge. There lies the difference. All right. So you can take care of a situation. He can take only care of a condition. This is the basic difference on how you have to judge and how you have to understand. Is it clear? So ये सारी चीजों को याद रखो. This is going to be the limitation. This is going to be the basic on how you have to proceed. All right. So if we're going to continue the reading, that is Introduction to HVAC Drafting. It says drafting is an engineering design which we prepare using the AutoCAD software. All right. As we deal with the HVAC service precisely, only talking about the HVAC, that is heating, ventilating, air conditioning service, It is called as HVAC drafting. If the same thing is going to work on the civil side construction, it will be called a civil drafting. If after the M you have M from among MEP, you have the E segment in below, all right, in between, that will be considering with electrical drafting. All right, so the parameters, the function, the abbreviations, the follow-ups, the text, the commands also depend on the service that you're providing. Fine. So ये basic चीजें हैं जो you should know and you will be knowing जैसे जैसे course बढ़े. All right. Then during the execution of the HVAC project, we first have to look at the architectural layout that is going to be a normal civil plan. Now, from a civil plan, there are two different things that have been distinguished here. One is the architectural engineer, one is the structural engineer. All right, so you should be knowing that what an architect is going to include in a civil plan and what is a structural engineer going to include in a civil plan, because जो चीज आपके पास बन के आएगी, it is depending upon that you will be starting to draw or deal with the our particular service. Right. So Zaid, what does an architectural drawing include or consist of? Sorry? No, not in general, just a plan. There will be a plan in the structural and engineer segment also, right? What the physical components are going to be included in an architectural drawing, right? So an architectural engineer or architecture plan is going to consist of your walls, very basically. And अगर एक wall आ जाता है तो एक window आ सकती है उसमें. So next thing is there is a window. एक wall अगर आ जाएगा तो there is going to be an entrance. There is going to be a door. अगर wall आ जाएगा तो नीचे उसके जमीन होना चाहिए, that becomes a floor. Okay, to make it a standing elevation. उसके ऊपर कुछ अगर होने वाला है तो there can be a ceiling. All right, below that there can be a false ceiling. These all things are going to be incorporated under a architectural view. ठीक है, क्योंकि आप जो सर्विस करने वाले हैं, your service is going to run above the false ceiling, your details, है कि नहीं? Right? What is going to be there in a structural drawing? There is going to be the total strength that is managing the construction. First of all, there is again going to be walls, but which one? Foundation walls. जमीन के नीचे. Foundation walls. Next thing is there is columns. There are going to be structural columns. There are going to be iron rods. There are going to be, partitions. There are going to be beams. There are going to be pillars. There are going to be slabs. Right? So वो सारी चीजें are going to come under the structural drawing. तो ये दोनों चीज जब mix हो जाते हैं, they are going to merge together. A civil plan is going to be constructed, which is important for us to start our phase of construction. All right, even on the site, can I say that my duct is ready? Can I say that my air terminal is ready? सिर्फ आपका civil plan लो और उसको लगा दो. They cannot do that. I cannot also do that. Right, you cannot do that being on the HVAC service. Fine. So for you to start building or fixing something, there has to be an element already ready. That is called first phase of construction, which deals with your civil designing, like the architectural and the structural commodity. Now, that is not going to be talked about whether it's going to be a residential flat, whether it's going to be a commercial space, whether it's going to be an industrial stadium, whether it's going to be an industrial factory or anything in general. ठीक है, कोई भी जगह पे I cannot directly go and apply my HVAC service if there is no civil conduction provided to me. A civil plan is not brought to me. I cannot start thinking on way to start and way to end from. Fine. So एक civil plan के अंदर ये दो चीजें जब होगी आपको detail मिलेगा and you will try to understand where to actually start from. Clear? So reading and understanding a civil plan is majorly a responsibility. You should know what is what in a civil drawing. You should know how that the doors look like. You should know how in real life the windows are going to be applied. You should know what is the wall material. You should know what is the false ceiling material. All those things are included in your part of design, even though you do not belong to the particular civil site service. Okay, now this complete MEP design side is actually, I love telling this word, it's a conjecture. All right, conjecture का मतलब है in connection. आपको सिविल की नॉलेज भी जरूरी है, आपको आर्किटेक्ट की नॉलेज भी जरूरी है, आपको अपनी खुद की नॉलेज तो चाहिए, आपको इलेक्ट्रिकल की नॉलेज भी जरूरी. ठीक है, उतना नहीं जितना आप अपने खुद के लाइन में एक्सेल कर सकते. You need minimum of everything. All right, you need a little minimum of M also, E also, P also, firefighting also, civil also, everything. It is totally a conjecture. All right, so now that we are going to deal totally with the HVAC project execution and how our services is coming into play, it starts from the actual consultant drawing. What does a client actually require? He's dealing with some air conditioning or central AC department. He wants to apply a central AC flat or maybe a central AC villa for himself or maybe for someone else. Now he proceeds by giving this first call to the architect. Ki, I am coming up with a project. I need your assistance. What does the architect do? He will then respond towards the design, not directly. पहले आपको you only have to gather information. You only have to gather the data and the requirements on what you actually want. How he wants is your responsibility. आई बात समझ में? What he wants is his responsibility. How he wants is your responsibility. You are going to draft that on a piece of sheet. आ रही है बात समझ में? So that starts from one particular thought process from the client, from the consultant. The architect gets a call. He starts collecting the structural engineer. The structural engineer starts collecting a mechanical, electrical, resourceful engineer to start the above services. The service engineers or the service design drawing comes only into play if it is related to HVAC, electrical, plumbing, firefighting. Is it clear? Alright, so pehle the architectural drawing banegi, then you will be coming up with the actual structural drawing along with that, and then it is going to deal with our service design. So when we're talking about the service design drawing, it is independent of all services. There is nowhere going to fall with HVAC, electrical, plumbing, firefighting, all drawings together is not called a service drawing. Individually HVAC, individually electrical is called a service drawing. हर चीज का 4 drawings आपको बनेगी. HVAC, electrical, plumbing, firefighting. That individual service drawing is going to be converted into a shop drawing. Now, what is a shop drawing? A basic introduction, a basic definition. A shop drawing, mein what will you get? Is it? No. What is a shop drawing? We have learned this in chapter 1 itself, in the beginning. Yeah, it's a detailed drawing of the concerned department that you're trying to show. It's a detailed drawing. Everything it is going to include. Alright, जो नहीं दिखाना चाहिए वो नहीं दिखाएंगे, जो दिखाना चाहिए पूरी तरीके से it will be in detail. Fine. So that is your shop drawing. So every service is independently going to create a shop drawing. That shop drawing, if it is rejected, it is going to be updated again. Means there is some fault in that. It has to be remodified. It's not approved by your seniors. If it is approved, that particular one service design drawing, if approved, it goes to the next secondary or higher department, which is called MEP coordination drawing. Now it is at this place where HVAC drawing, electrical drawing, plumbing drawing, firefighting drawing are going to be clubbed to understand if the MEP services are going in accordance. If there is going to be any clash detection, this is the position to acknowledge them. वो clash detection आपको separate करना. You have to just renew the drawing. If it is rejected, again individual shop drawings are to be created. It is not rejected. If it is going to be follow on, then it will be going approve, and then it will be going to the builder's work drawing. Now, what is a builder's work drawing from the word itself? On the construction side, inclusive of shop drawings of all services from the starting. ठीक है, जो आपके पास एक लेबर होगा, एक जो साइट पे जो अवेलेबिलिटी होगी, the builder's work drawing is not only going to get your labor who is good in HVAC part, or who's good only in the electrical part, or who's good only in the civil part. It will be a general labor. Now your builder is going to have a union of labors, and because everyone is good in different thing. Even a labor is having his own principles of working. Every labor cannot directly just go on the field and start building up the mud. Clear? So उनका भी एक art है, उनका भी एक तरीका है. So after your MEP coordination drawing is sustained and approved, it goes to the builder's work drawing where the complete design schedule is there, with the civil drawing, MEP drawing, and etc. From that individual portion, if required, can be limited and printed and given to the laborers for proper understanding. कि पहले architectural plan कैसे उठना है, उसके बाद जब ये इतना portion में उठ जाएगा, 5 floors आ जाएंगे, तो how the AAC ducting has to come. That can be separately, that can be individually planned. And lastly, you will be having the as-built drawing. Now, what is as-built drawing again? Final drawing all together over the plan if seen from top view, front view, side view, हर जगह से. That is the actual portion of construction जो start हो गया. That is the last final as-built drawing. And all the drawings that you are going to create, it is very, very important to remember, can be asked at the time of interview, that all these drawings are to be approved. If to be approved by the civil department or the municipal department, have to be proposed only in color 8. Color number 8, that is ash gray color. Your as-built drawing can be limited to availability of colorful drawing only if it is for your self purpose. आपको अगर देखना है कि आपके जो supported layers थे जिसे आपने drawing की है, if you want to see how those layers are actually conveying you the message of where is what, where is the exhaust, where is the air terminal, where is the actual grill and etc., you can try for your own particular reference. You cannot distribute that to company on a colorful drawing. It will be disapproved. It has to be approved by Civil Defense Department only in a monochrome color, which is color 8. Is it clear? So these things are to be remembered and very, very important. ये था आपका beginning, how it is going to be executed. Now, from this complete portion, the next page that is on page number 3, that is very, very important to us. All right. On page number 3 and page number 4, we are actually having and dealing with the complete abbreviations that are most oftenly used in the HVAC drafting drawing. Take a little time and try to read, and I'll be reading along with that. The abbreviations under the machine parameter says you have an AHU, FAHU, FCU, and CH. We most often know what an AHU is, what a CH is for a chiller, and etc. So under this one, there are some important things that you need to highlight. Just highlight with me. Highlight the air terminal first, and then you can also highlight the chiller. That is what is a little important to us from the segment there. Then in the second part, you have ducting. In the ducting, the most important thing to understand is the first term SAD, which means supply air duct. All right, this does not have to be replaced with where SAD means as supply air diffuser. All right, if we are going to consider a duct, it is going to be a duct. Plus, you can just apply a slash here. That is a what do you call that otherwise? Forward bracket that you can just apply, and you can write main duct. AD is going to be the main duct which is going to be attached to your AHU machine in the process of central cooling. So SAD to be highlighted, and you do not have to refer that as supply air diffuser. It is always going to remain as a supply air duct. Below that is going to be the return air duct. You can highlight that one again, RAD, and this is how you have to actually start creating the layers. Okay. Below that you have fresh air duct, then you have an exhaust air, you have a kitchen air, you have a transfer air duct, and etc. After that one you have air terminals, and under the air terminals, the first thing that you're going to deal with the diffuser, it is called SCD, not SAD. SCD defines as supply ceiling diffuse. Highlight, very important, SCD. So every time you deal or call a diffuser, and if I'm going to ask which diffuser in class, you have to tell me quickly whether it is SCD or RCD, because the diffuser here again defines into the supply condition or the return condition. All right, and do we know the process of how does a supply ceiling diffuser leave the air and how a return ceiling diffuser takes back the air? After that you have supply linear slot diffusers, you have return linear slot diffusers, where the air is going to transmit or transform only from one direction, only in the linear way, only in the lateral way the air will be flowing. ठीक है, या तो नीचे totally या तो side में totally. All right, like that one example is there very nicely for us in DMart. All right, they have a lateral supply slot diffuser. All right, first of all they have open ducting, so you can actually see the whole thing. Then lateral ducting के अंदर अगर आप linear slot diffuser लगाएंगे side से, तो वो सिर्फ शून्य के शेप में रहेगा, ओपन करेगा, एक ही फ्लो में उसको फ्लो कर देगा, डक्ट के नीचे नहीं रहेगा, साइड में रहेगा. ऑलराइट, वैसे जगह पे वो जब लगाना पड़ता है जब लार्ज मार्शल्स आते हैं, like a shopping mall or like if it's a stadium or etc., जहाँ पर more the number of people, more the heat is generating, more the cooling has to be in one particular direction. All right, for after that one you can also have a ceiling fan for distribution of air. All right, जो cool air आएगी, instead of just moving in one direction, it can also move with a fan, with a rotating fan. That happens with a supply linear slot, and that also जो भी supply करेगा उसका एक duplicate return में भी रहेगा. So there is a return linear slot diffuser. Then you have RAG when talking about the grills. All right, so there is a return air grill, you have to highlight RAG, and there is a supply air grill, which means that these are the grills on how you are going to deal with the grills when supported on the step fall ceiling. And similarly, like these linear slot diffusers, you have a linear grill which is called a register, and these registers you can also find a very good example in the air coolers, the desert coolers that we have at home, right? Uske andar you can try to shift the blades above or try to shift the blades below. It's manually done, right? जो आप उसको ऊपर कर सकते हैं for airflow above or below to totally ground floor, ground level. So the movement of the blades that you see, that becomes a register. All right, and if it is having no possible blade movement, it's called a grill. All right, So there that particular thing also is included, and there you can see that one. And on page number 4, you see you have a disc valve. A disc valve is only going to be included in an exhaust duct, all right, for exhausting the heavy smoke or heavy air that is not included inside the room area. Then after that, on number 4, you have accessories, and basic thing that you need to understand is what is the difference between accessories and difference between fittings. If you do not know that now, it will become very difficult in the later classes. So if you have come across any kind of accessory until now in the designing class or any kind of a fittings to kiye honge. Some examples of fittings and some examples of accessories. Shravan, right? Yeah. Some accessories and some fittings, like you should be knowing the difference, where to apply which one and why. Which is a fitting and which is an accessory if you're going to consider a duct or if you're going to consider a pipe that way. How do you connect two different ducts, an L-shaped duct? What would be in between, a fitting or an accessory? I'm not talking about the duct. What is going to help us connect the duct? Something that should hold the duct, right? Right. Yourself, Riyaz? Yeah. What is going to be a fitting? What is going to be an accessory? Doesn't fall under the category of fitting. I am saying, for example, I'll show you a section view of that. I have a particular duct in L shape. Okay. This way. The air is moving this side, moving to this side. Now, what kind of a fitting can I apply? What kind of an accessory I can apply? मेरी air यहाँ से मुड़ के यहाँ जाएगी कैसे? बीच में क्या होना चाहिए? Fitting होना चाहिए या accessory होना चाहिए? Fitting में क्या? Elbow होना चाहिए. Elbow में कौन सा? हाँ, you have a short run elbow, you have a long run elbow, you have a metered elbow, depending upon the clearance package. Okay. So this requires an elbow. Now this elbow is nothing but it comes under fitting. Now fittings are the compulsory things that you need to use. All right, they cannot be taken as optional. I will say that the duct, no, let the air move however it is. I'm not going to apply the elbow. Chalega? Nahi chalega. Right. So that particular things, the fittings are most of all not optional. They are going to be used or required as per the need, and they're going to be compulsory. Whereas a accessory or any kind of an accessory can be optional if not required, if all the parameters are going to be applied proportionally. Now, can anyone give me one example of an accessory? There is a VCD, there is a volume control damper. There is a butterfly damper. Butterfly damper becomes optional only and only if there is a different kind of a duct. Okay. Yeah. Fire damper. Fire damper becomes important, but still is calculated in the accessories. All right. So because it is holding a damper section and dampers do not come already fabricated, usko lagana padta. All right. So any kind of a damper that you're going to deal with, it is going to have its own value. It is its own place of adjustment. Fine. Now maybe I can have a fire damper at the beginning of this duct and at the beginning of this duct. It becomes compulsory, but it is still a part of the accessory. Jo cheez compulsory hoti hai, I said it is going to be counted as a fitting. All right, the fire damper is one such ailment which is important, but yet it is an accessory. Clear? So there is a lot of accessories and fittings that is going to come across our way. First one, very, very important highlight, fire damper. And under the fire damper, have you come across the manual and the motorized one? In the designing class, you have come. What does the motorized damper contain? What the manual damper does not contain? मोटराइज्ड डैम्पर के अंदर कुछ ऐसी चीज है जो मैनुअल डैम्पर में नहीं है. क्या है वो? रीसेट स्विच फॉर रीसेटिंग व्हाट? हाँ, मोटराइज में सेंसर रहता है जिसकी वजह से इट इज गोइंग टू सेंस द हीट मोर देन हाउ मच डिग्रीज? 70 to 80 degrees nearly. All right. And in the fire damper, what is more dangerous, the smoke or the fire? Why not fire? पहले तो आग लगेगी ना, पहले smoke आएगा. पहले आग लग जाएगी तो smoke होगा. तो why when there is a fire that is more hotter is less dangerous than the smoke which is dense and more dangerous? This is the nuksan that can happen with the smoke. Basically, it is going to flow directly or cover the major part of the duct. Fire though it's going to totally burn the duct. All right. And my duct, no ducts are going to be just straight. Ducts are going to have branches. सो एक डक्ट को बचाने के चक्कर में दूसरे पूरे डक्ट्स खराब हो जाएंगे, तो दूसरे डक्ट्स खराब हो जाएंगे तो कॉस्ट मेरा बढ़ जाएगा, राइट। अगर मेन डक्ट के अंदर आग लगती है तो दैट मेन डक्ट इज ओनली गोइंग टू बी रिमूव्ड, इट इज गोइंग टू बी अगेन फैब्रिकेटेड, हैव एन acoustic insulation applied again. Only one damage is going to be suspended. The branch ducts are going to be dealing good. So for not letting that amount of denser smoke travel and disturb the other necessary margins, the measurements and materials, we need a fire damper in between. Clear? So where to apply the fire damper, how it is going to be created in SLD, in DLD, it's all going to be different. Fine. The next one you have is a volume control damper. Do you know what is a volume control damper? What does it do? It balances the volume. All right. Then there is a butterfly damper. Where does a butterfly damper first actually locate itself? कहाँ काम आता है? Flexible duct. All right. Now what is a flexible duct? Between a branch duct to the actual air terminal. ठीक है? कितने लेंथ का हो सकता है maximum? Feet. That is nearly 1.5 meters. Right. And how much in the? What if I apply a flexible duct of nearly 4 meters? 1.5 maximum है. मैंने 4 meters का लगा दिया, क्या होगा? How is the air going to pass? मेन चीज है वो टिकेगा कैसे? फ्लेक्सिबल है वो, तो कहीं भी हिल सकता है ना. हाँ, तो उसको 4 मीटर का अगर लेके छोड़ देंगे तो एक हाँ ऑटोमेटिकली इट विल ट्राई टू फॉल ऑन वन साइड. ये लाइक पहले गिरने दो, हवा बाद में दूंगा, वैसा हो जाएगा. ठीक है, तो वो अब जो सर्टेन अमाउंट ऑफ लिमिटेशन है, यू कैन ट्राई टू बिल्ड अप थिंग्स ओनली इन दैट मच. व्हाट इज सेट टू हैपन इन 1.5 meters कैन हैपन दैट मच ओनली. Fine. So after that one you have a MVCD, which is a motorized volume control damper, similarly like a VCD, which is normal, which is manual, that is motorized. Then you have some motorized smoke fire damper, which is actually nothing but a fire damper in itself, but that is having a sensor. There is NRD, non-return damper. What does the NRD or an NRV do? NRV, have you people come across? अभी pump selection है हुआ ना, वहाँ पर NRV आएगा. This is a NRD, non-return damper. So what does the term suggest you? नाम के अंदर बहुत meaning है उसके. Only one way. That thing cannot come return. It cannot come back. All right. So anything that you want to push forward only is where you have to apply the NRD. Then there is a VAV, variable air volume. What is a VAV and what is the difference between a CAV? HAP software हो गया ना सबका? VAV, CAV में क्या difference है? समझ में आया तब आप उसको अप्लाई करने वाले एक डिजाइन के अंदर, क्योंकि वो सॉफ्टवेयर है ना. देयर यू कैन ट्राई टू अंडरस्टैंड मोर कि VAV क्यों यूज कर रहे हैं, CAV क्यों यूज कर रहे हैं. तो व्हाट इज अ CAV, व्हाट इज द डिफरेंस बिटवीन अ VAV? डूइंग टेम्परेचर एंड इज इट कॉल्ड वेरिएबल. क्या चेंज हो रहा है उसमें? व्हाट इज वेरिंग? वॉल्यूम इज चेंजिंग. एंड इन CAV व्हाट इज नॉट चेंजिंग? टेम्परेचर और वॉल्यूम. Volume is not changing, temperature is being constant. All right. So that is a CAV. This is a VAV. And what is the VAV going to be attached to in the individual zone space? नहीं, यहाँ पर अब मैंने VAV box का कुछ एक वायर छोड़ा है नीचे. How do I access a temperature of one particular zone? Thermostat. Right. A thermostat has to have a sensor connection to the VAV. That is how it will try to carry out the variation. ठीक है. So there is a thermostat that is going to be a part of VAV box. And lastly, you have a sound attenuator to reduce the sound. Okay. So इसमें से जो fire damper highlighted, then you have volume control damper, then butterfly damper, then you have NRD, you have a VAV, you have a thermostat. And in point number 5, you have others where you have written T by A, which means to above. Any particular thing that is flowing above, you can write in the continuation from this level to the next level. So you can write to above. The air or duct is following above. And anything from below, or that suppose you're trying to do work on a higher level, there is same construction below also. You can write reference to below, or you can write referred by T by B. All right, these are just the shortcuts. And then you have same thing with from above or from below, where it is coming from above, from below, right? So these things are important to understand because the abbreviations are what we are actually going to deal with. Okay, most of the layers are going to be created that way. All right, now on page number 5, you have types of layouts which are nothing but general layouts. First of all, a general layout is going to consider a concept drawing, which is nothing but as per the civil plan, what you can indulge or include in a drawing. Then there is a design drawing. There can be multiple designs. One will be selected as per the commands and as per the services that are all cleanly and very nicely adopted. Then there is a shop drawing, which is used for coordination. There is an as-built drawing. This is what we know until now. These are general layouts. After that, you have an architectural layout which contains most of all the furniture layout, the ceiling layout, the tiles layout, and etc. Right? Highlight that one. Furniture layout, detail layout for toilet, kitchen, and wall, until tiles layout, and everything will have its own notes and legends. After that, you have a structural layout, which is going to give you the foundation plan, which includes the wall foundations, beams, columns. You have footings, that is detailed drawings, even the staircases, the waterproofing of your roof, and the section drawings of each and every part. That is all going to be included. Highlight again from 1, 2, 3, 4. Foundation wall, foundation plan, beams, columns, footings, waterproofing. Electrical layout is going to include most of all everything that is included in the electrical or electricity side, like lighting, the appliances connection, and your security, fire alarm, safety, and etc. So highlight the lighting layout, power layout for appliances, and power layout for HVAC. There are going to be a connection, electrical appliance connection to your HVAC systems also. Maybe for example a split AC or a cassette AC, or for that you need a different allocated electrical supply. And for the other appliances like kitchen appliances, maybe a microwave, maybe your other TV, and all these things, it requires a different kind of strategy. Then there is fire alarms, and then you have security systems like CCTV camera, laser sensors. All those are going to come under the electrical layout. The mechanical layout first includes a firefighting layout, okay, and that also majorly includes your fire extinguisher, which is the manual way of seizing the fire. Then you have the sprinkler layout, automatic sprinkler, which an automatic sensor of your heat will try to split or spang water or carbon dioxide, gas, or all those things in order to seize the fire. That is automatic. Hose reel and internal hydrant layout, for you to have the landing valves, for you to, or the fire brigades to connect the pipes from outside. Those layouts are going to include in the firefighting layout. Then you have external hydrant, that is what is set outside. It will be there inside a cabin, red color box for emergency purpose. There will be a hose reel in that. Then there's a control panel schedule at the end of or the beginning of every ground floor basement. You have a firefighting control panel system. Now it will also include notes and legends. Lastly, what we are going to deal with is the HVAC layout, and inside this firefighting layout, highlight extinguisher, sprinkler layout, hose reel and hydrant, external hydrant. Means in general you should know what will you find inside every layer that is going to be drawn. Fine. Now the HVAC layout that we are having, it will include the machine layout, HVAC or FCU, where to place, how to place, where to create, how to create. Then you have air terminal layout, selecting between diffusers and grills depending upon the false ceiling. Then you have a ducting layout, which is going to be done on SLD and DLD. It is in short called ducting on airside. Okay, highlight that one. Then you have insulation layout, that is ducting and piping for both. What are the two type of insulations we have? One inside and one outside. What is the inside one called? What is the outside one called? Thermal, and it is acoustic. Okay. You have a refrigeration pipe layout, that is at the beginning of chill water pipe. Then you have chill water piping layout, how to do the chill water pipe connection between different, from one chiller to different AHUs. Then you have installation detailed drawing, that is also going to become actually the DLD of your chill water pipe. Then you have a schematic drawing, that is nothing but how to take the front drawing, front view drawing, that is nothing but section drawing, how to understand the layering and individual calculation of height between from FFL to the direct SSL level, from finished false ceiling to structure slab level. We will be talking that in detail. And then on the next page, that is page 7, from here onwards you have only things that are meant for reading and understanding. Different types of false ceiling. We all know there is a plain, tile, and step false ceiling. So on the plain and tile false ceiling is what we are going to apply. We are going to apply the diffusers. All right, why? Because the diffuser is in the shape of a box, in a shape of a square. So that can be fixed very nicely and keenly into the tiles or the plain false ceiling. But I cannot try to do the grills in a plain false ceiling. But most of all in the market, you can see that if you have a plain false ceiling, also the grills are applied. Right. Such a good example of that one is brand factory Abbott's. All right. If you have time, you can just go and look over there. You'll be having to see that on plain false ceiling there are grills applied. Means directly on one particular portion of the wall or the false ceiling, you will be having grills there. All right. So that is actually not the correct or sustained manner to do the drafting or to do the actual design concept. So because doing that is not going to help the airflow constantly in a very nice motion. All right. तो उसके अंदर what actually happens is the more pressure and more load is going towards the machine, right? अब individual diffusers अगर होंगे तो machine is also going to work properly. There is enough amount of CFM to come out from the supply. All right. Now what happens to them is कि when you're going to calculate or purchase a big complete grill, that actually is going to initially cost you less than selecting individual diffusers. So every marketplace or everyone tries to apply or tries to purchase that and put it there. Is like हवा आने से मतलब वैसा हो जाएगा. All right, so it's better to go and follow the actual principles and actual procedures on how to do things. All right. So we have a plain false ceiling highlight, we have a grid and tile, and we have a step false ceiling. The step false ceiling will include, inshallah, the grills. All right, the supply and the ceiling grills. And you also have a note there. For a plain false ceiling, SCD and RCD are used. What is an SCD? What is an RCD? Supply ceiling diffuser, return ceiling diffuser. सप्लाई एयर डिफ्यूजर्स नहीं बोलते हैं, सप्लाई एयर डक्ट होता है. हाँ, सप्लाई एयर डक्ट रहता है, सिर्फ सप्लाई सीलिंग डिफ्यूजर ही रहना वो, क्योंकि फॉल सीलिंग के ऊपर लगने वाला है ना, लाइक दैट. अब नॉर्मली इट इज ओनली गोइंग टू थ्रो एयर. अब उसमें से नाइट्रोजन हेलोजन गैस तो नहीं आएगी, राइट? नहीं, यूजुअली मार्केट में ऐसा है मिसकंसेप्शन की बोल देते कि सप्लाई एयर डिफ्यूजर है, राइट? सप्लाई एयर ग्रिल है, ऐसा एसएजी बोल देते हैं. बट एक्चुअल नॉमेनक्लेचर ऑफ दैट इज टू डील विद द सीलिंग. जहां लगता है वहां की बात करना, like that. उसमें से flow air होने ही वाला है. All right. अब both are same only. What to use maximum is supply ceiling diffuser. And then again you have the same thing, return or supply ceiling grill, supply air grill means the same. All right. Just that to not get confusion between SAD two times. Now maybe you are going to write or create layers of two SADs. One you're going to regard as a supply air duct and the other one supply air diffuser. There can be confusion erupted over there. It can be emerged. So not to avoid that confusion, A and D दोनों को change करके CD बना दिए ceiling diffuser. आई बात समझ में? Nothing is wrong in asking or pronouncing it that way, but to avoid confusion or clash detections, it is better to go with the actual parameter, right? Now, when you're going to create the layers, we have seen I had given you a syntax earlier. What is the syntax? People remember? I gave at the time of AutoCAD classes. नहीं दिया? कि दिया? I told that there is something called dset. All right. That one. Yes, there is something called dset for you to follow while doing the drafting. It is department, service, element, and tag. Right? So this is how you have to follow the thing while actually creating the layers when dealing with the HVAC drafting. Alright, ये चीज को याद रखना है, समझना है. एक छोटा सा एग्जांपल इसका मैं फिर से दे देता हूँ. Suppose we are dealing with which department? Mechanical department. We are into which service? We are HVAC, क्योंकि mechanical में there is HVAC and firefighting. So we are dealing with HVAC. Now any element of HVAC, for example, chiller. Okay, CH. And the tag means the number of chiller in that particular drawing. Maybe it can be the 12th chiller. All right. Usually इतने chiller रख लेंगे तो फिर. All right. So with the tag you can actually place that with N. That means number. All right. So there is a D set that you have to actually follow. Department by service to element with the tag. All right. So remember all these things, and from here it means or deals the same thing, that the layers help us differentiate objects from one another. As per SMAGNA, that is Sheet Metal for Air Conditioning National Association, highlight, the standard, the layer system is as follows. All right. So this is a syntax that is followed by SMAGNA, so that we also have to follow that. M_HVAC_SCD. You can actually try to omit the tag if it is not required or if it is not a very major project. Alright, if only some kind of diffusers are going to be used, you can try to do that. You can just eliminate the tag. So where M stands for mechanical, HVAC refers to the type of service, and SCD refers to the object. And some layer representations are as such. Now from this one, I'm going to ask individually what is which one. Okay, RCD, Yogesh. RCD क्या है? Return ceiling diffuser. ठीक है. SCG रियाज. CG. Supply ceiling grill. RCG वाले क्या? Return ceiling grill. CAN. Yes. तो उसमें bracket में लिख लीजिए. CAN is going to be used for the canvas cloth. What is a canvas cloth? Where it will be? We will learn that in the canvas cloth. CANVAS. After that one, MACZ. Machine. In brackets, AHU or FCU. FD, Shravan. Fire damper. Right. Then after that one, it is written BFD. It is actually not BFD. It's only BD. Butterfly damper. वो butterfly को अलग अलग करके लिख दिए तो just eliminate F from that. It is BD. Yes, Yogesh, VAV volume. VAV is constant air volume. Then VCD will be volume control damper and VD will be which one? Shift volume damper. Volume control. Same. Nearly it is same only. चलो ठीक. हाँ वो actually MVCD आना चाहिए था last वाला. Motorized volume control damper, but it came BD. चलो, you people are aware of that. That is good enough. All right. Now from page number 8 is what I'll be doing it tomorrow because that will need to create the air terminals directly. I'll be having to show that on the CAT software. All right. We'll be start dealing with individual appliances first, like how to create both diffusers and grills, how to create the reducers, how to create the machine, how to create the flexible duct, how to create your trouser piece, how to actually apply your elbows and etc. And then we'll be going into the main project study, which is called SLD and DLD of Airside project. All right, and after that we'll be doing the chill water pipe part on the SLD and DLD using the real-time project for your experience on Dubai International Airport Terminal 1 waiting launch area. All right, we'll be doing and taking that as external reference to show you the chill water piping segment. And later on, we will end the classes with the elevation or the schematic drawing. So that's all for today with the introduction.
Now we'll continue creating the 8 terminals. Each and every, like before starting, like drawing each and every component, first of all, you need to create the layers of that particular component. Okay. So coming to the software, and enter for creating layers. Click on this for new layer, M underscore HVAC underscore. First of all, we are creating the 8 terminals. So supply ceiling diffuser. Okay. Select the required color. Green. Okay. Click to activate this layer and click close. Now we have some standards in our theory part. How to create these are the standard measurement for creating the 8 terminal diffuser. Create a rectangle of @300 by 300. Length and width will be 300 by 300. Okay, now take the offset of 50 mm multiple times inside like this. Then you need to show the 2 diagonal lines. Okay. For supply ceiling diffuser, 2 diagonals you need to show, and for return ceiling diffuser only 1 diagonal line is enough. Okay, then you need to show the arrow like this, the throw of that particular diffuser. Okay, coming here, activating the required layer, REC enter @300, 300. Now what you need to do is offset of 50, select this, type M for multiple like this. Then 2 diagonal lines. Yes, offset 50. O enter, give the distance, select the object, go for multiple or single time. Okay. Yeah, single diagonal line refers to written diffuser. Okay, intersecting two diagonal lines means supply. Now you need to give the arrow. PL enter with respect to this point. Just give the starting point. Now ortho on. Give some tail height, tail length 50. W for width. Again I'm going to give 50, ending with 0. Standard 90. Like this. Click. Okay. Now just use the array command. Select polar. Select the object. Give the center point. Number of items. Okay. Like this. This is the third time or fourth time I'm going to show you. Okay, no problem. देखिए, PL enter, give a starting point. You need to give the tail length. Okay, this will be your tail length now from this part to this part. You need to give. First of all, give the direction, then give the tail length as per your requirement. Suppose now I'm going to give as 60. Enter, then width. This will be your width from this point to this point. Okay, for that W enter. Now dimension for that particular width. Again you can give 50 as per your requirement. W enter. Standard given the 90. Head height. This will be your head now. This is your head. Clear? Any doubts? Then use the array command for showing all the remaining three sides. After creating this A terminal, whatever your component you are drawing, after finishing it, just convert into a block. Okay, this is a multi-entitled object now. See, the whole object is multi-entitled object. You need to convert it into a single entitled object. B enter, name, SCD, supply ceiling diffuser. Select the object, selecting the whole thing, enter, give the pick point. I'm selecting this, then convert to block. Okay, when you select, this will be like whole single item. Okay, next you need to create another layer for return. M underscore HVAC underscore RCD. Just change the color. Red I'm going to give. Activate this. Close. Same procedure, just arrow will be different. REC enter, click on the starting point, at the rate 300, 300. Then offset. Procedure is there in your notes. Okay. नहीं होगा. फिर जब आप फिर चेंजेस करेंगे बैठेंगे, ये तो क्रिएट SCD लेयर से हुआ, तो आप SCD लेयर्स में चेंजेस करेंगे तो इसमें भी हो जाएगा. वो प्रॉब्लम हो जाएगी. कॉपी करेंगे भी तो ये ऑब्जेक्ट कौन से लेयर में क्रिएट हुआ है, दैट विल टेक द चेंजेस. ब्लॉक का एडवांटेज क्या है, जो एक लेयर में क्रिएट करेंगे, चेंजेस पूरे लेयर्स में, जो वो एक लेयर से पर्टिकुलर जो भी ऑब्जेक्ट रिमेनिंग जहां जहां भी क्रिएट हुआ है चेंजेस हो जाएंगे. वो एडवांटेज है आपका. ठीक है. एट द रेट 300 by 300, ऑफसेट ऑफ 50. सेलेक्ट द ऑब्जेक्ट, M for multiple, inside single line. Okay, now arrow. ठीक है. Now simply move. After creating, you can just move. Now you can use array command. Okay, this is your return air diffuser, as a return ceiling diffuser, RCD. Sorry, B enter for block. RCD is the name. Selecting the object, giving the pick point, converting to a block. Okay, like this. Next we have grill. Okay, for creating the grill we have the theory here. Usually when you see from the top view, grill only face and neck will be visible. ठीक है, ऊपर से देखेंगे तो कैसा नजर आएगा? देखिए, ये ग्रिल का नेक रहेगा, ये फेस रहेगा. ठीक है, ऐसा कनेक्ट होगा जब आप ऊपर से देखेंगे तो. ये इसको फेस ऐसा कनेक्ट होगा. ठीक है, यहाँ पर देखिए, दिस इज योर फेस एंड दिस इज द नेक साइज. ठीक है, इसका डायमेंशन है 1150 mm by 5, देन 1100 mm by 50. ठीक है, सेम दो रेक्टेंगल क्रिएट करेंगे विथ रिस्पेक्ट टू दिस डायमेंशंस. देन आफ्टर क्रिएटिंग द रेक्टेंगल, सिंपली मूव योर फेस साइज टू नेक साइज विथ रिस्पेक्ट टू मिड पॉइंट. ठीक है, यहाँ पर देखेंगे सेम न्यू लेयर for m_hvac scg for supply ceiling grill. Color, okay, yellow, just to differentiate, that's it. Okay, now with respect to this, click rec, okay, at the rate 1150,5. This will be your face size. Then again rec, enter, click here 1100 by 50. This will be your neck. Now simply move with respect to this midpoint. Now attach like this. Clear? Oh, sorry. Enter. We just need to select the same color, no, for grill. Just name will be different, color will be same. See, supply ceiling grill, same color, supply ceiling diffuser, same color. Return ceiling diffuser, red color, return ceiling grill also red color. Okay? Followed? Simply again here, from here also, what you can do is arrow. Copy this. Okay, like this. White one inside. Okay. Now it's okay. This is your supply ceiling grill. One more thing. Simply copy before converting into a block. Now I'm going to convert this into a block. B, enter. Supply ceiling grill. Selecting the whole object. Giving the pick point. So see, while placing, your neck size should be like, see, suppose this is your false ceiling, no? What you need to do, you need to place. How? See, ये रहेगा ना, जो false ceiling रहेगी आपकी, ऐसा place करना है, so that your next size should not come inside. देखिए, जो false ceiling है, उसको बड़ा कर देंगे. Now what I'm going to do is, देखिए, जो आपका फेस है और जो नेक है, नेक स्टेप फॉल सीलिंग के बाहर रहना. मोस्ट ऑफ द कैंडिडेट्स क्या करते हैं, ये साइड को पिक करके यहाँ पर प्लेस कर देते हैं, तो ये होल पार्ट अंदर आ जाता है. दिस इज नॉट द करेक्ट वे. यू नीड टू प्लेस इन सच ए वे दैट योर फेस, like face size midpoint should be directly placed on the midpoint of the false ceiling. Clear? ऐसा प्लेस करना है आपको. Yeah. Next, we need to convert this into a block now. B enter, SCG, select the whole object, give the pick point. Now with respect to this, I'm going to give the pick point, convert to block. Followed? ये टॉप व्यू से देख रहे हैं. Everything is in right now top view only, no front view. अभी जैसा मैं आपको एक लेआउट बताया था, लेआउट के हिसाब से ये स्टेप फॉल सीलिंग है. स्टेप फॉल सीलिंग में आप ग्रिल प्लेस किए हुए थे वहां पर, विथ रेस्पेक्ट टू दैट मिड पॉइंट से प्लेस हुआ था जी. हाँ टॉप व्यू है. अंदर कैसे जा रही मीन्स दिस इज द फ्लो नो, डायरेक्शन ऑफ फ्लो इज दिस. ओके देखेंगे अभी यहाँ पर सेलेक्ट. ओके creating another layer for return grill. Okay, m_hvac return ceiling grill. Okay, color will be red. Click OK, activate this, close, rec enter. How much? 1150 by 5. Sorry 45 आ गया. Now simply move, join. Okay. Now M enter, select the source object. इसको पेस्ट कर देंगे. क्यों हुआ ऐसा? ओके PL एंटर. ये हो गया आपका रिटर्न. वन मोर थिंग, डायगोनल लाइंस सप्लाई में वहां पर नहीं दिए हैं. ओके, वन लाइन फॉर रिटर्न एंड टू लाइंस फॉर सप्लाई. ठीक है. आफ्टर दिस बी एंटर, RCG, convert to block like this. Okay, now you have this block. No, this is single. Okay, this is the block. What you need to do if you want to have some correction, be it is the command or else simply double click. ठीक है. SCG है लेयर, यहाँ पर सेलेक्ट कीजिए, L enter, simply draw two lines. Okay. ये आपके चेंजेस हो गए. देन क्लोज करना है, नहीं सेव करेंगे जब आ जाएगा, सेलेक्ट करेंगे, स्टिल ब्लॉक में ही रहेगा. फॉलोड. नाउ यू हैव कन्वर्टेड दिस इनटू अ ब्लॉक आल्सो. प्लेसिंग ये एग्जांपल के टाइप पे बता रहा हूं मैं आपको. सिंपली जस्ट रोटेट इट. ओके, M enter, select, copy, search for the midpoint, then place like this. When you zoom in, see here, this line is coming like this. This is your face and this is your neck. ऐसा place होगा. Followed? जी हाँ, कॉर्नर्स में नहीं, बीच में रहेगा. वो स्पेस के हिसाब से लंबा हॉल है तो कंटिन्यूस ग्रिल रहेगी. ठीक है, अगर स्पेस में एक ही ग्रिल इनफ है तो एक ही ग्रिल. बीच में इन द सेंस ऐसा वाला, या वॉल के स्टेप फॉल सीलिंग को कनेक्ट करना है या स्टेप को कनेक्ट करना है. देखिए, वर्टिकली प्लेस हो रहा तो स्लॉट डिफ्यूजर कहा जाएगा. वो इमेज देखे थे आप, वर्टिकल ऐसा जा रहा था लंबा, वो स्लॉट डिफ्यूजर रहेगा. ठीक है, वो स्पेस ज्यादा था तो उसका कंटिन्यूएशन लंबा था. ये स्पेस एक सिंगल रूम के लिए है. ठीक है, अभी जो यहाँ जो प्लेस किए हैं ग्रिल, जी जी हाँ, ये कॉर्नर पे ऐसा वाला है, ये कॉर्नर ऐसा वाला है. अरेंज कर सकते हैं. अभी यहाँ पर स्टार्टिंग लाइन क्या था, 8 टर्मिनल्स डिपेंडिंग अपॉन द आर्किटेक्चर लेआउट सेलेक्ट होंगे. फॉल सीलिंग ऐसी है तो अब यू आर नॉट सपोज टू प्लेस ग्रिल्स. आर्किटेक्चर लेआउट खराब दिखेगा. ग्रिल है तो स्टेप फॉल सीलिंग आएगी, प्लेन है तो डिफ्यूजर लगेगा, ग्रिड है तो डिफ्यूजर लगेगा. क्लियर? नेक्स्ट वी हैव creating the canvas cloth. As we have discussed, canvas cloth is placed to reduce the vibration, okay, to avoid the vibration passing from machine to duct. Okay, we have a standard measure form like procedure to draw the canvas cloth. Okay, now in this you can find machine है. यहाँ पर machine का standard dimension note कर लीजिए, 1100 by 600 by 400. एक स्टैंडर्ड मेजरमेंट, जैसा कि डिफ्यूजर का 300 by 300 था, मशीन का 1100 by 600 by 400. 400 यहाँ पर आपकी मशीन की विड्थ है. ठीक है, सॉरी हाइट है, 600 विड्थ है और 1100 लेंथ है. क्लियर? देखिए, यहाँ से यहाँ तक 1100 है, यहाँ से यहाँ तक 600 है. हाइट जो as you are viewing from the top view, so you cannot able to see the height. Height 400 है, एक standard measurement. ठीक है? Now first of all we need to again create a layer for machine. First of all, okay, m underscore hvac underscore mac for machine. Okay, now color blue. Okay, same type. Next, activating closing. As discussed, REC enter. How much? At the rate 1100 by 600, not 400. Oh, by layer another. Okay, this is your machine. Next, we need to have the canvas cloth. ठीक है, canvas cloth का procedure यहाँ पर देखिए. Draw a line, okay, or else what you can do, simply now you have drawn a rectangle with respect to a normal command rectangle. Command, it is a single line title object. What you need to do, we have two methods. Simply you can draw a line, new line from here to here, and you can take offset, or else simply explode this object. Okay, now coming to the theory, same canvas cloth layer बनाएंगे. Step 1, draw a line at the ending point of the machine. Now offset of 4-5 times. ठीक है, ending ये point से ये point तक आप line draw करेंगे, taking this offset distance as 25 mm, giving direction like this down, have the lines offset. Okay, next, now draw the vertical lines at the end of the machine joining all the offset horizontal points. ठीक है, ये points आप दे दिए, offset हो गया, ये lines आ गया आपको. Then with respect to these end points, draw the lines connecting like this. Then give the offset of 25 inside. I'll show you, you'll get it. See what you need to do. Again, draw the line. from here to here. Okay, so what I'm going to do is, again I'm going to create a new layer with respect to the canvas cloth. Okay, CAN, same color I'm going to place, activating like this. Okay, I'll enter like this, offset 25 mm, select the line, M for multiple times, give the direction, have the offset, 1 time, 2 time, 3 time, 4, 5, 6, 7. Okay, for example purpose I'm going to give as 7 times. Now what you need to do, go for line command, just join these endpoints. Why? I will tell you. This point, this point, this point, this point, like this. Again what you need to do, go for offset of 25 mm, selecting this line inside, selecting this line inside, just to give the shape, cone shape structure for canvas cloth. That's why we are going डायरेक्टली लाइन लेने के बाद क्या जो एरर आएगा वो देखिए आप. ठीक है, आफ्टर गिविंग द ऑफसेट इनसाइड व्हाट यू नीड टू डू, यू नीड टू जॉइन दिस एंड पॉइंट प्लस मिड पॉइंट, एंड पॉइंट मिड पॉइंट. शेप दे रहे हैं ना आप, अगर आप डायरेक्टली लाइन ड्रॉ कर देंगे तो आपको मिड पॉइंट सर्च नहीं करेगा, दैट विल बी द एरर. ओके, like this. Now press escape. Now simply use the trim command just to trim the lines which you don't need. Some part won't get trimmed, so simply delete that. Following? Okay, next you want to have this shape here also. Use mirror command. Mi enter, select the object, press enter, just give the reference line, mirror line. Move. Okay, set was not selected properly. Mi enter, object, press enter, ortho on, click, press enter, you'll get like this. Trim. Just to get this particular shape you are doing this much of thing. Clear? Like this. Now draw the line coming from this point. Before that, go for polar, select as angle as 45, polar on, just move your cursor in desired direction for creating the mouthpiece. We'll just read out the theory after drawing this. Okay, this is the intersection point. From this intersection point you'll be having your duct. Okay, for duct we'll be creating a new layer, M underscore HVAC underscore supply air duct, SAD. Okay, color will be this, sign color. Okay, like this. Close. Again draw a line. Okay, use polyline, because when you are using polyline it will like a single entitled object, so it will be easy for you for giving the, while going for DLD you don't need to go for the again continuation, because while exploding you need to go for each line. Okay, polyline start करेंगे तो आपको easy रहेगा. Suppose this is my duct up to here. Okay, duct width is suppose 600, so offset of 300 on both ends, this end and this. Okay, so this is your main duct. Okay, connected to your machine. Now with the help of mouthpiece. So now we are creating the mouthpiece. Simply draw a line from here to here, then trim the remaining parts like this. Even this also. Okay, this is your machine, canvas cloth, mouthpiece and duct. Followed? Simple procedure. Create the layer, go for the respective theory what you are drawing. Clear? Next what we have? Yeah. See, even we have the theory in our notes. Machine, selecting how to mirror, it is given. Creating mouthpiece is also given. First, from with respect to the middle line, stretch the line, then give the offset. How much is the duct width? Now, for example, we have taken a 600. So as per 600, 300 on each side. Clear? Next, with respect to this endpoint of that particular canvas cloth, draw a line with respect to the angle of 45 degrees. Okay, search for 45. Here, click, and with respect to this point, start a line like this. Then draw a line from this endpoint to this endpoint. Okay, stretch the line, simply trim the part just to get this figure, just to get this shape. Next, what we have? Creating a flexible duct. Okay, even we have the theory how, while discussing in the AutoCAD classes, I have told that spline line will be used for showing flexible duct. Okay, suppose this is your duct. Now this is your duct, and to this duct, here is your supply. What I'm going to do, simply supply ceiling diffuser, REC enter, or else we can simply copy. We have created already one. Simply copy this. As per the requirement, suppose this is my supply over here. So I need to connect a flexible duct to it according to the situation. Okay, how? Using spline. SPL enter, draw the line. First of all, we need to create the layer for not spline, flexible duct. Yeah, M underscore HVAC underscore FLX, simple way. Okay, FLX, as it is in the same, connecting to the same, no, like it is also a branch duct, so I'm going to give the same color for main branch. Okay, now activate, close, simply use SPL enter, give the midpoint of this diffuser. Randomly I'm just placing it over here, click. Okay, so this will be your just single line representation for flexible duct. Now you need to create in actual way how it looks like. For that purpose, you need to create an object. Okay, at the end it should look like this. Okay, for that we have a procedure. Draw a rectangle of 25 by 100. Okay, at the rate 25 by 100. Then what you can do, explode it so that it can become a multi-entitle object. Now taking this line, okay, from this line 25 above offset and 25 below offset. Okay, after giving the offset, just simply match with respect to this endpoint and midpoint like this to get this particular shape. After getting this, trim the respective part. At the end you should get like this. Then after getting like this, simply convert this into a block, and you need to give the name as per your requirement. Okay, FLX 1 2 3 4, okay, whatever it can be. Then we have a special command here, measure command. Okay, we'll see how it actually looks like. Okay, see, REC enter, how much? 25 by 25, 100. So this is your rectangle. X enter for exploding. Now again take offset, how much? 25. Select this line, 25 above and 25 below. Now simply taking this point, midpoint like this, Trim. Some portion won't get trim. Now this will not get. Okay, TR, simply select and delete, select and delete, select and delete. After getting this figure, convert this into a block. B enter FLX1. Example. Select the object, give the pick point. Now I'm going to select this one. Convert to block. Okay. Now next procedure will be using measure command, ME enter for measure. This is the new command over here. ME enter, select the line. Like on this object you want to have this particular shape. Okay, select the line, not the object. Select the line. Again, follow the command window, specify length of segment or block. We have already created block now. Simply B enter. Name of the block to enter. What we have given, FLX1. Always remember whatever you have created, that name only you need to give. FLX1 enter. नाम याद रखना पड़ेगा, इतने सारे रहते अगर ठीक है नहीं रहेगा, मल्टीपल रहेगा तो उसमें सेलेक्ट करना पड़ेगा कौन सा ऑब्जेक्ट आपको. अगर उतना भी मुश्किल हो रहा है तो आप पर्टिकुलरली ऑब्जेक्ट तो क्रिएट करके रखेंगे, ब्लॉक में भी कन्वर्ट कर चुके हैं. तो अगर मल्टीपल है तो सिंपली अभी बताएंगे. ठीक है, प्रोसीजर आप देख लीजिए. ME एंटर, स्टार्टिंग से बता रहा हूँ. ME एंटर, सेलेक्ट द लाइन. सोर्स लाइन ये रहेगी ना, इसको सेलेक्ट करना है. देन ब्लॉक बना चुके हैं. B एंटर. नेम FLX1 एंटर. अलाइनमेंट यस, बिकॉज अलाइनमेंट नहीं रहेगा तो गैप आ जाएगी. It should be according to this line, no? It should move according to this line. So alignment is required. Y enter. Length segment we have created with respect to 25. Okay? That's why we are going to give 25. Why? I'll show you. So at the end you will get like this. When you zoom in, see. Procedure क्या था? ME enter, selecting the line. ठीक है? After selecting the line, you are supposed to give the block name. ठीक है, आफ्टर गिविंग द ब्लॉक नेम व्हाट यू नीड टू डू इज फॉर अलाइनमेंट. ये देखिए तरीका, अलाइनमेंट दिए हैं तो एग्जैक्टली ये यहाँ से यहाँ प्लेस हुआ है. अलाइनमेंट नहीं देंगे तो आगे पीछे हो जाएगा. ठीक है, 25/100 था इसलिए 25 दिए, 35/100 रहता तो 35 देते थे. एज पर द कन्वीनियंसी आप जो क्रिएट किए हैं उसको उस हिसाब से देना है. ठीक है, लाइक दिस. वन मोर टाइम बताऊंगा, देखिए. हाँ, आप जो बोले थे मल्टीपल अगर ब्लॉक्स है कैसा मालूम होना. ठीक है, सिंपली क्या करिए, ब्लॉक पे क्लिक करिए, उसका नेम आ जाएगा. जितने ब्लॉक्स क्रिएट किए थे यहाँ पर वो आ जाएगा. देखिए ये नाम का ये है ना, डिस्प्ले भी करेगा, प्रीव्यू भी आएगा आपको. RCD, RCG, ACD ये रहेगा. ये आपका था ऑब्जेक्ट तो सिंपली याद रह जाएगा कि ये नाम है. क्लिक ओके. अगर ये तो एडिटिंग के पर्पज पे है. ठीक है, even you can just know the complete block details by double click. Okay, one more time. SPL ठीक है. ME enter for measure command. Procedure लिख लीजिए इसका, you don't have in your CAD notes. ME enter even आपको है ना डेटा नोट्स में. हाँ, क्लोजली ऑब्जर्व करिए, अगर कुछ उसमें अगर थियोरेटिकल पार्ट कुछ समझ नहीं आया तो आप पूछ ले सकते हैं. ME एंटर, सेलेक्ट द ऑब्जेक्ट टू मेजर. सिंपली सेलेक्ट द लाइन, देन गो फॉर द ब्लॉक. B एंटर, गिव द ब्लॉक नेम FLX1 as you have given. अलाइनमेंट यस. नाउ लाइन सेगमेंट देखिए, यहाँ पर मैं अगर 35 या 50 दूंगा, एग्जाम्पल 25 की जगह मैं 50 दे दूंगा. देखिए गैप आ गया है ना, आगे गैप. अलाइनमेंट है, अलाइनमेंट मीन्स जो लाइन है उसके हिसाब से होना है ब्लॉक, लेकिन लेंथ सेगमेंट भी जरूरी है. यहाँ लेंथ सेगमेंट कैसा डिफाइन हो रहा है, यहाँ पर एक के ऊपर एक नहीं आ रहा है, स्पेस आ जा रही है. 25 देंगे तो यहाँ से यहाँ तक 25 है, तो फिर ये नेक्स्ट लाइन भी 25 आएगा. ठीक है, यहाँ से यहाँ तक अब मेजरमेंट 50 हो गया है. जो अलाइनमेंट आप दिए हैं वो 50 है यहाँ पर. क्लियर? ME enter, select the line, let's go for block. FLX1 Y 25 like this. Clear? Okay. Next, what we have? Creating the trouser piece. Okay. What is trouser piece? You have any idea? No idea? Okay. Now we'll get an idea. Selecting the supply that line. देखिए, now your main duct is here, running from here. Suppose you have a supply over here, one here, one here. Okay, at that time you need to have the branches now. So automatically this main duct will convert into branch duct like this. If coming from here, like अगर यहाँ turn हो जाएगा तो वो branch बन जाएगा. ठीक है, उसके लिए आपको suppose दो side है ना, तो trouser piece कहा जाएगा. Single side रहे तो elbow हो जाएगा वो. ठीक है. Now if your main duct is having two divisions on either side, that's why you need to create like place the trouser. Y junction बोलेंगे. Now इसको मैं delete कर दूंगा. ठीक है. With respect to this point, I'm just drawing line with respect to the midpoint only. Okay. Suppose this, if the duct width is 600 and this branch duct width is 300, at that time what you need to do, the offset of 150 on either side like this. Okay, this will be your sizing. Duct sizing आपको calculation के हिसाब से आएगा. Okay, एक error आपको जो नहीं करना है with respect to this line, ठीक है, यहाँ तक आएगा. फिर यहाँ से आप डायरेक्टली एक यहाँ से स्टार्टिंग पॉइंट से लेकर कंटिन्यूअस लाइन नहीं दे सकते. क्यों नहीं दे सकते वो भी आपको मालूम होगा. नाउ यू आर अबाउट टू प्लेस द ट्राउजर पीस ओवर हियर. ओके, 600 is this duct width and 300 is this duct width. So now we have two types of elbows. One is short run and another one is long run. Okay, short run and long run. The procedure, we have a standard formula for going for short run and long run. Okay, for long run देखिए यहाँ पे जब कर्व की बात हो रही है, ठीक है, ये शार्प एंड्स है, you have the sharp ends here, so you need to convert this into sharp ends, this sharp ends into curve ends. Okay, for that you need to give the fillet radius. For short run, W by 4, total width of the duct by 4 for short run, W by 2 for long run. Highlight this point. Okay, highlight this important one. Here elbow also according to the availability of the space. ठीक है, normally long run means you'll have a long curve. ठीक है, short run में आपको आपका कर्व छोटा रहेगा, लेकिन शॉर्ट रन में आपको फ्रिक्शन लॉस होने की ज्यादा चांसेस है. लॉन्ग रन में स्मूथ होगा, स्पेस ज्यादा रहेगी, कर्व ज्यादा रहेगी तो फ्रिक्शन लॉस कम होगा. शॉर्ट रन में कर्व छोटा रहेगा, उस हिसाब से आपको फ्रिक्शन लॉस ज्यादा होगा. ओके, अकॉर्डिंग टू द अवेलेबिलिटी ऑफ द स्पेस यू नीड टू सेलेक्ट योर एल्बो. ओके, यहाँ पर एल्बो अब कंसीडर करिए, ये प्रोजेक्ट के लिए एग्जांपल स्पेस ज्यादा है, लॉन्ग रन करेंगे. ठीक है, फिलेट रेडियस F एंटर, R एंटर. फॉर्मूला क्या है लॉन्ग रन के लिए? W by 2. W कौन सी लेना है, 600 लेना है या 300 लेना है? डक साइज. तो यहाँ पर हो गया आपका W by 2, 600 by 2, that gives you 300. ठीक है, simply select this part and this part, you'll get a curve. Okay, इसको डिलीट कर देंगे. 1 minute. जी जी, हाँ वो आएगा भी, नेक्स्ट लेवल वही है. आपको आपका डाउट क्लियर हो जाएगा. नाउ दिस वी हैव टेकन द लॉन्ग रन. ठीक है, यहाँ पर शॉर्ट रन देंगे, दो भी एग्जाम्पल कवर हो जाएंगे, ठीक है। F एंटर, R एंटर, 600 इज द डक्ट विड्थ, 600 by 4 that gives you 150, 150 select, ओके। सी कंपेयर कर लीजिए, यहाँ पर एक लॉन्ग रन है, एक शॉर्ट रन है, उसका कर्व देखिए, इसका कर्व देखिए, यहाँ पर फ्रिक्शन लॉस होने के चांसेस ज्यादा रहेंगे, यहाँ पर कम रहेंगे क्योंकि कर्व ज्यादा है या कर्व छोटा है, ठीक है। ये आपका एल्बो आ गया, कर्व दे दिया। नाउ यू नीड टू मैच दिस कर्व, नो, at the time what you need to do, simply you need to give the offset, okay, offset of this arc with respect to this particular duct width, ठीक है। यहाँ पर 600 है, यहाँ पर 300 है, यहाँ पर 300 है, ठीक है। आपको ये duct width से मैच होना है, for that purpose simply go for offset of 300, click on this arc, then give, here also same width है ना, ठीक है, सेम सेलेक्ट करेंगे, सेम दे देंगे, फॉलोड। नाउ ड्रॉ द लाइन जस्ट टू शो द कनेक्शन। ये ऐसा क्यों आ रहा है, क्योंकि एक ही उसमें आप शॉर्ट रन भी ले लिए, लॉन्ग रन भी ले लिए, इसलिए ऐसा आ रहा है। नाउ जस्ट ट्रिम द रेस्पेक्टिव पोर्शन विच यू डोंट नीड, like this, clear? This is your long run elbow and this is your short run elbow. ये तो elbow का concept हो गया। Okay, one more thing what you can do is here, simply by deleting this, here F enter, R enter of 300 long run, ठीक है। Again F enter, R enter of 300, selecting this, here you'll get नहीं, कुछ एरर हो रहा है, सिंपली डिलीट, विल जस्ट, नहीं मिरर नहीं, फिर से बता देंगे, ठीक है। ये आपका नो प्रॉब्लम, लाइन ऊपर है, एक ही उसमें आप दोनों कर लेंगे, मतलब एक ही करेंगे, एट ए टाइम एक करेंगे। F एंटर, R एंटर ऑफ 300, फर्स्ट लॉन्ग रन जाएंगे, ठीक है। सेलेक्ट दिस, सेलेक्ट दिस, ये हो गया आपका लॉन्ग रन एल्बो, ठीक है। ट्राउजर पीस का विजिबिलिटी चेंज हो रहा है क्योंकि अब बिगिन कर रहे हैं ना, तो आपको अंडरस्टैंडिंग ज्यादा होना चाहिए इसकी। F एंटर, R एंटर, 300 हो गया, देन ऑफसेट 300, सेलेक्ट दिस, select this, then draw the line। इवन आप जब एल्बो भी ड्रॉ कर रहे हैं, आपको ऐसा लाइन देना होगा, ये आपका एल्बो रिप्रेजेंटेशन रहेगा। नॉट ट्रिम द पार्ट्स, TR सिंगल एंटर, सेलेक्ट दिस बाउंड्री एंड दिस बाउंड्री, लाइक दिस, ठीक है। अगेन दिस बाउंड्री, दिस बाउंड्री, ये हो गया ट्राउजर पीस, ठीक है। जो इक्वल डक्ट विड्थ है, 300 इधर भी है, 300 इधर भी है, तो ऐसा लगेगा, ठीक है। अगर जब शॉर्ट रन है, ठीक है, अगर यहाँ पर आपको डक्ट विड्थ चेंज हो रहे हैं, यहाँ पर 300 की जगह 400 है, एट द टाइम यू कैन यूज शॉर्ट रन एल्बो, ठीक है। फॉलो, कुछ डाउट्स है? ओके, इवन यू हैव द प्रोसीजर इन योर नोट्स, सो at the end it looks like this, okay। Now we have types of elbows. There are basically three types of elbows: short run elbow, long run elbow and tapered metered elbow, tapered or metered elbow. Procedure is same. Suppose ये आपका duct width है, देखिए, now you need to go for the, अगर single side curve हो रहा है, at that time you will be placing elbow, नॉर्मल प्रोसीजर शॉर्ट रन एंड लॉन्ग रन. शॉर्ट रन के लिए W/4, लॉन्ग रन के लिए W/2. एंड मीटर्ड एंड टेपर्ड एल्बो जो रहेगा बहुत रेयरली यूज होगा. वो भी कैसा रहेगा देखेंगे अभी. इसका प्रोसीजर देख लीजिए यहाँ पर. फॉर शॉर्ट रन एल्बो रेडियस इज 6 एज स्टैंडर्ड, दैट मीन्स 150. क्या करना है आपको? F enter, R enter, simply click on this part and this part, you will get the curve. Then offset will be the duct width. Always remember. ठीक है, duct width जो है वो आपकी offset रहेगी. नेक्स्ट सेम लॉन्ग रन के लिए भी सेम है. W/2 कॉन्सेप्ट है. जो भी आपका रेस्पेक्टिव डक्ट विड्थ है बाय 2 कर आपको फिलेट रेडियस देना है. देन अकॉर्डिंग टू द डक्ट विड्थ यू नीड टू गिव द ऑफसेट. यू विल गेट द कर्व लाइक दिस. नाउ मीटर्ड एल्बो इज, ये आप साइड पे ही प्रिपेयर करेंगे. कैसा करेंगे? जब आपका डक्ट रहेगा उसमें आप जस्ट टर्निंग वेन्स लगाएंगे. नो नीड टू प्लेस सेपरेट एल्बो. जो डक्ट पास हो रहा है उसमें ही आप टर्निंग वेन्स ऐड कर देंगे. कैसा रहेंगे? नॉर्मल जस्ट आप हवा को, जो एयर को एक पासेज होने का एक डायरेक्शन देंगे, फ्लो बताने के. ठीक है, स्ट्रेट आएगी हवा, कर्व्स रहेंगे तो मुड़ जाएगी विदाउट एनी फ्रिक्शन लॉस. मतलब होगा इसमें भी, क्योंकि ये फिटिंग कंसीडर होगा, इसमें भी फ्रिक्शन लॉस होगा, लेकिन 100% नहीं होगा. इसका स्टैंडर्ड के हिसाब से जब आप कैलकुलेट करेंगे, ठीक है, उस हिसाब से कितना फ्रिक्शन लॉस होगा वो आपको आ जाएगा. क्लियर? कैसा कनेक्ट होता वहीं साइड पे ही प्रिपेयर करेंगे. ऐसा नहीं कि कोई मैन्युफैक्चरर है जैसा कि कंपनी से जो हर चीज नॉर्मली डक्ट जैसा मूव हो रहा है ना, उसमें टर्निंग वेन्स लगाकर फिट कर देंगे. जस्ट विल ऐड टर्निंग वेन्स ऑन द साइड इटसेल्फ. फ्लो का डायरेक्शन बताएंगे जस्ट. ठीक है, फ्रिक्शन लॉस लॉन्ग रन में, फिर उससे थोड़ा कम शॉर्ट रन में. मीटर्ड एल्बो तो बहुत कम यूज होता उस हिसाब से, क्योंकि उसमें इवन टर्निंग वेन्स तो 100% प्रिसाइज एकदम एक्यूरेसी लेवल नहीं रहता, उसमें ज्यादा होगा ही होगा. उससे थोड़ा ऊपर आएंगे तो शॉर्ट रन, उससे और ऊपर आएंगे तो लॉन्ग रन. क्लियर? प्रोसीजर बताऊं या लॉन्ग रन का शॉर्ट रन का सॉफ्टवेयर में, या ओके है? देख लीजिए. यूजिंग द PL लाइन. ओके, सपोज 600 डक्ट विड्थ है. देखिए ये आपका मेन डक्ट है. ठीक है, यू हैव द टर्निंग ओवर हियर. नाउ यू आर सपोज टू प्लेस द एल्बोस. F enter, R enter. First decide which elbow you want to place. Either it be long run or short run. Suppose first we'll go for the long run. What is the concept formula? W/2. Duct width is 600. Simply divide that by 2. F enter, R enter, 300. Because W/2. Simply select this. You'll have the curve. Now after having the curve, go for offset. Total duct width is how much? 600. Select the arc, give the offset. Now again draw the line with this. Okay, now trim. This will be your long run elbow. Followed. Again, suppose if this is your duct, offset of 600 same, coming here, and now you are about to place the short run elbow. F enter, R enter, give as W/4 gives you 150. Whatever it may be the duct width. 800 लेंगे तो आपको W/4 आपको 200 आएगा. Simply select the, ठीक है, ये आ गया आपको कर्व. Then offset 600. Select the arc like this. Then draw the line. Trim. देखिए फर्क देख लीजिए यहाँ पर. एंटर. शॉर्ट रन और लॉन्ग रन में कितना फर्क आ गया है? कर्व ज्यादा है, फ्रिक्शन लॉस भी कम होगा, कर्व छोटा है, फ्रिक्शन लॉस ज्यादा होगा. This is your procedure for long run and short run elbow. Any doubts? Okay. We have types of reducers. Okay. What is reducer? Suppose you are having a duct of 600 mm or 1000 mm after some supply, ठीक है, on either sides, दो तरफ supply हो चुका, then CFM कम होगा, so you are not supposed to run the same duct width, ठीक है. CFM supply हो चुका, ठीक है, उस हिसाब से duct size आप पहले ले चुके, CFM कम होगा तो duct width भी कम करना चाहिए, ठीक है. अगर duct width कम नहीं करेंगे तो ऐसा होगा कि एक्यूरेटली नहीं जाएगा, ठीक है. उसको जितना रिक्वायरमेंट है आप उसे मोर देन रिक्वायरमेंट दे रहे हैं, तो वो सही लेवल में नहीं है और एक्सेप्टेबल भी नहीं है. एट द टाइम यू नीड टू प्लेस द रेड्यूसर. डक्ट विड्थ भी चेंज करना है तो डक्ट विड्थ चेंज करेंगे. 600 हो गया था, 400 हो रहा है, तो कैसा कनेक्ट करेंगे? विद रिस्पेक्ट टू द रेड्यूसर. नाउ दिस विल बी लाइक फिटिंग, इंपॉर्टेंट फिटिंग इन बिटवीन द टू डक्ट्स ऑफ डिफरेंट साइजेस, ठीक है. वो कैसा क्रिएट करेंगे? Normally we have two types of reducer, eccentric and concentric. Concentric means two sides taping, taper on two sides, दो साइड से कर्व रहेगा. Eccentric means single side taping रहेगी. वो भी देख लें आप इमेज. देखिए, टेपर ऑन सिंगल साइड, इसको टेपर बोलेंगे. जो कर्व है ना, ये सिंगल साइड है. यहाँ पर जो भी विड्थ है यहाँ पर रेड्यूस हो गया है, तो दिस विल बी योर रेड्यूसर विथ वन साइड टेपिंग, दैट इज एसेंट्रिक रेड्यूसर, ठीक है. नाउ वी हैव ए प्रोसीजर हाउ टू ड्रॉ क्रिएटिंग ए कॉन्सेंट्रिक रेड्यूसर. नाउ important thing, highlight this, 300, 450, 600, 900, we'll discuss what is this. Okay, now the concentric reducer is used when supply is provided on both sides. Concentric reducer कब यूज करेंगे? सप्लाई जब both side है, यहाँ पर भी है यहाँ पर भी है, तो आप concentric reducer यूज करना होगा आपको. Let us suppose that duct width is decreasing. After some supply, the duct width is decreasing. At the end of the duct, create an offset with standard measurement of 300, 450, 600, 900. वो कैसा होगा? देखिए, ये आपका duct है. आफ्टर सम सप्लाई यहाँ पर रिड्यूस होना है, तो एक लाइन ड्रॉ करेंगे. ओके, विथ रेस्पेक्ट टू दिस लाइन यू नीड टू टेक ऑफसेट मिनिमम 300, मिनिमम 300, 1 फीट तो रहना चाहिए, मिनिमम 300 देना होगा. ये इंपॉर्टेंट पॉइंट है, इवन आपको इंटरव्यू पॉइंट ऑफ व्यू से भी पूछ सकता, ठीक है. यहाँ ये लाइन से आप 300 देना होगा ये डायरेक्शन में. देन विथ रेस्पेक्ट टू द मिड पॉइंट, ठीक है, स्ट्रेच कर लेंगे मिड पॉइंट. नाउ द न्यू ऑफसेट, जो भी डक्ट का विड्थ है, सपोज यहाँ 1000 है, ठीक है, 1000 के बाद कुछ रिड्यूस हो रहा है, 800 हो रहा है, तो यू नीड टू टेक द विथ रेस्पेक्ट टू दिस मिड line, center line, offset of 400 above and 400 below. So you will get this size. Then simply draw the line from this point to this point. This will be like, ये आपकी duct end है, ठीक है. यहाँ से offset of जो 300 लिए, ये लाइन से 300 वाली लाइन तक, ठीक है, जो ऑफसेट 300 लिए वहां तक टेपिंग करेंगे, टेपर ड्रॉ करेंगे बोथ साइड्स, देन ट्रिम कर देंगे तो आपको ऐसा शेप आएगा. ओके, सपोज यहां पर कैसा है, दो साइड सप्लाई है, दैट्स व्हाई वी आर यूजिंग कॉन्सेंट्रिक रेड्यूसर. सिंगल साइड रहेगा तो सिंपली एसेंट्रिक रेड्यूसर यूज करेंगे, ठीक है. ऐसा रहेगा आपका एसेंट्रिक रेड्यूसर. एट द एंड एक तरफ टेपिंग रहेगी, टेपर रहेगा. ओके, नाउ what we'll do, we'll just draw the line using polyline. This will be the midpoint, ठीक है. Now what I'm going to do is, suppose ये टू साइड सप्लाई हो चुका, ठीक है, यहाँ कनेक्शंस हो गया, लेकिन यहाँ पर मुझे फिर और दो कनेक्शंस है. Now I am going to have the branches over here. So यहाँ पर होने के बाद मैं एक लाइन ड्रॉ करूंगा यहाँ से यहाँ तक, ठीक है. Now here comes the standard value, offset of how much, minimum 300 लेना होगा. Selecting this like this, ठीक है, यहाँ आ गया. Now new duct length डक्ट विड्थ ऑफसेट, सपोज ये 600 था, यहाँ पर 400 हो गया, ठीक है, 400 हो गया, हो जाने के बाद मैं 200 दूंगा क्योंकि ऑन आइदर साइड आई एम गिविंग ना, हो गया। ये आपकी न्यू डक्ट विड्थ है, ये आपकी ओल्ड डक्ट विड्थ है। सो यहां से सिंपली जॉइन दिस पॉइंट्स। जी 200 दिया टू गेट 400, 200 देंगे ऑफ साइड ऊपर, दो 200 ऊपर तो 200 नीचे रहेगा तो टोटल 400 आएगा, ठीक है। नाउ यू हैव जस्ट रिड्यूस्ड योर डक्ट फ्रॉम 600 to 400. Okay, you need to maintain 300 minimum. You can give 450, 600, 900 respectively. ठीक है, देखिए देखिए कैलकुलेशन नहीं, नॉर्मल कॉन्सेप्ट है। सपोज ये एक रूम हो गया, ठीक है, इन बिटवीन यू हैव पार्टीशन, देन अगेन यू आर हैविंग अनदर रूम, ठीक है। यहाँ पर सप्लाई हो चुका, यहाँ से आ रहा है आपका, यहाँ दो रिड्यूसर डिफ्यूजर लग चुके, यहाँ सप्लाई हो चुका, वो नेक्स्ट रूम में पास होना है, तो इट्स अ कॉमन कॉन्सेप्ट दैट यू नीड टू प्लेस द रिड्यूसर, ठीक है। वो कैसा करेंगे, नहीं दो एग्जाम्पल दिया मैं कि बीच में पार्टीशन है, इवन पार्टीशन नहीं भी रहा तो यू नीड टू गो फॉर द रिड्यूसर। हाँ लगेगा, रूम रहो या नहीं रहो, इवन ए बिग हॉल भी है तो जहां भी CFM लॉस हो रहा है तो वहां से रिड्यूसर लगते जाएगा। हाँ स्टार्टिंग से 1000 यूनिफॉर्म नहीं होगा, वो एक्सेप्टेबल नहीं है, क्योंकि ऐसा हो जाएगा, हाँ एक्यूरेट नहीं होगा। मशीन का प्रेशर बढ़ जाता, फैन सिलेक्शन, मशीन सिलेक्शन जब पढ़ेंगे ना आप, तो उसमें क्या होगा, नॉर्मली आप ऐसा डिजाइन करेंगे, मशीन तो आएगी, उसको जो टनेज है वो सप्लाई करना है, उसके हिसाब से डक्ट विड्थ भी एक पैरामीटर है जो उसको सूटेबल रहना चाहिए। सपोज उसकी जैसा आप बोल रहे हैं कि सिंगल मेंटेन करेंगे, एक ही विड्थ मेंटेन करते हुए पूरा एंड तक जाएंगे, वो कंसिडर नहीं, हाइट सेम रहेगी, डक्ट हाइट विल रिमेन द सेम फ्रॉम स्टार्टिंग टू एंड टिल द लास्ट डिफ्यूजर, बट डक्ट विड्थ विल वेरी फ्रॉम ईच डिफ्यूजर्स, ठीक है, ऐसा होगा। कौन सा भी अगर पार्टीशन रहो या ना रहो, इवन एक बिग हॉल है, सपोज यू हैव सप्लाई ऑन आइदर साइड, सो दैट्स व्हाई यू नीड टू प्लेस द, क्या प्लेस करना होगा आपको, रिड्यूसर। कॉन्सेप्ट समझ गए आप, जहां भी एंड हो रहा है वहां से एक लाइन ड्रॉ करेंगे, ऑफसेट देना होगा मिनिमम 300, 450, 600, 900 देने के बाद न्यू डक्ट विड्थ मेंशन कर देंगे, टेपर्स ड्रॉ कर देंगे, ठीक है। नाउ नेक्स्ट विल जस्ट डिलीट दिस, ओके। सपोज कंटिन्यूशन है यहाँ पर, ओके देखिए यहाँ भी सप्लाई हो चुका, एग्जाम्पल यहाँ ब्रांच कनेक्ट हो गया, यहाँ ब्रांच कनेक्ट हो गया। नाउ अगेन यू नीड टू हैव योर रिड्यूसर हियर, विच टाइप ऑफ रिड्यूसर, सी द difference. Previously we were placing a concentric reducer because we were having two side supply. If we are having one side supply, here you need to place the eccentric reducer. See, यहाँ पर सप्लाई हो चुका, simply draw a line यहाँ पर, ठीक है, ये हो चुका आपका। नाउ इसका कॉन्सेप्ट क्या रहेगा, प्रीवियसली कॉन्सेंट्रिक रिड्यूसर के लिए मिड पॉइंट स्ट्रेच करके ऑफसेट दे रहे थे, ठीक है, डबल साइड टेपर आ रहा था। यहाँ पर 600, 400, सपोज ये 300 है, व्हाट आई विल डू, सिंपली आई विल स्ट्रेच द लाइन लाइक दिस, यहां से आता है, ठीक है। नेक्स्ट डायरेक्टली आई विल गिव द ऑफसेट ऑफ 300 लाइक दिस, ओके। Now, with respect to this line, I need to have the offset. How much? Minimum? नहीं समझे? पूरे बोलिए. समझे तो समझे, नहीं समझे तो नहीं समझे. ठीक है, देखिए. Previously we were having two side supply on either sides. Okay, one side here and one side here. So that's why after supply we have just placed the reducer, concentric reducer. Okay, for that we have simply drawn the line and given the offset as 300. We can also give 450 also, 600 also, 900 also. Clear this point? Yeah. So again we were having the two side supply. Okay, so that's why from this midpoint I have just given the offset of this new duct. 600 was the previous duct width. Now 1 minute. Yeah, it's recording. Yes. Previously we have given the 600 as duct width. Now duct width is changed to 400. Selecting this line and giving the offset of 200 on both sides of above and below, you will get the new duct width as 400. Clear? Now you are having supply single side. So that's why I'm directly stretching this line and giving the offset from here, not taking the midpoint. Clear? From this, considering this as the duct end, okay, simply give the offset of, now we are going to give as 450, because above 300 we have 450, 600 and 900. Okay, 450 given, selecting the line like this. Now simply draw the line from here to here, then trim. This will be your eccentric reducer. Here important note is there in your theory. Where it is? It's not given. Okay, you can write down. Suppose why we are using eccentric reducer, because we are having only single side supply. If your supply is above, your taper should be below. This is the important point. Supply आपका ऊपर है तो taper नीचे आना चाहिए. ये taper line है ना? This is the important thing. If your supply is below, then your taper should be above. Followed? If supply is above, taper should be downwards. Okay? If vice versa, if your supply is below, your taper should be above. With respect to eccentric reducer, this is the important note that you need to remember. Okay? Okay, we'll end today's session here. It will be like a burden for you. Practice करिए जितना भी अब तक किए हैं. जी? हाँ, बोला ना अभी. लिखिए, नोट लिखिए. If supply is above, comma, taper should be below. Taper line should be below. If supply is above, taper should be below. Vice versa, in bracket you can, if below means you can give above. So till now, what we have discussed, just we have discussed 8 terminals: diffusers, grills, flexible duct, machine, canvas cloth, mouthpiece, trouser piece, elbows, and concentric and eccentric reducers.
Right. तो आफ्टर जो हम लोग ने लास्ट देखा था कि द मशीन, देन देयर इज अ कैनवस क्लॉथ के बाद माउथपीस के बाद अपना मेन डक्ट. अब मेन डक्ट के बाद से जो अपना कंटिन्यूएशन होगा, दैट विल बी हाउ टू डिवाइड द ब्रांच डक्ट्स. तो इनिशियल स्टेज पे यू कैन कनेक्ट द हाउ टू कनेक्ट द मेन डक्ट विद द ब्रांच डक्ट इज व्हाट वी हैव टू डिसाइड. All right. So I had asked a question earlier कि अपने पास एक fittings and accessories में क्या difference होता है? Initially when we were talking about abbreviations and etc. on page number 3. Right. So यहाँ that time we understood that fittings के अंदर एक ऐसा fitting भी होता है called an elbow. All right. So अब दो different ducts को जिसका functionality अलग है. One is going to be the main duct that is attached to the machine. Air is following inside that. उसमें हवा आएगी तो दूसरी जगहों पे it is going to spread. Right. So now in that situation, for a branch duct to be attached to the main duct, we require a fitting, right? That particular fitting is going to be an elbow. Now when we are going to talk and deal about elbow, उसमें भी अलग किस्म के elbows. Now how to decide on which elbow to provide is what you will understand on the designing side. Depending upon your project strategy, depending upon the site clearance, depending upon the landscape clearance, depending upon the fitting placement, ये सारी चीजें are going to come under the designing parameter on how you have to decide. Here we are going to deal with which one suits the best in attaching a main duct and a branch duct. All right. So very quickly, I'm going to create a layer. I'll just name it. We already know how the format goes for layers. I'm just taking it in a normal way. I'm just typing trouser piece, simple terms. All right. I'll draw that with magenta. Keeping that one currently, that is the only layer I require. And I'm going to draw a duct again, following the same example, keeping my ortho on. The length is not important to us. We are dealing with W into H, that is width into height when it comes to the duct. Okay? So taking 1000 mm of length, all right, and the actual width of my trouser piece I'm going to maintain is 600 by 300. Okay, so for 600 I need to take an offset of 300 individually. Total width अगर मुझे 600 maintain करना है तो I have to take it off 300 by 300. Is it clear? And after that one, what I'm going to now do is we have to understand key whenever we are going to create a trouser piece. First of all, why it is going to be called as a trouser piece. All right, it looks like the shape of a trouser. That's why. That is the only difference. And the air that is going to flow or follow from the main duct to the branch duct is going to be in that particular shape. तो एक ट्राउजर के शेप के जैसा वो जाएगा with two different legs and one complete body ahead. That is why it also looks like an inverted alphabet T. Okay, so whenever you're going to draw the trouser piece or connect two different branches, we do not have to make one complete line like this. एक पूरी line आप इसमें से इस तरह से draw नहीं कर सकते to call this as this is one branch and this is another branch. Right, we require a line that divides into two different halves. So we cannot draw a line that is continuous. We need to draw from the center line one line extending to some corner individually, and from the same point of intersection another line on the other end. इस तरीके से. Now if I'm going to maintain the main duct at suppose 600 by 300, I should maintain the branch duct much lesser width to the one of the main duct. ये भी 600 by 600, ये भी 600 by 600 अगर रहेगा तो the flow of motion, the distribution of air and the fittings and everything is going to be a little limited. Okay, so the main duct is what it is main, मतलब consciously ये मालूम होना चाहिए कि वो सबसे बड़ा duct है पूरे project में, उसके जैसा कोई दूसरा नहीं. ठीक है, so the branch ducts that we are going to maintain, I am going to cut short that size to 300 by 300 for example. अब पूरी duct की width अगर 300 होगी तो उसका offset कितना होगा? 150. Take offset of 150. From this end, make the changes that way, and the side and the side. I'm just going to stretch this a little bit more so that I get a little larger part. Okay, so now from here you can see this belongs to the same lines until here. ये तीन एक हिस्सा है, and these three are one of them. All right, so अब यहाँ पर in this particular session we require a turn that is coming from the main duct flowing only into the branch duct, and from the main duct again flowing only into the branch duct on the right hand side and left hand side. So the air is going to be divided into two different corners, into two different directions and orientations. Right, अब यहाँ पर how to do that one? For us to apply that, we should have the knowledge on selection of fittings. So normally when you're going to talk about the elbow के अंदर और कितने किस्म के elbows? You might have come across that in the designing class. You're currently in module 2 or module 3? Module 2. Which part and portion is going on? Dampers. वहां तक हुआ है. तो उसमें elbows का session हो गया. राइट तो कितने टाइप के एल्बोज है? एक शॉर्ट रन, एक लॉन्ग रन एंड मीटर्ड, राइट। तो शॉर्ट रन एल्बो को फाइंड करने के लिए फॉर्मूला क्या जनरेट होता है? व्हाट शुड बी द रेडियस टू अप्लाई अ शॉर्ट रन एल्बो? अब शॉर्ट रन एल्बो एंड लॉन्ग रन एल्बो सिर्फ दिखने में ही अलग नहीं, उनके पैरामीटर्स एंड फिजिकल क्वांटिटी भी अलग होना चाहिए ना। तो टू डिफाइन द शॉर्ट रन एल्बो द रेडियस इज गोइंग टू बी डिफाइंड डिफरेंटली, इट इज गोइंग टू बी डिफरेंट फॉर अ लॉन्ग रन एल्बो। तो वो आइडिया मालूम रहना चाहिए पहले से। आर बाई नो, आर इटसेल्फ कैन नॉट बी आर बाई 2। हाँ तो जो एल्बो है आर इज इक्वल्स टू समथिंग शुड बी बाई 2, बट ओनली आई एम आस्किंग इन टर्म्स ऑफ शॉर्ट रन या लॉन्ग रन। तो शॉर्ट रन एल्बो का ही मुझे बताइए। चलो वी विल टेक द एग्जांपल ऑफ, ओके चलो अमंग शॉर्ट रन, लॉन्ग रन, मीटर्ड एल्बो, व्हिच वन इज गोइंग टू बी कॉल्ड एज अ स्टैंडर्ड एल्बो? नो, आर इज इक्वल टू डब्ल्यू बाई 2 कौन से एल्बो का है ये? चेक अगेन, देख देख के भी बोलिए, कोई बात नहीं, एक छोटा सा रिवीजन हो जाएगा आप लोगों के लिए, सो दैट यू विल अंडरस्टैंड कि उसका इंपॉर्टेंस क्या है। नोट्स में भी आपने देख लीजिए, ड्राफ्टिंग नोट्स में भी होगा। लॉन्ग रन का है, हाँ W/4 रहेगा शॉर्ट रन एल्बो के लिए। तो अब तीनों किस्म के एल्बोज में से विच वन इज गोइंग टू बी कॉल्ड अ स्टैंडर्ड एल्बो? नाउ यू नो द फॉर्मूला आल्सो, तो हाउ डू यू अंडरस्टैंड कि स्टैंडर्ड एल्बो मतलब मोस्ट ऑफ द टाइम विच वन इज गोइंग टू बी सिक्योरली यूज्ड? नहीं, आर को डिफाइन करने के लिए अपने को विड्थ चाहिए डक्ट का, एंड उसमें भी आपको क्या है, यहाँ पर आप दो डिफरेंट टाइप ऑफ डक्ट्स है, मेन डक्ट है, ब्रांच डक्ट है, राइट। हाउ यू विल बी एबल टू डिसाइन कि कौन से डक्ट के विड्थ का हाफ लेना है? आप कनेक्ट तो एक मेन डक्ट से ब्रांच डक्ट को करने वाले हैं, राइट। तो आपके हिसाब से, तो 3 people are there in class, आप लोगों के हिसाब से यू टेल मी के मेन डक्ट का रेडियस आई हैव टू कंसीडर, मतलब मेन डक्ट का विड्थ आई हैव टू कंसीडर टू जनरेट द रेडियस, और आई हैव टू कंसीडर द विड्थ ऑफ द ब्रांच डक्ट व्हिच इज 300 टू कंसीडर द शॉर्ट रन एल्बो? कौन से चीज का मुझे विड्थ कंसीडर करना चाहिए, मेन डक्ट का या ब्रांच डक्ट का, और क्यों? एक का विड्थ अपने को मालूम है 600 है, ब्रांच का मालूम है कि 300 है, राइट। एंड आर इज इक्वल्स टू W/4, ऑलरेडी वी नो इट इज टू अरेंज द शॉर्ट रन एल्बो, ठीक है। तो शॉर्ट रन एल्बो इज ऑल्सो गोइंग टू बी कॉल्ड एज योर स्टैंडर्ड एल्बो फर्स्टली, ठीक है। मोस्ट ऑफ द प्रोजेक्ट, मोस्ट ऑफ द टाइम्स we are going to define and select the short run elbow, usually available in 90-degree format to attach two different ducts, ठीक है। अब उसमें से R is equals to W/4 जब आप यूटिलाइज करने वाले हैं, तो W here is going to be always remember the size of your main duct, and we are going to take 600. Now divided by 4, how much is going to be the answer? 150. If suppose I had considered 300, that is the width of my branch duct, so 300 by 4 would become 75, right? So a turn of 75 is bigger or a turn of 150 is bigger? एक जो turn होगा, radius 150 is larger, right? Like numerically it is a larger number. तो 150 का turn हम लोग को इसलिए लेना है because we also have to consider the peak amount of turning to be taken place. मे भी नहीं लगता होगा 150, नहीं पता, वो सिर्फ 100 mm की रेडियस भी काफी है, बट 75 अगर ले लिए तो 100 mm तक रीच नहीं कर सकते ना, अंडर हो जाएगा, राइट। तो ओवर के हिसाब से इफ यू आर गोइंग टू कंसीडर देयर इज नो प्रॉब्लम, ऑलराइट। 100 तक मिनिमम, चलो एक कैपेसिटी के हिसाब से, थंब रूल के हिसाब से देखे तो चल जाएगा, एनालाइज कर लेंगे। कम से कम जो हमको वेरीफाई हो रहा है, थियोरेटिकल वैल्यू आ रही है, इट हैज टू बी मोर देन दैट ओनली, इट कैन नॉट बी अंडर दैट, थंब रूल विल आल्सो बी नेग्लिफाइड, ऑलराइट। सो we are going to consider as per the example, यहाँ पर आप suppose मेरा मेन डक्ट 400 mm का ही होता, डायरेक्टली मैं R would become 100, 400 divided by 4 would become 100, तो हमको 100 कंसीडर करते हुए चलना होता, right? Since the example here is going to be 600 on division by 4, the R, that is radius, is coming as 150. Now what we need to do is we have to consider that continuous curve and arc at this complete position connecting the main duct with the branch duct. So I am going to make that a fillet radius. F enter, R enter 150. Select this part and select this part. Now you can see there comes one particular turn. Same thing is to apply on the other end. Use a space bar to continue the same values. Now did you understand why we should not consider to draw one complete line? अगर एक ही लाइन होती तो एक ही बार में ज्वाइन हो जाती, कोई एक तरफ, दूसरी तरफ ज्वाइन या फिलेट करने के लिए हमारे पास लाइन नहीं बचेगी. That is why individual line from this side and individual line from that side. Clear? Now that the turn has taken place, we need to join it with the main part of your main duct. So अब ये जो ऑफसेट आपको लेना है पीछे, ये आप किसके हिसाब से लेंगे? अपने ब्रांच डक्ट के हिसाब से लेंगे कवर करने के लिए, या मेन डक्ट के हिसाब से लेंगे कवर करने? नहीं, ब्रांच डक्ट के हिसाब से लेना पड़ेगा. Why? Because the width of the branch duct is going to be the total offset for you. How it is going to be offset for 300 इस तरफ यहां पर, एंड ये वाला हिस्सा यहां पर. तो डिपेंडिंग जितना आपका जो ब्रांच विथ रहेगा, दैट इज ओनली गोइंग टू कवर द पोजीशन ऑफ एयर. ठीक है, अगर सपोज मैं यहां से 600 का ले लिया होता तो वो मुझे मेरे लिए कहां पर आएगा? यहां पर आ जाएगा. ऑलराइट, दैट वुड बिकम अ मिस्टेक. सो सम थिंग्स यू हैव टू कंसीडर इन रेफरेंस टू द मेन डक्ट, एंड दूसरी चीज है इन रेफरेंस टू योर ब्रांच डक्ट. ये चीज यहां पर याद रखने वाली है. ठीक है, नाउ दैट यू आर गोइंग टू डील विद द completion of this, you have to show that it is going to behave like a proper elbow in a 2D drawing. तो ये लाइन यहां पर आएंगे जहां से आपका कर्व स्टार्ट हुआ है. फ्रॉम देयर जॉइन स्नैप ऑन द अदर साइड, फ्रॉम दिस एंड जॉइन द स्नैप ऑन द अदर साइड, एंड यहां पर आएंगे, यहां पर क्लिक करेंगे और यह आपका एक एल्बो बनते हुए नजर आएगा. अनवांटेड लाइंस आर टू बी डिलीटेड, जस्ट ट्रिम देम इस तरीके से. The lines that are not going to be erased, select and delete them, and now you can see that a normal duct, a branch duct, is connected to your different branch ducts. Now the next thing that is going to be important is, I do not think that both my branches are going to be aligned on the same side. मतलब एक ही हिसाब के नहीं रहेंगे, एक ही साइज के नहीं रहेंगे. दिस इज 300 by 300. मेजरली दिस इज गोइंग टू बी 450 by 300. हाइट इज गोइंग टू बी द सेम. ठीक है, हर चीज की हाइट एक रहना जरूरी. अब यहां पर दिस इज 300 by 300, तो वी हैव टेकन एन ऑफसेट ऑफ 300 बिहाइंड. ये अगर 450 होता तो 300 लेते थे? नहीं ले सकते. हमको विड्थ ऑफ द ब्रांच डट के हिसाब से जाना पड़ेगा. All right, and when you will be going to your estimation classes in this particular course, you will be coming into that particular example कि एक main duct से एक branch जो जा रहा है थोड़ा सा पतला है, दूसरा branch जो जा रहा है काफी ज्यादा इसके सामने बड़ा है, लेकिन main branch से main duct से छोटा. ठीक है, तो it's not necessary but that both the branches are going to be of equal size. Majorly they can be very good अगर होता है. नहीं अगर होता है, depending upon the design parameter, depending upon the connection of the duct to another place, it can deal or it can change in size. That is maximum on the width size. ठीक है, so the offset that you're going to take place is dependent upon the width of the branch duct after you do the fillet. Clear? Yes. So अब यहाँ पर this complete thing is called your trouser piece. The connection in between is called a, ये पूरी चीज है trouser piece. ये connection between जो fitting है, this is a short run elbow. All right. So R is equals to W by 4 is required for applying a short run elbow, whereas R is equals to W by 2 directly would be for long run elbow. Now short run elbow कहाँ place होगा, long run elbow कहाँ place होगा, ये आप लोग को better मालूम हो जाना चाहिए कि उसका usage क्या है, इसका usage क्या है. All right, less amount of space, less amount of clearance, not have enough of room for taking the turn, short run is good. Enough of space, enough of room, enough of clearance, no disturbance to the side, consider the long run elbow. All right, so with this we actually do the trouser piece that we have. यहाँ पर in the trouser piece option on page number 14, you can just highlight the main terms. Page number 14 पे you can draw that, consider an example of 600 mm. Dividing into two pieces. Next page, offset for proper distance. Create two elbows of 300 mm. Lastly, fillet is completely dependent upon the type of elbow, that is short run elbow, or the fillet length is equivalent to W by 4. For a long run elbow, fillet WR is equals to is going to be by 2, where W stands as the width. And below will be your example 600 by 4 and 600 by 2 on the next page. Lastly, on page number 16, the last line, trim the remaining segments and hence the trouser piece is created. Underline. Just below the diagram, trim the remaining segments and the trouser pieces created. And just after that you have three different types of elbows. We have known them. Short run elbow, in bracket it is written standard elbow, highlight. अब वो याद रख लेना है, शॉर्ट रन एल्बो बोलते ही मतलब R इज इक्वल टू W/4. लॉन्ग रन का नाम सुनते ही W/2. वो हर जगह पे सेम चीज इस्तेमाल होगी. चाहिए तो आप लोग वहीं ब्रैकेट में लिख लीजिए. लास्ट वाला जो है टैपर्ड या मीटर्ड एल्बो, वो कैसा रहेगा, उसका मेजरमेंट कैसे लेंगे. यहाँ पर metered elbow on page number 18. You can see these are used when there is very less clearance area for turning of the duct. All right, there is very less, मतलब some percentage only. अब कोई अपने पास रेक्टेंगुलर बीम आ गया, रेक्टेंगुलर कॉलम आ गया, कोई मूवमेंट नहीं है. अब स्ट्रक्चर को तो हम हटा के नहीं बोल सकते कि थोड़ा 1-2 इंच इधर ले लो. Right, we cannot disturb the main foundation of the building. We can indirectly try to change the route of our ducting. All right, so these when are not taking a smooth turn, how is the air going to balance inside this kind of a fitting is the question. That is why these metered elbows are going to contain turning vanes, which indirectly inside the shelf of that particular fitting, वहां पर blades इस तरह से होंगे that the air that is moving very fastly in some high velocity is going to touch these blades and move as per the direction of blades. ऐसे touch होके उसके ऊपर move होते ही slip हो जाएगी और वहां उस direction में चली जाएगी जहां पर ये veins उसको direction देंगे. बाहर की तरफ से it is totally solid. अंदर की तरफ से there is a turning that is help with the turning veins. They are like blades. 1 से 2 से 3 रहेंगे. जैसे जैसे एयर टच होगी और वो वहां पर जाएंगे, हल्की सी उसमें आवाज भी आएगी. ठीक है, तो वो टोटली जीआई शीट का या बन सकता है या फिर मेटल का बन सकता है या अंदर स्टील का हो सकता है. वो वेन्स इस तरीके से रहेंगे, शार्प एंड्स होंगे उसके पास, और जैसे एयर लगेगी इट इज गोइंग टू मूव. ज्यादा गैप नहीं रहेगा एयर को और कहीं फ्लोट होने के लिए. All right, so these are going to be used, and this is a third type of metered elbow, very rarely used. Most of all the contractors try to prefer that ये ज्यादा इस्तेमाल ना हो, because having the fitting of a elbow या फिर कुछ भी is easy to for maintenance purpose. Next time निकाले और लगा दी. metered elbow वगैरह रहेगा तो directly उसको निकालना पड़ेगा या फिर अलग से fabricate ही करना पड़ेगा. Clear? So after that one we are dealing, or we are going to deal with the reducers. So normally how many types of reducers have we seen across the complete study of HVAC? कितने types के reducers जानते हैं आप? Basically अपने पास 2 types के हैं. एक हो जाता है eccentric, एक हो जाता है concentric. अब normally अपने पास जो concentric reducer होता है, you can see that it is going to be tapered on both the sides. ठीक है, तो ये टैपरिंग जो होता है, ये जो रेड्यूस हो रहा है ये फ्रॉम दो साइड्स, इसके पीछे बहुत मतलब है. वो इट इज नॉट ओनली टू गेन दैट शेप, इट इज गोइंग टू बी टैपर्ड ऑन बोथ द साइड्स ओनली एंड ओनली व्हेन इट नोज दैट देयर इज अ सप्लाई टू द कंटिन्यूएशन ऑफ द रेड्यूस्ड डक्ट. दोनों साइड्स पे सप्लाई यूनिट्स भी दोनों तरफ है, रिटर्न यूनिट्स भी दोनों तरफ. तो रिटर्न का तो अपने को लेना देना नहीं है, ये रिटर्न वापस डक्ट के अंदर से तो ही ना रिटर्न होता, अलग जगह से हो जाता. ठीक है, अपने को सप्लाई यूनिट से मतलब है, सप्लाई डिफ्यूजर से मतलब. तो जब एक कॉन्सेंट्रिक इस तरीके से लगाना है या वहां यूज करना है, जब आपके पास जो फॉलोइंग डक्ट है जो रेड्यूस होकर साइज जिसमें लगने वाला है, उसके ऊपर ऑलरेडी प्रिफरेबल आर 2 सप्लाई डिफ्यूजर्स ऑन ईदर साइड्स. Now the tapering that is going to be done from that end, the air that was going straight will now be directed into the smaller duct at a higher velocity. Right? जगह छोटी हो जाएगी तो फ्लो ज्यादा बढ़ जाएगा ना, स्पीड में बढ़ जाएगा. अब जब ये वाली एयर इस तरफ डायरेक्शन से और बाकी की एयर ये डायरेक्शन से, दोनों भी एयर जब मिक्स हो जाएंगे तो दे विल बी हंटिंग फॉर अ प्लेस टू ड्रॉप डाउन. निकलने के लिए उनको एक वो चाहिए. अब यहां पर से जो सिंगल लाइन है, दिस इज नॉट ओनली अ सिंगल लाइन, दैट इज अनदर स्मॉल ब्रांच डक्ट. आई बात समझ में? तो दैट एयर दैट इज फॉलोइंग और मूविंग डायरेक्टली इन अ वेरी हाई वेलोसिटी इन द reduced duct, entering the branch duct, it is going to fall from the supply diffusers. That is going to happen on both the sides of the reduced duct. तब जाके concentric reducer अप्लाई करना. Eccentric reducer अप्लाई करना है opposite situation. कैसे, क्या है opposite situation? एक ही जगह से टैपरिंग हो रहा है, ठीक है, और ये जो reduce duct का साइज है उसके सिर्फ एक ही तरफ आपके पास सप्लाई यूनिट. ऑलराइट, अब ऑपोजिट, अब ये टैपर होना बोले तो कैसा समझ में आना कि नीचे से होना या ऊपर से होना? या फिर किस तरीके से उसको फिट करना चाहिए, वो चीज डिपेंड होती है आप जिस तरफ उसको टेपरिंग करेंगे उसका ऑपोजिट डायरेक्शन में सप्लाई होना चाहिए. Why? Because if the air is cutting down into a high velocity inside the duct, physically air के लिए पॉसिबल नहीं है आगे जाके फिर ऐसा मोड़ के ड्रॉप करने के लिए. ठीक है, तो वो फिजिकली पॉसिबल नहीं है. जो जिस डायरेक्शन में एयर बढ़ने वाली है, फर्स्ट ऑफ ऑल यू कैन नॉट ब्रेक द डायरेक्शन. तो जो यहाँ से टेपरिंग होके इट इज गोइंग टू फ्लो, इट हैज टू बी रीचिंग अप टू अ सर्टेन लेवल वेयर इट कैन टोटली ड्रॉप डाउन. ऑपोजिट साइड में डिफ्यूजर होना चाहिए. तो eccentric is going to be placed in places where there is a single diffuser allotted, and concentric is going to be used when there is more than one supply on either sides of the reduced duct. Clear? So creating both of them is going to be very simple, but until now we were only handling and dealing with the number and the numerical values which were example based. अब इसके अंदर जो हम actual concentric या फिर eccentric reducers को create करेंगे, they will be the standard sizes available to you in the market, starting the range from 300, 450, 600 to 900 mm तक के sizes आपको मिल जाएंगे. All right. So first of all, we are going to create a concentric reducer. Very simple. I'm going to draw it with a polyline, keeping my ortho on. Just a little size here. Take 1500 of length. Take an offset of, I'm reducing it from 600 to maybe 400. Why is this not working properly? Yeah. यहाँ से आप इसको ज्वाइन कर लेंगे इस तरीके से. अब कॉन्सेंट्रिक रेड्यूसर्स को ड्रॉ करने के लिए, बिकॉज द टेपरिंग हैज टू बी फ्रॉम बोथ द साइड्स, द नेक्स्ट कंटिन्यूएशन ऑफ द डक्ट हैज टू बी फ्रॉम द सेंटर पॉइंट. ओके, इसको भी आपने लिया और कहीं पर ड्रैग कर दिया. Now we know that the marking that we have here is nearly the size of the duct is. Unable to see that. It is 600. I am reducing it to 400, 200 mm का reduction, और say I am reducing it to 300. All right. अब वो चीज को ड्रॉ करने के लिए पहले मुझे एल्बो फिटिंग या रेड्यूसर को ड्रॉ करने से पहले ये डक्ट का इंतजाम बना देना है कि टोटल उसका reduced डक्ट का साइज कितना है. आई एम गोइंग टू मेक दैट फॉर 300 is decided. So the offset is going to be 150, right? Offset of 150 on both the ends is going to give me total of 300. Now the offset that you need to fit here in order to reduce this duct is what is the concentric reducer. तो यहाँ पर जो concentric reducer हम पहले इस्तेमाल करेंगे of the standard size 300 mm, which is nothing but how much in terms of inches? 12 inches, right? 12 inches का आपका एक reducer market में आपको मिल जाएगा. Offset for 300 directly. From here, take a line on the other side. Keep your ortho off. Use a line command. From this end, draw here. This end, match here. Very simple. Use TR double enter to just delete or trim the extra lines and select the midpoint here to delete, and then you can see that the duct is reduced from 600 mm to a 300 mm of size with a reducer of a standard size of 300 mm. ये वाला डिस्टेंस वही तो लिया ना हम लोग, 300 लिया ना, वो उसका ही ऑफसेट करे ना वहां पर, वो एक्चुअल के इसमें अटैच करना है. दिस साइड इज गोइंग टू बी वन फ्लैंज, दिस साइड इज गोइंग टू बी वन फ्लैंज. दोनों 100 जो है कॉन्सेंट्रिक रेड्यूसर. एसेंट्रिक रेड्यूसर जो हम लोग यूज करेंगे, सेम एग्जांपल वंस अगेन. यहाँ पर एक आई एम reducing, taking an offset of say 400 mm this time, and I am going to join the line. I am going to taper it only from one side. So can I take it from the center point or from either one side? Either one side continuation में मुझे लेना पड़ेगा. If you're going to taper from the opposite direction, continue from down. If you're going to taper from below side, continue the line from up. इस तरीके से आप इसको लेकर छोड़ देंगे. अब 400 से ये वाली लेंथ ये डक्ट को रिड्यूस कर रहे हैं हम 200 mm पे, इसको भी 200 mm का बना लिया. अब ये जो हमारा जो साइज है इसका ऑफसेट हम लेंगे एक डिफरेंट साइज 450, जस्ट फॉर लर्निंग पर्पस. for understanding how it is going to see. Turn off the ortho, use align command and join the two edges. TR double enter, this line is done. And then you can see the duct is reduced from 400 to 200 only with one side tapered, and because the tapering is on this end, it is understood that maybe a supply unit can be any one side. Maybe it can be more than one, two, not a problem. But it has to be only on one side. And jo concentric tha, maybe 1 and 2 here, 1 and 2 here. Can be more than one on each side, but has to be on opposite ends. Clear? So this one is your concentric reducer, niche wala is your eccentric reduce. And the sizes jo iske andar hai, that is 300, 450, 600 and 900. ये आप लोगों के पास इसमें लिखा हुआ है यहाँ पर, इसको हाईलाइट कर लीजिए पेज नंबर 18 के पॉइंट नंबर 2. At the duct end create an offset with standard measurement and the measurements are in bracket 300, 450, 600 and 900. The first point उसके ऊपर, the concentric reducer is used when the supply is provided on both the sides. Coming to the next page, page number 18. Join both ends with a line where they are meeting. Trim the remaining lines and hence the concentric reducer is created. Until there was the concentric reducer. Eccentric reducer के लिए, point number 1. Eccentric reducer is used when the supply is provided only one side. Highlight. Now lastly, what we have is we are having a shoe neck. तो एक shoe neck क्या करता है अपने पास? Do we know what is a use of a shoe neck? Where it is to be used? कहाँ लगाएंगे? कैसे use करेंगे? Main duct को? सब branch के लिए, right? Next branch के अंदर flow को start करने के लिए we have to give that an indication to flow. So that is going to be my shoe neck. यहाँ पर I'll draw the shoe neck with a red color. Now to draw the shoe neck, also we actually follow one kind of a thumb rule. On page number 21, we have creating a shoe neck. And first line in itself says, a shoe neck is connected to the branch terminal to show the air flow from the main duct. मेन डक्ट से आने वाली हवा को ब्रांच डक्ट तक जाने का रास्ता एक शू नेक बताएगा. ऐसा नहीं है कि शू नेक अंदर की तरफ से चलते चलते बताएगा, डट के बाहर की तरफ जो आपको मूवमेंट आना चाहिए, there is where a shoe neck is going to be applied. You can see under point number 3 you have a diagram that shows that way, right? This portion, ये छोटा सा चीज between the main duct and the branch duct is called a shoe neck. And because it is actually displayed in the shape of a shoe, उसको shoe neck बोलते. और क्योंकि वो कोई भी चीज के स्टार्टिंग में आ रहा है, ठीक है, ब्रांच डक्ट के स्टार्टिंग में बैठ रहा है, उसको नेक का नाम दिया गया है शू नेक. क्लियर? सो देर इज गोइंग टू बी इंपॉर्टेंट हर एक चीज को याद रखने में. एंड शू नेक को भी क्रिएट करने में भी आपके पास एक फॉर्मूला मिल जाता है, सेम लाइक द एल्बोस, एंड दैट इज गोइंग टू बी L is equals to W by 4, where L becomes the length of the shoe neck, W is the width of the main duct. Clear? So L is equals to W by 4, but there is also a lineage for having a thumb rule value. अगर आपके पास L is equals to W by 4 की value is coming less than 100, you have to automatically substitute that to be 100 mm. कम से कम 4 इंच which is 100 mm तो भी उसका लेंथ रहना है, मिनिमम वैल्यू है वो. अब सपोज माई लेंथ और W is only 300 by 4 is going to be 75. I cannot try to take a shoe neck of 75 mm. I will automatically have to apply that to make it 100 mm. All right. If it is going to be 400, the width 4 by 4 is going to be exactly 100. I'll take that one. Anything above than 100 has to be considered as per the formula. Anything less than 100 to be automatically considered as 100 mm. All right. So point number 2 is very important. Offset the line inside the duct for 100 mm in bracket. वहाँ पर एक term missing है, minimum. For 100 mm minimum, or L is equals to W by 4, go with the value, where L is the actual length. Now we're going to check that as an example here. I'll just draw one using a different color. 400 mm नहीं, सिर्फ 100 mm minimum. This is my main duct, and from here is my one branch duct moving. That is of the size 200. Like this, and in this position I have to apply the shoe neck. Now I'm going to create the shoe neck. That is, first of all, draw a line there. Simple. 400, right? Main duct, 400 divided by 4 is 100. So now take the offset for 100 mm for this one. यहाँ से लेकर यहाँ तक, right? अब ये करीब करीब इस तरह से बन गया है. शू का जो शेप है वो लेकर आना है. For doing that, we need to click on polar tracking using F10 function key. Right click, let 45 be the incrementing angle suggested. Use align command, take from that position, drag until the third quadrant, finding 225 degree angle. 225. ये डक्ट के मेन डक्ट के अंदर तक लाकर आप कहीं तक छोड़ देना है. इस तरीके से जो पहली लाइन आपने ड्रॉ की है उसको लेकर ड्रैग इट टू दैट इंटरसेक्शन पॉइंट देयर. यूज TR double enter this line and अंदर की line. Now you see a normal shoe neck is formed. Clear? So the polar tracking plays an important role in achieving exactly the cut at 45 degree angle. Clear? So ये shoe neck आपके पास मिल जाता है for giving you the delivery of LE enter डक्ट. ऐसे आपका एयर जो है मूव होने वाला है. थोड़ा सा उसको इंडिकेशन में बड़ा कर देंगे. आपकी जो एयर है इस तरीके ये डायरेक्शन में से जा रही है. अब यहां पर मिलने के बाद से आपकी एयर इज गोइंग टू फ्लो कंप्लीटली दिस वे. यहां पर से वो चली जाएगी, राइट? तो द प्रोपगेशन ऑफ एयर फ्रॉम दिस साइड है बोल के वो ये डायरेक्शन ऐसा है. अगर ऊपर से होता तो ये भी टिल्ट हो जाता. आई बात समझ में? तो यहां पर क्या होगा, आपके डक्ट के पास ये मेन डक्ट अप्लाई करने के लिए, पकड़ में रखने के लिए शू नेक चाहिए. डायरेक्टली अगर ये डक्ट की ओपनिंग और ये डक्ट की ओपनिंग क्या है, बोथ आर स्क्वायर. ये भी ऐसा है, ये भी ऐसा है, ठीक है? तो ये एयर जो यहाँ से मूव होते होते अगर इसको जगह सही हिसाब से पुल नहीं मिलेगा, एक फोर्स ऑफ अट्रैक्शन नहीं मिलेगा, तो ये अंदर नहीं जाएगी उसमें, राइट? प्लस यहाँ पर अब ब्रांच डक्ट के अंदर डैम्पर्स होंगे, ये सारी चीजें होंगे, तो उसकी वजह से वो सक्शन क्रिएट हो जाएगा. प्लस नीचे डिफ्यूजर भी रहेगा, तो वहां से भी अपने को एक पुल चाहिए रहेगा, एक्सेट्रा. शू नेक हम इस वजह से लगाते ताकि जो मीडियम ऑफ एयर फ्लो है, सम एयर वी आर सेइंग सम एयर मूव्स इनटू द ब्रांच डक्ट व्हाइल सम जस्ट पासेस अवे. थोड़े आगे भी बढ़ना है, थोड़े मूव भी होना है. अगर आपका डक्ट यहाँ कंप्लीट हो जाता है वो बात अलग है. नहीं अगर कंप्लीट हो रहा, आगे तक है डक्ट और आपके आगे भी एक ब्रांच डक्ट आने वाला है, तो वहां पर भी एयर इज गोइंग टू मूव, बिकॉज एयर को हम कंट्रोल पावर नहीं पकड़ सकते. It is in high velocity, right? First of all, it is very refrigerated at a very low temperature, and then it is flowing at a very high velocity, right? तो जैसे वो बढ़ते जाएगी, जहां जहां जितना रिक्वायरमेंट CFM सब ब्रांच में है, वहां शू नेक के जरिए से it will direct itself there. All right? तो शू नेक is again important. शू नेक को भी प्रैक्टिस करना जरूरी है, and it is going to be this way depending upon the direction of air flow. All right? यहाँ से we have marked point number 2. Yes, point number 3 में just mark angle 45. Trim the inner lines. That's it. And you will be getting a diagram like this. And ये इसके bracket में लिख लीजिए use polar tracking F10. Point number 3. हाँ, use polar tracking F10. Next is creating accessories. Under the accessories, we have given you two examples, that is a fire damper and the creation of a butterfly damper. But actually, the accessories are a lot many to be shown. There is a VAV box with a thermostat, right? Then there is going to be a VCD damper. इस तरीके से अपने पास बहुत कई कई किस्म के और accessories आते हैं depending on its usage on a project. Project to project वो चीजें होंगी. And butterfly damper हम कम लगाएंगे जब किस चीज की जरूरत है हमारे पास, फ्लेक्सिबल डक्ट की ओपनिंग की जरूरत है. तो फ्लेक्सिबल डक्ट जब याद आया कि इट्स गोइंग टू बी अ सब ब्रांच, बटरफ्लाई डैम्पर वहां पर ऑटोमेटिकली यूज होना जरूरी. एंड फायर डैम्पर कहां लगाएंगे, मतलब कौन से सिचुएशंस में, इज इट ऑप्शनल और इज इट गोइंग टू बी कंपलसरी? इट्स गोइंग टू बी कंपलसरी. व्हाई? फॉर सेफ्टी पर्पस. ऑलराइट, तो फायर डैम्पर को क्रिएट करने के लिए अपने पास दो डिफरेंट मेथड्स हैं. In the SLD drawing, it's going to look different, and in the DLD drawing, it's going to look different. And DLD drawing it actually is going to look like a motorized damper. In the SLD drawing, it's going to look like more of a manual damper. All right. So to show that example, I already have this duct here with me. I'll just delete this line, create a new layer, and I'll be using only one term, fire damper, and I'll show both the examples in that itself, orange color. Good to see. The first fire damper that I need to create, I'm going to show in the SLD form. To do that, I'm taking a polyline. The polyline is going to begin keeping the ortho on from some position. Usually we know that at the beginning of the duct के mouth के पास इसको लगाना है. मैं ऊपर बताता हूँ ये example फिर यहाँ से. नहीं तो ये air यहाँ से start हो रही है ना, move होने के लिए यहाँ नीचे draw कर देता हूँ. All right. So it is understood that. तो यहाँ से my polyline is going to begin. But the polyline has to become or with some thickness. So W enter, I'm giving it 50 enter, 50 enter this way. So PL enter from this side, go until the other marking, come down to a minimum of only 100 or 150 mm and enter, escape. ये इतना ही आपका एक fire damper है. So this handle over here shows that the blades can be opened and it can be closed. तो दिस इज मैनुअली अट्रैक्टिव. ठीक है, ये फायर डैम्पर आपको ऑरेंज कलर में आप रिप्रेजेंट कर दिए, समझ जाएंगे कि यहाँ पर एक्चुअल में मोटराइज फायर डैम्पर लगना है. आज की तारीख में कुछ भी कहीं पर भी हैंड से यूज करने वाला फायर डैम्पर नहीं. ठीक है, तो इन द अदर टर्म्स वी आर द जो पॉलीलाइन की जो विड्थ है दैट इज एग्जैक्टली गोइंग टू बी द विड्थ ऑफ माय डक्ट. आई डू नॉट नीड अ मेजरमेंट फॉर दैट. जितनी विड्थ है उतना चौड़ाई रहेगी फायर डैम्पर की. हैंडल के लिए 100 to 150 mm रह सकते हैं, आप छोड़ सकते हैं ड्राइंग के हिसाब से. ठीक है, वो छोटा सा ही रहना है. अब जो मोटराइज फायर डैम्पर आपको दिखने वाला है उसके लिए आप एक रेक्टेंगल लेंगे. सबसे पहले एक रेक्टेंगल आपकी जो लेंथ होगी दैट इज डिफाइंड एज पर द विड्थ ऑफ माय डक्ट. यहां से लिए यहां तक आ गए, लेकिन उसका जो विड्थ रहेगा आपके हाथ में, हाउ मच यू वांट टू डिफाइन. यू कैन मेक इट वेरी बिग ऑल्सो, यू कैन मेक इट वेरी स्मॉल ऑल्सो, और एल्स देयर इज अनदर आइडिया इज कि आपके जो प्लान का जो वॉल रहेगा उसका थिकनेस ले लेना. दैट इज द बेस्ट वे टू एक्चुअली क्रिएट अ फायर मोटराइज्ड फायर डैम्प. सपोज वी आर गोइंग टू मेंटेन इट ऑफ दिस मच साइज. ठीक है, after that what you need to do is use the keep your ortho off, use lines from both the extents. In between, draw a circle of some huge measurement this way randomly. Next again, use a polyline with the same width 50 and 50 from that end to this end. And this is how your that is going to look like fire damper in the DLD form. All right, ये round circle यहाँ पर shows as if that exhaust जो दूसरी तरफ जो smoke का opening है वो allow नहीं करेगा because we are putting this polyline सामने की तरफ. पॉलीलाइन डाल के भी ऊपर से हम लोग सर्कल ड्रॉ कर सकते हैं और अच्छा दिखने वाला था, बट दिस इज टू शो दैट इसके बाद से एयर मूवमेंट नहीं है, आगे की तरफ नहीं है कुछ भी बढ़ने का, ये यहाँ पर खत्म हो जा रहा है. वो चीज को बताने के लिए फायर डैम्पर इस तरीके से डीएलडी में ड्रॉ किया जाता है. ये आपके पास नोट्स में नहीं है, साइड में ड्रॉ किया हुआ, एक्चुअली ड्रॉ कर देना चाहिए था. आप लोग उसको कहीं साइड में ड्रॉ कर लीजिए ऑन पेज नंबर 22 एंड राइट फायर डैम्पर इन डीएलडी फॉर्म. हाँ, सिंगल लाइन में, ऊपर वाला डबल लाइन. एंड दोनों भी जहां पर भी ड्रॉ करो, कोई भी ड्राइंग में एट द एंड एंट्रेंस ऑफ द डक्ट में ही नजर आएंगे आपको. ये बता दो। Done? Yes. And इसके बाद से one more thing that we have, that is a butterfly damper. I will quickly show you that also. किस तरह से draw करना है उसको. Simple to use. LA enter. Butterfly damper is BD. I'll be taking a light color to show that. You have to first create a rectangle of a random size. I'm taking is 100 by 250. We have to here not use the circle command. Instead, we are going to use the donut command. All right. So donut command and circle command में क्या difference है? A donut command is having internal and external diameters. All right. So I'm going to use the command do enter. Internal diameter being 10 mm and the outer diameter being 50 mm, like this. Very, very minute and very, very small. Place it exactly at the center of your rectangle. इस तरह से. You are now going to turn the ortho off and draw a line from this end, crossing that polyline, crossing that donut this way. Go to the center, trim the line in between. And this shows that either on this side or on this side is the blade going to move, right? So this is your butterfly damper to which the flexible duct is going to be connected. वो यहाँ side में से continuation हो जाएगा. Alright, so butterfly damper भी आपके पास अब मौजूद है. ये complete drawing को मैं save कर देता हूँ पहले, so that I can send you the email. HD94 drawings, and this is our HDE94 drawing 2. And I can use T enter to just mark everything. This is my trouser piece. Shoe neck, fire damper, butterfly damper, concentric, eccentric. इसको भी प्रैक्टिस कर लीजिए. फिर कल इंशाल्लाह मंडे से नेक्स्ट क्लास में हमारे पास जो होगा डायरेक्टली हम SLD फॉलोड बाय DLD ड्राइंग करेंगे. जो भी आप जितनी चीजें सीखे हैं इंडिविजुअली, अब उनको प्लेस करना सीखेंगे एक नॉर्मल एक छोटे से सिविल प्लान में. ठीक है, तो उनको SLD ड्राइंग अपने लिए जरूरी है सिंस बीइंग ऑन दी डिजाइनिंग साइड, इंजीनियर साइड. DLD उसको कर लेना अपने जानकारी के लिए बेटर. Alright, so DLD में we are going to place all the diffusers, all the proper dampers and everything to make it a total proper drawing. एक shop drawing के जैसे दिखाएंगे उसको करके. SLD करने के लिए करते वक्त आप लोग को वो पूरी चीजें अब तक जो सीखे आना चाहिए by heart, परफॉर्म करने के लिए, ड्रॉ करने के लिए. ठीक है. Before we are going to start the session for single line drawing today, that is single line for ducting, it is important for me to confirm if all of us know what is external reference. Right, we should be knowing what is an external reference. If we do not know also, I'm going to show that once again now. So even if you know, you can just review yourself how to do the external reference, how to place the external reference, and how to use them now when we are dealing with a different service sector. All right, since we are dealing with the HVAC drafting, we are going to look forward on taking a civil plan as our external reference, and over that civil plan is what we are going to do the drafting. All right, the single line drawing. Now, what is a single line drawing is very important. A single line drawing, as written on the screen, you can see it's a representation of the design which we have calculated with the definite dimensions to it. It is only a concept drawing as per the design which you have to do initially. कोई भी drawing का double line cannot be created if there is no single line. Is it clear? And all the final drawings are going to be in your double line drawing only with proper dimensions, measurements, and etc. Yes, please. All right. So single line drawing is a representation of the design that you have actually thought of. जो creativity आपके पास है, that thing is what you're going to now apply with AutoCAD. All right. So you have to highlight the definition. You have to say it as it is at the time of interviews and etc. Highlight the text, and I'm going to just highlight this on page number 24, single line drawing. And now, before we are even going to deal with the steps of drawing, we need to have the civil plan on screen. All right. So before we are going into the details of the steps, we are first going to get a civil plan in terms of an external reference. Okay. So the way to apply the external reference is XREF, that is XREF is the command. Enter. And you will be getting to apply one particular attachment of a drawing. I'm going to click over it, go to my desktop, take a civil plan, and you can see how the civil plan is going to look like. Inside the views, make it thumbnail. This is how my civil plan is going to look like. I'm going to open that. I'm going to make the attachment. I'm going to make the reference type as attachment. No scaling to be done. I want it to be original. Insertion point is to be selected over the screen. Path is to be completed. Rotation and angle is to be 0. It's the default size. And this is how it is going to look like. Press OK. And then you can see it is available to you on the screen very, very lightly. The moment I click it, I need to use Z enter, A enter. But it's too light. And now you can see that something is loaded here on civil plan. Right. I'll just change the background score so that you can see it a little bit darker. This is available. You can see it, right? Once your civil plan is loaded, you can just close the external reference dialog box. And this is what we need to be held on the screen. It's a room 1, storeroom, and room 2 drawing. A small civil plan with having different false ceilings, different number of doors, different number of windows. So why is this drawing so light is the question to be answered. Why? Because it is not a normal drawing. It is taken from an out or external source, applied or embedded into the current drawing. That is why it is not the original part of our original drawing. Kabhi bhi any type of external reference that you try to take, it is going to be created in color 8, which is, now what is a color 8? If I'm going to show you which one is going to be my color 8, this is going to be the color 8. And now you see the difference between a color 8 and a normal black color. Through index, this is going to be the darkest black color. Jiska name and numbering is not shown to us here in terms of x-axis or anything. Maybe I can just select that from here. The index score color is nearly 250. And the color 8 in terms of that is going to be much lesser in shade. So कोई भी drawing अगर आप इसमें करने वाले हैं, create करने वाले हैं, it is going to be applied in color 8, and then you have to save it as an external reference file to be used again and again by different departmental people. Okay, so now without the help of this external reference or these boundaries, I cannot try to upload my HVAC drafting single line drawing. Okay, and so that is why we have created or taken the help of my external reference. Now, after I have brought the external reference on the screen, you can see it now. Little bit clear. Yeah, itna hi aayega. I cannot make it much more darker. The maximum I could do is to change the background score, background color to black, so that you can see it little bit. If I'm going to do it to white again, वो तो totally नहीं दिखेगा. All right. So we are now going to deal with the external reference, and before even starting the steps of drawing for the single line drawing, we need to gather the information from the plan. So very quickly, we can see room 1, a storeroom, and room 2. Now you have to tell me what is the type of false ceiling in room 2 and what is the type of false ceiling in room 1. Yourself, Zaid. Plain false ceiling in room 2, acceptable. In room 1, step false ceiling in room 1. All right, why? Because it is taking a step and the other portion is coming inside the false ceiling area that you can say made of POP. All right, अब ये plain है totally. It can be plain like this or it can be even kept in tiles. Now if we have a plain false ceiling, what is the idea? कौन सा air terminal इसमें लग सकता है? Diffusers. And for the step, grills. Understood, right? So now in between the two of them, I have a storeroom. What can be the help of a storeroom? क्या काम मुझे आ सकता है storeroom? क्या place करने के लिए? I can place the machine. And why I can place the machine in the storeroom? Why cannot I place it in room 1? Okay. Suppose I'm making it ceiling suspended. Then yes, it will be gathering heat from from both the corners only, from two sides of the wall, plus the ducting is going to be difficult until the next room. फिर उसके बाद we also have to think that the return passage that is going back to the AHU has to have some gap in between. How will the air pass back into the AHU otherwise? So if not being placed in room 1 and if not being placed in room 2 for proper distribution of air in both the rooms, we are going to place it inside a storeroom in this category. You have to maintain the pressure reading, the velocity reading that is going to eject totally from the AHU to be spread inside both the rooms. Now this room area we do not know the room volume, we do not know anything. We are going to take total assumptions only consideration. For example, I'm going to create or contain an AHU of 2000, this one, what you say, nearly 60R. How much is that going to be? 2400 CFM. All right. Now, if 2400 CFM is available to be coming out from my AHU, दोनों rooms में कितना distribute होगा? Equally, 1200, right? 1200 in room 1 and 1200 in room 2. Now, as per that all designs and consequences, we can find the number of diffusers depending upon the CFM. Now, I am going to apply maybe 2 supply and 2 return. If I'm going to make 2 supply ceiling diffusers from 1200 individual diffuser में से कितना आएगा? 600 individually, right? So 600 plus 600 total room coverage is now become 1200 CFM. Okay, and this total room is 1200 CFM. This total room is 1200 CFM. Maximum capacity of AHU is 2400 CFM. The addition of both the rooms में जितनी air consume हो रही है, that is the actual power of my AHU. Now suppose if I had more 2 rooms like this, can 2400 be enough for me? Can I make the same supply to be flown in 4 rooms? नहीं होगा, right? तो depending upon जितने rooms बढ़ते जाएंगे उतना CFM कम होते जाएगा. All right, so that time you have to increase the total capacity of my AHU. All right, up 2400 से maybe I'll have to gather more. Maybe instead of 60R, maybe I'll have to take 80R machine. 3200 CFM उसमें से होगा. Then to be divided by 4, maybe 900 CFM in each room. Then it's going to be considerable. All right, so number of rooms and the capacity of AHU has to go in alignment always. And in terms of drafting, what you have to do is now considering the first step is placing the machine. First thing is you should know the location where to place the AHU and उसके बाद ही बाकी के चीजें will come accordingly. Now the first thing to here apply, we know that we are going to apply the AHU in storeroom. Okay. Now to do that, I do not have any particular layers updated. I'm going to create a new layer. And that is going to be called AHU. I'm going to keep it with a light blue color in order to see it on the background. And the size for the AHU is what we are going to consider again is the same size that we had done last time. That is same example 1100 by 600 by 300. 300 remains the height. 1100 is length, 600 is the width. You see, this much is going to be my actual top face of the AHU. You are going to use the move command, take its midpoint. My ortho is not on snap mode. Take that, drag it to a situation here and try to place it in the middle of my room. You cannot just place it very close to the wall. मेरी ducting के लिए बहुत लंबा हो जाएगा. Plus you see, if I'm going to place, not only for the ducting, there is a canvas cloth going to come, there is a mouthpiece, then there is a main duct, and after the main duct is the fire damper. Right, fire damper का maximum area आने के लिए I need one supporting wall पीछे. All right, so I cannot take the HU totally backside. Plus इतना पूरा मैं अगर पीछे कर दूंगा तो जो दीवार की मुझे जो स्लैब की जो गर्मी वगैरह रहेगी, that is going to affect on the HU. More valuable heated air is going to get inside the HU, which is not recommended. Plus इतना दूर अगर उसको लाकर रख देंगे last corner में, how is the return actually going to go inside the AHU? All right, so for considering all those points, we have to keep it exactly in the center of the room. I'm maintaining at this position. I have placed it. Okay. So in the SLD only ये सब decide करना है आपको. ये एक ही position है. DLD में everything is just going to make the offset. The SLD is of more thought process. यहाँ पर ज़्यादा सोचना है. ये वाली drawing में कैसे place करेंगे, कहाँ place करेंगे, and etc. But it becomes very easy to do that. Performance is easy. Creation is easy. Thinking is difficult. After placing of the machine, I'm going to give the description inside the machine. कि मेरा AHU का content क्या है. Always you have to maintain that it is AHU, my dimensions are how much? 1100 by 600 by 300. After that one, my capacity I'm going to maintain for 6 TR, which is equivalent to 2400 CF. Lastly is the make or the manufacturer. Maybe we are taking from Carrier. Simple. We're going to increase the tin size 50, maintain, and it is available, it's readable. Okay. Next thing after that one, what we need to do is to place the air terminals. Which are the air terminals? Diffusers and grills. Now to access the air terminals, what is more important is we have to, as we have already discussed, plain false ceiling, step false ceiling. Plain false ceiling matlab automatically diffusers are going to be applied. So we have to start creating the diffusers. We already know how to create the diffuser in SLD and in DLD, right? So that is going to be my SCD, supply ceiling diffuser. Color is always going to be in green. And I will be needing RCD, supply or return ceiling diffuser, red color. Keep SCD currently the active. Check inside the layers, it is updated. Coming down here, using the same example size, 300 by 300. This is done. The only format how to use or how to show the SLD, L enter, two different lines. This is done. This is done. ये है आपका supply, right? Taking RCD in active mode, creating another one, 300 by 300. Only one line to demonstrate that it is the return. Keeping them aside. Now, because these are multiple images, I need to convert them to block. I am only writing plain SCD currently. This is converted to block. Again, B enter, RCD. We are not writing the sizes or any specification currently. Why? Because it is only going to be my single line drawing. Now comes the placement. यहाँ पर इसको कैसे जमाएंगे? Right? ये है सबसे main चीज. For doing that, I'm going to create or convert my room into 4 equal blocks. I'm showing you how to do that in actual practice also. कभी भी कोई भी plain false ceiling हो या tile false ceiling हो, anytime try to divide the space into equal rows and columns depending upon its width and length and width. Block method से जाएंगे, बहुत easy समझ में आएगा. नहीं तो ये समझ में नहीं आएगा कि एक डिफ्यूजर रख दिए 4 फीट का गैप रखना है, एक डिफ्यूजर रख दिए 4 फीट का गैप रखना, प्लस सप्लाई रख दिए तो रिटर्न कहाँ रखना है, रिटर्न रख दिए तो सप्लाई कहाँ रखना है. Alright. Now in this complete section, we are only going to talk about the room 2. Now not dealing or thinking about from where the duct is going to emerge. कहाँ से duct आने वाला है, I am going to leave that. But we know that the duct जो भी आएगा ऐसे आके follow होगा, right? L shape में. Now where to place the supply and where to place the diffuser, I am having 5 minds in class. All 5 are going to give me the answer. Everyone is going to have different ways. So where to apply, where to keep the supply, where to keep the return. Think of the physical parameters, think of the ventilation standards, सब कुछ सोच समझ के आप बता सकते. Starting with Yogesh. Where do I apply the supply units? किधर किधर मैं place करूं? 1, 2, 3, 4. And we are going to go with the quadrant method. This is 1, 2, 3 and 4. So you have to tell me and I'll be starting to place them. First, green वाला supply. कहाँ कहाँ मैं लगा सकता हूँ? आप देख सकते हैं कि there is a door, there are windows. तो कहाँ से उसको लगाने पे approximation ज्यादा मिलेगा एयर का, कहाँ से एयर वेस्ट हो जाएगी. सोच के समझ के आपको वो चीज को प्लेस करना है. You can keep thinking the hint that I have given कि to supply you have to apply, so automatically to return will be coming for assuming 1200 CFM. ठीक है, एक आपने कहा डोर के पास, दूसरा वाला एक सप्लाई एक रिटर्न आएगा. एक सप्लाई तो लगा दिए, दूसरा सप्लाई कहाँ लगाएंगे? ऑपोजिट डायरेक्शन में लगाएंगे, यहाँ लगाएंगे, नहीं साइड में लगाएंगे, कहाँ लगाएंगे? एक आप कहते हैं फर्स्ट क्वाड्रेंट में, दूसरा थर्ड क्वाड्रेंट में. ठीक है, नेक्स्ट आप सेकंड में लगाएंगे और फोर्थ में लगाएंगे. जैद सेकंड में, फोर्थ में. श्रवण आइडिया आप थर्ड में और फोर्थ में. आपका था फर्स्ट और थर्ड में, राइट? तो वी विल स्टार्ट विथ द वंस हु हैव टोल्ड नियरली 1 2 3 या फिर 1 3 and 4. ठीक है, सो अखिल हैज 1 and 3, रियाज हैज 3 and 4, राइट? अब आप लोग का इसमें प्लेस का सेकंड प्रॉब्लम व्हाट विल हैपन इफ यू आर गोइंग टू मेंटेन इन 1 and 3 और 3 and 4 इज यू हैव अ डोर ओपनिंग हियर अंडरनीथ. ये फॉल सीलिंग है, आपने यहाँ लगाया, समझो इसके नीचे डोर है. एयर सप्लाई होते कहां जाएगी? बाहर जाएगी कि अंदर आएगी? बाहर चली जाएगी, राइट? तो दैट इज गोइंग टू क्रिएट इनफिल्ट्रेशन. व्हाट इज इनफिल्ट्रेशन? यू विल बी कमिंग टू नो इन द क्लासेस. यू हैव डन दैट, राइट? तो इनफिल्ट्रेशन क्या हो जाएगा? द सप्लाइड एयर इंस्टेड ऑफ कंज्यूम्ड इनसाइड द कंडीशन स्पेस लीव्स दैट एरिया. जो एरिया को उसको कूल डाउन करना है, इट इज नॉट कूलिंग दैट पार्ट एंड इट इज लीविंग आउट, सो दैट इज गोइंग टू बी अटर वेस्ट, राइट? फ्री में तो बिल्कुल भी नहीं आ सकता, राइट? अब कभी भी कोई भी सप्लाई आसपास या बाजू बाजू में नहीं आती. दैट इज अ सेकंड पॉइंट दैट यू शुड कंसीडर. 3 and 4 के बाजू में सप्लाई, सामने से रिटर्न, तो दैट इज गोइंग टू बिकम अ टोटल लोड फॉर द मशीन. डक्ट के अंदर आते ही इट इज वांटिंग टू थ्रो बोथ ऑफ देम, राइट? और थ्रो होने के बाद से बाकी का डक्ट इज वेस्ट. बाकी का तो रिटर्न रखने का है, तो मेरे को मेरी डक्ट यहां तक ही आ जाएगा, मेरा खर्चा कम हो जाएगा, लेकिन बाकी के पूरे पैरामीटर्स आर गोइंग टू बिकम वेरी वेरी लोड टू द मशीन, राइट? सो दैट इज अगेन रीजन यू कैन नॉट अप्लाई बोथ सप्लाईज besides each other. The correct answer is said by 2 and 4. All right, why? Because if we are going to apply this in number 4, suppose here 1, this is going to take care of this much area as well as this much area. All right, but I told ki infiltration will happen here. That is when you're placing the supply diffuser right above. अब my supply diffuser is placed there, so till it is reaching this zone, okay, it is already cooling that much of portion. So my direct 1200 CF, direct 600 CFM is not being wasted, no, from one diffuser. यहाँ पर direct waste हो रहा था, और एक ही 600 CFM was then responsible to cool the complete room area, which is not going to be possible. Understood? So one is going to be placed here, the other one is going to take care by placing in the other region, इस तरफ, यहाँ पे. All right, so keeping that in second quadrant and fourth quadrant is going to make it easy by moving the duct from this portion. यहाँ से जाएगा, first this will get the supply 600 CFM, then जैसे the move air duct and the air is moving ahead, this one is going to take care for cooling this much of zone. All right, or you can say this diffuser is taking this side, this diffuser is taking this side. So in total, this part 1 and 2, this part 2 and 3, complete room is satisfied with the air, right? So that way you have to take, and जो भी empty spaces होंगे वहां पर कौन सा diffuser आएगा? Return diffuser आ जाएगा automatically. So we are going to move that. I'll directly copy that. Paste one here, paste one here. Now the exact location of also how to place them is still not correct. All right, we have only learning कहाँ पर place करना. Exact location किस तरह से find करना है, DLD में अपने पास apply होगा. All right. So after doing that, we are going to remove these blocks. This much is easy and okay for understanding. Let us come down to step fall ceiling. Here is what you have to answer very, very nicely, because in the step fall ceiling on applying the grill, I cannot divide the room into 4 zones or 4 quadrants. It has to be orientation wise, either north, east, south, or west. I'm going to start creating that one. Until then, you have to think ki supply kahan lagaye or return kahan lagaye. I'll start creating my layer for that. SCG, supply, RCG for return. I'll create a normal size. We have a head and then we have a neck for that. Right. So I'm going to select this one and where to place the supply, where to place the return. 1 and 3 कहाँ है अभी? अभी quadrants नहीं है. You have to tell me in terms of direction, north, south, east, west. ना अभी इसके अंदर एक ही सप्लाई हम लगाने वाले हैं. एक ही सप्लाई यहाँ कंसिडर कर रहे हैं हम लोग. तो we are going to talk as per one supply and one return only. The grill can access directly 1200 CFM. All right. More than the one of the diffuser. So अब total एक जब करने वाला है तो why should I apply two of them in the room? Room की complete capacity is 1200 to be accessed as per the capacity of my AHU, right? तो एक supply एक return में लगाने वाला हूँ. Where to apply the supply, where to apply the return. This is how the duct is going to run. ये room में से पूरा ऐसा है. यहाँ से entrance है और ये पूरा exit है आपके पास. So now think and tell me where to apply that one. इसको B कर देता हूँ पहले. ये क्या है? SCG. जी बोलिए. नॉर्थ में एक सप्लाई. The supply grill that we are going to maintain is where we are going to keep it from there at this position here. In the beginning stage from where the duct is going to rule out its air. यहाँ से duct is going to move one pressure drop here and it is going to leave the connection inside the grill to start facing में रहेगा. ठीक है चलो. नॉर्थ में आपने बोला करेक्ट आंसर. मैं इसको रोटेट कर लेता हूँ. रोटेट करके वहां पर प्लेस कर देंगे. सर रोटेट हो रहा भैया. यहाँ पर so you have to come up there and then you have to place it. But you see usually ऐसा mistake यहाँ पर हो जाता है that the face also goes inside the ceiling. Placement के टाइम पे ठीक है. तो इसको best place करने के लिए you have to just use the move command, select the overall thing. Alright. पूरा चीज को ऐसा select करेंगे. अब तो वो ब्लॉक में बना हुआ है राइट. पूरा select हो जाएगा. Just zoom total ठीक है. वहां पर से लेकर उसको नीचे की तरफ यहाँ पर अपना ऑर्थो ऑन करके प्लेस कर दो. अपने आप उसी जगह पे वो मिड पॉइंट का ख्याल रखते हुए नीचे बैठ जाए. वेरी वेरी नाइसली. सेम गोज टू द सप्लाई ऑल्सो. ठीक है. यहाँ पर तो अभी प्लेस हम लोगों ने सही कर दिया. प्लेसमेंट के टाइम पे वहां हो सकता. बट लास्ट टाइम दैट आई हैड टोल्ड कि इन्फिल्ट्रेशन होने की वजह से हम सप्लाई उसके करीब नहीं रख सकते. यहाँ पर भी डोर ओपनिंग है. अब यहाँ पर हाउ इंतजाम इज गोइंग टू टेक प्लेस. बट आई एम गोइंग टू से दैट दिस इज द ओनली पॉसिबल वे टू अप्लाई द ग्रिल. सो हाउ आर यू गोइंग टू गिव द डिक्लेरेशन ऑफ इन्फिल्ट्रेशन इन रूम 2 इन रूम 1. इन्फिल्ट्रेशन होने के चांसेस है या नहीं है वो एक्सप्लेन कैसे करेंगे आप. ग्रिल सप्लाई ग्रिल तो सबसे करीब में इट इज नियर द डोर. अब ये डोर है. इधर इज माई सप्लाई. हाउ इट इज गोइंग टू कंसिडर और कम इनसाइड इन्फिल्ट्रेशन और इट इज नॉट गोइंग टू कम इनसाइड इन्फिल्ट्रेशन. सो बिकॉज द ग्रिल एज बीइंग ए नर टर्मिनल इट इज अ साइड थ्रो प्रोसेसर. साइड में थ्रो करता है वो. डिफ्यूजर क्या था? ड्रॉप दो प्रोसेसर था. वो ड्रॉप कर देता है एयर को जिसकी वजह से मोर वेस्टेज इज गोइंग टू कंसिडर. नाउ हियर यू कैन आल्सो सी दैट देयर इज ओनली वन सप्लाई यूनिट, one supply grill, so that is throwing totally of 1200 CFM into room 1, right? So जैसे it is going to throw the air is moving directly in the सामने के direction में. That is why the return is taking from there. All right. So the moment it is throwing the air, it is maximum covering maximum spaces of all orientations inside the room rather than only the below area. All right. हवा ऐसे flow नहीं हो रही. Air is flowing in this direction. So the more the space, more the air is going to be taken care of. All right. That is what works in the central AC system. All right. So वहां पर infiltration अगर होने भी वाला हो तो that much of loss is not maintained जितना एक diffuser में होने वाला था. All right. Maybe there will be some bits and spaces. That's why you have to take a safety factor and run. 1200 में से maybe 1150 is only coming in our hand. 50 CFM जा रहा है हाथ से. Not a problem. तो वो आने की वजह से ओवर टनेज लेना है. अंडर टनेज नहीं ले सकते. आई बात समझ में. तो that is why we have to consider by keeping it near to the wall where the emergence and material of the duct and everything is also going to be considered. Next thing from here, we have placed the air terminals for both the rooms. That is done. उसके बाद next thing क्या है? Duct routing. Point number 3. Now, in order to understand the duct routing, what you need to do is, I will first create a different layer so that there is no confusion of colors. I will write SAD supply air duct, and I will take light color for that. And from here, we know that it is going to begin from the mouth of the AHU. So keeping my ortho on, AL enter, I'm going to provide some thickness from this center point, W enter. I'll take off 75 and 75. You can see that there is some thickness. दिख रहा है ना? Or I'll take 100 directly. दिख रहा है ना ये काफी. So from here, now we know कि एक AHU के बाद से what are the other supplements that are going to be connected? क्या क्या होंगे? There is a canvas cloth for cutting down the sound's vibrations. Then there is going to be a mouthpiece for fitting the mouth of the supply air duct properly and directly the supply air duct with the installed fire damper at the beginning. All right. Now from here and until here, we have always considered only the width and height of my ducts. Remember, there is no use of considering the length. हर जगह पे वो बदलने वाला है, the length. All right. Now here, as per the assumption, if I'm going to take my duct यहाँ से यहाँ तक maintain करना है, जहां तक it is going to be closer to the door, closer to the wall, एकदम यहाँ से यहाँ तक भी नहीं रख देना. All right. उसको निकालने में, सेट करने में बहुत प्रॉब्लम होने वाली है. Second thing you have to remember always when you're going to do a supply air duct, it is going to be pre-fabricated, pre-installed. Installation के साथ आएगी वो, तो ठीक है. तो उसको installation के लिए जगह छोड़ना जरूरी नहीं है, क्योंकि उसके अंदर installation होता. All right. तो आप consider ऐसा अगर करने वाला है, यहाँ से you're going to turn left and right thinking that oh no, but I cannot take the offset for installation. All right. इसको installation की जरूरत नहीं है, but इसके branches जो निकलेंगे उनको installation चाहिए. All right. तो उन चीजों का ख्याल करते हुए you have to leave that much of gap at least. All right. This is the way the SLD drawing has to be created. So many things to remember. Now suppose I have kept until this position here. Since it is a complete polyline drawing, it will be continuous. We know that. All right. Now the area for me to cover inside the room 1 is much smaller than the one that I have to consider in room 2. लंबी duct पड़ेगी room 2 में. यहाँ पर it is going to be small. Why? Because the duct is flowing till here and it is going to turn directly into the grill. We are not going to do like that. We have to let the duct leave out at least nearly 4 inches after the space of the neck of the grill. कम से कम 100 mm more. कम से कम. उससे ज्यादा भी छोड़ सकते. क्यों आपको छोड़ना चाहिए is a very very definite reason. And that reason is कि यहाँ ही अगर हम duct को end कर देंगे, there is going to be a lot of turbulence. The air is going to go until there and it will know कि यहाँ पर जगह खत्म हो गई. वहां move होते होते it is going to push too much of that much side. And why? Because directly 1200 CFM is coming out from one grill. All right. That much of speedy air is going to consider and come out of that much of grill. तो air के पास it has to not have exactly the end face जहां पर grill is also ending. There has to be some more space left for the air to bounce back and enter the grill. Always. If we are not going to leave this much at the time of maintenance, take the center point of the grill and attach it this way. Trim the extra parts. This is not a part of the duct. Duct आपकी यही है. This I am showing how the air is going to flow. क्योंकि इनकी जगह पे directly collar and shoe neck आने वाला है. To show the how air is going directly inside the grill and it will start to flowing. Grill and duct, grill भी एक ही है, duct भी एक ही है. This portion is only to show that there are more supplements going to come down. This is not a part of the duct. In the DLD, you will come to know the conclusion. All right. Now from there, what you need to understand is how you have to consider the ducting in this portion. All right. For doing it here, use your polyline once again. I am going to start creating the duct. Now what I have is एक supply यहाँ पे, एक supply यहाँ पे. This is 600, this is 600, total inside the room 1200. Right. Now what are the possible ways I can show my ducting? And only I want to show ducting for supply units. No ducting for return. Use a polyline, come until this position. You will not know where exactly is the half of the room. All right. First try to, with a normal line, divide the room into again that many halves. Why? Because PL enter then is going to be supposedly follow the same path until the extension of the last supply. Considering the same thing here for turbulence, you can see supply यहाँ पर end हो रहा है and end of the duct is not there. थोड़ा हिस्सा ऊपर छोड़ना पड़ेगा. Now select the line and delete that, and that is done. Now I have two different supply units. Now it is up to me as being the designer if I want to give both GI sheets, subducts, or it is up to me if I want to give both of them flexible ducts, or up to me if I want to give one flexible duct, one GI sheet. Three options are there. ठीक है? We are going to see the process of both in the drafting, so I'm going to consider this one only for GI sheet. PL enter, consider this one, the duct continuation from this side. This is going to be GI sheet. This one is not going to be with GI sheet. This is going to be considered with a flexible connection. तो उसके लिए you will have to draw one SP line. Starting from here, keeping ortho on. ये यहाँ तक लिया, ये यहाँ तक, और ये यहाँ तक इसका सप्लाई बटरफ्लाई डैम्पर प्लेस कर देंगे इस तरीके से। आपको पूरा फ्लेक्सिबल डक्ट ड्रॉ करने की जरूरत नहीं है, एसपी लाइन आपने ड्रॉ कर दी, वहां पर फ्लेक्सिबल कनेक्शन आ जाएगा, समझ जाएंगे। ऑलराइट, फिर उसका शेप को चेंज करना है नहीं करना है टोटली अपने हाथ में। थोड़ा सा यहाँ पर मे भी उसको और पुल करना है आपको इस तरीके से या इस तरीके से नीचे। ऑलराइट, इस तरीके से करके मे बी यू डू नॉट वांट इट टू टर्न दिस मच, you can take it down like this, you can make it again like this, up to you how you want to do, you can try to make the consideration. All right, a flexible duct वहां पर आ जाएगा। The same thing you can do here, इसको GI sheet बना दो, इसको flexible duct बना दो, not a problem. Branch and air is going to flow, कितना 600 in this, 600 in this, right? So ducting is also done, the maximum ducting is this much. After that one, what is the fourth point is applying the accessories. What is the possible accessories maybe I will be requiring, सिर्फ प्लान को देखकर बोलो। फायर डैम्पर्स इन ऑल द थ्री साइड्स, यहाँ पर एक फायर डैम्पर, यहाँ पर एक और यहाँ पर एक। उसके बाद से और क्या चीजें चाहिए? ये आपका फ्लेक्सिबल डक्ट है, फ्लेक्सिबल है तो यहाँ पर क्या आ जाएगा? बटरफ्लाई डैम्प। नेक्स्ट, स्ट्रेट ले सकते हैं ऐसा। जैसा एक एग्जांपल बताने के लिए एक प्लान में मैं दोनों चीज को कंसिडर कर रहा हूँ। आप इसको नहीं, ऐसा नहीं चाहिए तो आप पॉलीलाइन लेते हुए आपने आपकी प्रैक्टिस में आप ऐसा भी करो, पॉलीलाइन लेते हुए ऐसा उसको डक्ट को अटैच करके रखो, कोई बात नहीं। आप वैसा दोनों चीज को भी वही कंसीडर कर सकते हैं, दोनों को फ्लेक्सिबल भी बना सकते हैं, कुछ भी कर सकते। सीरीज में अपने को जो चीज प्लेस करना है, एज आई टोल्ड, फायर डैम्पर्स रहेंगे एट द बिगिनिंग ऑफ एवरी डक्ट फॉर सेफ्टी पर्पस। देन यहाँ पर बटरफ्लाई डैम्पर इफ देयर इज अ फ्लेक्सिबल डक्ट। व्हाट मोर? शू नेक तो बहुत सारे आ जाएंगे, ठीक है। यहाँ पर एक शू नेक लगेगा, यहाँ पर शू नेक लगेगा, ये वाला भी डक्ट है, यहाँ पर शू नेक तो नहीं लगेगा, क्यों? वहां पर बटरफ्लाई डैम्पर है, वो एक शू नेक के जैसा ही काम कर। नेक्स्ट, हाँ एल्बोस, तो एल्बोस यहाँ पर आएंगे, एल्बोस तो फिटिंग में आ जाता है ना। हाँ, वीएवी आएगा बॉक्स, ये वाला रूम अलग होने की वजह से यहाँ पर एक वीएवी बॉक्स, ये रूम अलग होने की वजह से वीएवी बॉक्स आएगा। तो उसके साथ क्या आएगा? थर्मोस्टेट्स आ जाएगा फॉर जोनिंग, तो टेम्परेचर रीडिंग फॉर इंडिविजुअल इंडिपेंडेंट जोन। यहाँ पर से आपके पास आ जाएंगे फिटिंग्स के अंदर शॉर्ट रन एल्बोस, यहाँ पर डायरेक्टली आ जाएंगे कैनवस क्लॉथ की फिटिंग, माउथ पीस, एंड देन द नॉर्मल डक्ट, राइट। एंड वो ट्राउजर पीस, वही दो एल्बोस लगा दिया, ट्राउजर पीस बन जा रहा। एंड यहाँ पर क्या आपने को चाहिए तो अपन एक वीसीडी डैम्पर भी लगा सकते, वॉल्यूम कंट्रोल डैम्पर, सिंस एक डक्ट सिंगल जीआई शीट होने की वजह से। ऑलराइट, फॉर कंट्रोलिंग द वॉल्यूम 600 इज द मैक्सिमम कैपेसिटी, उस 600 से ज्यादा उसमें नहीं गुजरना बोल के वीसीडी डैम्पर लगाना। ऑलराइट, अब दूसरा चीज उसके अंदर और क्या है, अपने पास एक रहेगा मेंटेनेंस पर्पस के लिए ट्रैप डोर पीछे। इट इज हैविंग टू नेम्स, ट्रैप डोर या एक्सेस डोर। वो फॉल सीलिंग के अंदर से आपका ऐसा स्लाइडिंग डोर रहेगा, जस्ट एंड ओनली टू क्लीन द बैक साइड ऑफ द एएचयू। ऑलराइट, तो वो कंसीडर करने के लिए आप एएचयू डोर आप टोटली पीछे नहीं लगा सकते, ठीक है। तो वो क्या है आपका एक्सेस डोर या फिर ट्रैप डोर, उसका नेम वो है। आई एम गोइंग टू राइट दैट ट्रैप डोर, एंड दैट हैज टू बी शोन इन डॉटेड लाइंस वगैरह। तो आई विल कंसीडर दैट टू बी इन डॉटेड लाइंस, हिडन, एंड उसका कोई इस पर्टिकुलर साइज वगैरह कुछ भी नहीं है, क्योंकि वो स्लाइड होने वाला है, राइट। सो आई एम क्रिएटिंग अ रेक्टेंगल स्मॉल, ऐसा थोड़ा सा कुछ, कोई भी कैन यूज एन एलिप्स इन बिटवीन। आई एम क्रिएटिंग एन एलिप्स फॉर बाउंड्री क्रिएशन, ऐसा। एंड लास्ट में यहाँ पर आई विल जस्ट ड्रॉ वन सर्कल along with a ellipse again. हैंडल के जैसे, सिंपल एज दैट। ये क्या है? डॉटेड लाइंस में, दैट मींस वो शो नहीं करेगा। वो पार्टीशन बना हुआ रहेगा अपने फॉल सीलिंग में, राइट उसको सिर्फ ऐसा मूव करना है, ऊपर की तरफ एक आदमी विल बी स्टैंडिंग इन फ्रंट ऑफ द फेस, देयर विल बी AHU whatever it is kept near the box, the cleaning will be done. Why? So that the process, the return जो जाएगी यहाँ पीछे, there is a filter on that AHU, ठीक है, alright, it has to be very clean for the return and the fresh air to get engulfed back into the AHU. Alright, so you require a trap door or access door, both the names are same. Plus ये तो है अंदर का consideration that from the air is moving, you will require to have different sorts of OTS also. What is an OTS? OTS, full form, open to sky, or else it is also called our plumbing service wall, or it is also called civil shaft. That portion of the building जो नीचे से लेकर ऊपर तक open रहेगा, that is called open to sky. All right, अब that if it is inside the building, from there is what your civil shaft is going to run. The empty pipes, water pipes, drainage pipes, कुछ भी sewage pipes वगैरह usually जो building के पीछे से जाते हैं, कभी-कभी बीच में से भी जा सकते. So from that particular place also we have to generate an opening for the fresh air to get inside the AHU, right? So here I am going to consider that in one position on this side, I have a gap between the two walls. I am creating one OTS here so that I can get little fresh air directly from there into the backside of my AHU. Along with the 70% of return, 30% fresh air यहाँ से भी आना चाहिए. एक दूसरा OTS I am going to generate on this end. एक भी रख सकते हैं. We are keeping two just for example purpose. ठीक है, एक वॉल के पीछे साइड, एक वॉल की ये साइड. आप सपोज उस तरफ भी नहीं रखना है आपको, next thing what you can try to do is create just a have on both the sides. इसका ही opposite में यहाँ पे इसको if I'm going to mirror, first pointer mirror line suppose यहाँ पर लेकर I am going to place it on this side. Two different OTS for me and the beginning of two different rooms, right? After you do this much in the complete drawing, I need to place the fire damper again. LA enter, fire damper. Fire damper, we know how to create that in the SLD drawing. Sim take PL enter, the width is already uploaded. Keeping ortho on, from this end, नीचे का nearly 150, the handle, this much. Wall के पास, so that it fits properly with along with the hangers. यहाँ पर भी कैसे draw करेंगे? PL enter and 150 this side for the handle. And now I want the same thing on the other side. Let me check if I can mirror that in the center of my wall here. आ रहा है उस तरफ? Yes. That is also done. Next I need to create a butterfly damper. Butterfly damper. Colors can be used anything. There is no approximation on that. How do we create a butterfly damper? We have seen it is 100 by 250. Which command to use inside? Donut. 20 inside, 25 outside. Do enter, 20 inside, 50 outside. This is cool. Line, ortho off. TR double enter. Take and place it here. अंदर से you have to delete the flexible duct. Trim it. Like that. That is also completed. So we had different this ones. Now the VAV box, the thermostats and VCDs, I will try to develop that originally in the DLD, right? So that only VAV and thermostat is remaining, so we will do in that one in DLD. Next class will be just the approximation. इसको DLD में कैसे convert करना है वो रहा है, right? But before that I need to enter the text to give the information. Whoever is going to read the file should be informed that what is the information of room 2 and what is the information of room 1. So since it is room 2, we are going to use which one? Air terminals is SCD SCD का एक कैपेसिटी कितना है 600 CFM each. यहाँ पर आप लिखेंगे in brackets how many numbers 2. ठीक है, CFM 600 CFM each हो गया. Match with 50. Place it there. Copy in this room. यहाँ पर क्या है SCG number is 1. SCG individually it is 1200 CFM each निकाल दें. ये भी आपका अप्लाई हो गया. Now when we are going to consider this in the DLD में इसको ब्रेक करके ऑफसेट करने के लिए आपके पास इसका रीडिंग मालूम होना चाहिए कि ये है कितने का और कितने पे इसको ऑफसेट लेना. So we are going to decide the sizes here itself to take the offset tomorrow. I'm going to consider the main duct at 600 by 300. Okay, and the branch ducts are going to be considered at, for example, 300 by 300. This side also same. Return ducting इसमें नहीं. It's a plan without return ducting. If you are going to consider return ducting, same way जिस तरीके से duct यहाँ पर से है, you will be taking a duct from this end and a duct, एक और एक duct यहाँ पर ऐसे पास होगा, एक इस तरफ एक इस तरफ, right? Same जैसा ये पोर्शन है ना, opposite उसका, and that is going to consider on back side of the edge. जैसा सामने से आ रहा है वो पीछे से चले जाए, उतना ही, right? Since because we were considering to show you more of the trapdoor and etc., we have eliminated that part into the SLD and DLD drawing. All right, not necessary कि every time you try to take off with return only. Very very large projects अगर रहेंगे तो return ducting becomes compulsory. Small अगर villa projects हो या फिर classroom projects हो या school projects वगैरह हो, you have to leave the return. वो how the machine is going to take that, it is going to suck it from the open complete space inside the false ceiling जो भी रहेगा, the hot air जो it will be moving, there will be a suction category inside the filtration of the air जो उसको emerge करके ऐसा अपने आप अपनी तरफ खींच लेगा, right? So that is why the return is here ductless. Supply is with the duct. Supply cannot be ductless, right? In major projects, the duct return के लिए भी ducts अगर चाहिए हो तो return ducting आप कर सकते, like that. The example that we have taken care of is as such this one. Okay. So now I'm going to delete the rest of the portions that one we have. If you want, you can practice with the return duct also in this project. इसमें आप लोग को और detail मिल जाएगा, right? I'm going to first save this file. HD94 drawings SLD Airside. And from here, the main thing or the first step that you need to understand inside the AutoCAD file is to first, whenever I'm going to click over the duct, आप देख सकते हैं it is a continuous process. If I'm going to take any offset or if I'm going to do any fillet, it will be applied all over. That is one instance which we do not want, because this in itself is one different identity. It is SAD, supply air duct. This is not a part of SAD. It is a branch duct. और यहाँ पर भी, even though it is a continuous branching, all right, from here onwards, then again it has a sub branch of GI sheet, and this has a sub branch of flexible duct. All right, again I cannot try to maintain this on same levels, means I cannot try to have this in continuous motion. So I'll have to first explode them. Select this one and explode, then again select this part and explode. Why? Because the exploding is different as per the sizes. You can see here the SAD is 600 by 300. While the branch ducts are 300 by 300, so the offsets will be different, right? I'm going to take the explode because this is entirely going to be very different. And now from here, the first thing that I'm going to do is, before I'm going to manage to do this, the offset as per 600, I'm going to draw the other things that are required to fix a SAD. That is nothing but the canvas cloth and the mouthpiece, along with the fire damper. That will be coming back to the fire damper in the end at the time of applying the accessories, right? So we all know how to create the canvas cloth. We have seen the measurements. Let me see if I have the layer for that. No, we do not have the layer. We're going to create a layer, canvas. I'm using a yellowish color for that, little. Keeping my ortho on, align. Okay, offset for 25 at some numbers, 7 times, 8 times, however you require. The DLD is going to be the complete required drawing, so nothing can be missed there, right? So this is enough. We're going to join the lines, zoom in one particular space, using your raw snaps, just join all of them very conveniently and very quickly. Taking an offset from this side again for 25 mm. Turning the offset off and the ortho off. Take line command once again. Leaving the first and last one. From the second line, create a conical shape. Using the cross window method, select the front lines and delete them. Similarly for the rest of the inner lines. The first one, last one also gets deleted using TR double enter. Trim off what is not required. This is established on one end. Keeping the ortho on, MI enter. Select most of the items that we require, not the whole thing. MI enter. Everything is done. Take this part and see if it is following on the other end. Yes, very nicely it has been created. Using the trim command once again. This is done, right? Since the canvas cloth is also completed, we now know we have to draw the mouthpiece. So very quickly, now taking an offset for 300 individual sides. This one, keeping ortho off, using your polar tracking at an increment of 45-degree angle, taking L enter from this end, maintaining that at 45 degree in the third quadrant. From here once again in the same L enter, join these parts, TR double enter, create the mouthpiece, and you see it will not be deleted for these lines. Select individually them and just delete them. TR double enter once again. Use the match command to match them with this side. Mouthpiece is also created. Now since you have taken the offset for SAD, we need to take the offsets for the branch ducts as well. So offset for 150 here, ortho on, one above, one below. Why we are taking 150 offset? Total width is 300, right? That is clear. Maintaining the same thing here again. An offset for 150, this side and this side. This is going to be entirely different. Now since we know that it requires a trouser piece, we have to go for applying the short run elbow on both the ends, right? Very easy to understand. I'm going to move this text. I don't want that to come in between. So we have 600 and 300. We are going to take the F enter, R enter for how much? Formula wise? W by 4. How much is going to be the result? How much is W divided by 4? How much? 150. 600 divided by 4. It's going to be 150. Repeat the same on the other side. Offset would be for 300 as per the size of the branches. Done. Trouser piece is also established. Now we do not require this center line. Delete that, but we cannot delete that on the branches. We still have some work. Okay. Coming back on this position, we know that there is a turn here and there is ample of space. Which elbow can I apply? Long run, right? So that would be 300 by 2. The fillet would be again 150 for that. 150. This end match with this end. Total offset for 300. Use the line. Done. We need to close the duct at this position, so I'll enter. That is also done. Yahan tak we have understood how to do and what to do. The next step after developing the what you call the ducting, we need the actual positions for applying the diffusers. मतलब diffusers are still created in SLD. Right, उसको DLD में convert करना पड़ेगा along with the arrows and arrow indication for supply and for the return. Now we know that we have created this yesterday in block. So I can just double click that to edit the block editor. Go there. We are going to convert that into the actual SLD. So take the offsets inside. Lastly, we need PL enter to create the arrows. Width is already applied too much. Make it less. Then give the arrow indication for the tail first. Then W enter. Starting with maintaining 30. The other one 0. Lastly 90. Move for a displacement of 50 mm. जी कलर अभी मैच करेंगे उसके साथ. AR enter. AR enter करने से पहले ही मैच करना पड़ेगा उसको. AR enter. Select it. Polar. Axis of rotation is this point. 4 and 360. This is done. Remember, if you're going to do in the block editor, it is going to be applied on all the sides. मतलब मैंने एक को किया, दूसरा diffuser भी अपने आप create हो जाएगा वैसे, right? Close the block editor, save to SCD, and then you can see the changes on both the ends, right? तो एक को करेंगे, दूसरा भी apply हो जाएगा. Same thing is for the RCD. Taking an offset for 50. Use polyline or PL enter to show the arrow indications from behind, right? It's going to start with width, 0, enter, 30, enter, 90, enter. Continuing with W, W, enter, 0, enter, 0, enter, L, enter, 30, enter. Lastly, take M, 50. Match with the layer RCD. AR, polar, center point 4, 360. Save, and that is also applied. Clear? So the clarity has been obtained for dealing that with the SLD and to DLD. Same thing applies for here. ये already SLD DLD make जैसे ही दिखेगा, right? We do not have to do except for the arrows. So we are going to get back to the SCG. Click OK. I'm going to first click over this side. PL enter. 30 enter. W enter. 30 0 90. Escape M. Now we need to copy. No, we cannot do the array there. Such it is, there is no this one towards. ये भी हो गया आपका SLD में converted. अब यहाँ पर देखिए ये अंदर जा चुका है, इसको भी क्या करेंगे, बाहर मूव कर लेंगे. पिक पॉइंट सेलेक्ट कर लेंगे तो बेटर होगा. Now let us create the flexible duct, right? For creating the flexible duct, we need the small segment. I need to create a layer for that. I'll be calling that segment. And I'll create flexible duct in which color? Pink color. Pink ही है ना उसका वहाँ पे? SAD पूरा pink में है ना? हल्का सा light pink कर देंगे. The size is going to be 25 by 100. You can take any particular sizes. Exploring. Offset for 25. One above, one below. Keeping ortho off. Selecting the other horizontal lines. Deleting them. Converting to block, I'm going to call it the flex. Maybe I'll not name anything, I'll name it 1. Coming here using the measure command, select to measure. B enter, number is 1, yes, 25, that is done. Whenever we are going to show the connection of a flexible duct towards something on a diffuser, it has to be connected like it is connecting to the plenum box, right? So keeping that on, from the second portion, just try to drag one pink color box. It shows as if it is going and connected to that plenum box, and the plenum box is then connected to the neck of the diffuse. Same thing has to be done on this side, but when you will be taking care of this GI sheet, that time you can do that one. All right, for the dropper. And what else I need to convert? Firstly, the fire damper is going to look entirely different. Let me just take and delete that. मतलब position वही रहेगा लेकिन अलग तरीके से आएगा. These lines are done. This line is also done. इसको क्लोज कर देंगे, ये वाले को निकाल देंगे. I'll take my SAD for no double works. I'm going to draw 2 lines, keeping my ortho on. यहाँ से और यहाँ से in continuously inside. And I need to create a new layer for shoe neck. Take that in blue. शू नेक को कैसे करेंगे हम लोग? मिनिमम कितना होना चाहिए और फॉर्मूला के हिसाब से कितना रहना चाहिए? फास्ट L is equals to how much? Minimum 100, otherwise W by 4. So W is how much here? 300 divided by 4 will become 75. So I cannot take 75. So I'll have to take minimum of 100 offset. So offset for 100. As per the thumb rule, that is going to be that much, right? Now that you can see it is created, I need to do it with the polar tracking for 45 angle on this side. Join the line, trim out the extra line that is not required, that is the shoe neck below, and just followed by the shoe neck jo upar, which is connecting the mouth of the shoe neck and the neck of the grill, is what is your collar, right? Automatically collar आ जाएगा जब आप shoe neck draw करेंगे तब, right? ये 100 ही है ना यहाँ से? Right. So ये आपका shoe neck और followed by that one is completed. So connection towards the grill is also done for the supply. Now we are going to talk about this part here and then how to apply the reducer for the other end there. When I'm going to talk about this sub grill, what I need you to understand and give me the answers for is the aspect ratio. इस चीज को शो करने के लिए first I'll be drawing for you little bit of a section drawing so that you can understand and give me the correct answers possibly. Think that the 300 mm duct ये वाला है जो run हो रहा है सामने, and अब उसके अंदर you are going to create one duct this way in connection. This is by sub duct, this is the branch duct. Okay, this one that I'm showing here, ये वाला जो है, this is this part. हाँ, this original part is the above one. तो ये उसका section view है जिस तरह से हम लोग देख. आप कभी भी अगर ये duct का size you know it is 300 by 300. Very clear. Now I'm going to apply a sub duct whose neck face is again 300 for the diffuser. तो मेरा duct अगर same 300 by 300 size का रहेगा तो इसमें कैसे fit होगा? It has to reduce in terms of width and in terms of height, right? Because both the same, if this is one quantity, इसके ऊपर आप इसके जैसा, it is by keeping the aspect ratio thing in mind, that is long side by short side, right? So how much and what is the range for the aspect ratio to be maintained? Less than 4 it is going to be convenient, it is going to be allowed, but if it is very closer to 1, what does it say? That's a perfect square. Perfect square in terms of being the duct. अब अगर मैं 250 by 250 maintain किया, aspect ratio would be how much? 1, right? It is going to be long side is 250, short side is 250 is equals to 1. So this aspect ratio जो 1 बन जा रहा है, if it is very very close to 1, it's going to be a perfect square. PS. अगर वो 4 के नीचे रह जाता है, less than 4, it is nothing wrong. It can be 1.5, it can be 2.5, depending upon the two different sizes. Now, keeping this thing in mind, my duct, branch duct is running like that, and this is the sub branch that is going to take place. So here already we know is 300 by 300. Now here, what do I need to change first, the W or the height? 250 is going to be 125, offset for 125. एक ऊपर, एक नीचे, इस तरीके से, right? अब यहाँ पर again, because there is a turn that is taking place, I will require to apply a shoe neck. I am in the shoe neck quantity. Draw this one line. How much is this? It is 250. Divisible by 4 is not nowhere going to come close to 100. So offset for 100. इस तरफ से आएगा. Why? Because the air is moving from this side. That way it has applied. यहाँ पर भी keeping ये segment का ले लेंगे. I will just draw the plenum box. Done. जी हाँ, increase करना है. जी, आप रख सकते हो उसको 4 inches extra, करीब करीब. बीच में से this line is now not required. The only thing this will require now is a which damper? VCD. A volume control damper has to be applied after the movement of the air inside the duct. Why? By 250. This is done. So right. Now, what else do we have in making the actual procedures right? यहाँ पर से the DLD is converted this way, right? Fire dampers आना है, VCDs आना है, VAV boxes आना है, thermostats आना है. Let us create the fire damper first. We all know how to create the fire damper in terms of DLD. I told you to take the exact width of the replacing wall that is there behind. Exactly आप लोग को उतना length and width मिल जाएगा to fix it, right? Because it is going to be in the starting. After that one, you are supposed to use lines, cross lines. Lastly, a circle of any particular dimension. Just shouldn't PL enter straight line. I need to apply some width. I'm going to apply that 75 by 75 to make it look like exactly the same. थोड़ा सा आगे pull करके छोड़ेंगे तो it will be easy for you to do the trim. That is done for the main duct. Coming to the branch duct, this is a wall surface area that we have there. We are going to do REC once again. Use my turn off ortho, do it this side, C enter, PL enter, ortho on. That is done. If it was converted to block, I could have replaced it this side, but let me still try if I can mirror it, this one. Oh yes, it is coming. फायर डैम्पर भी हो चुका है, इसको भी तरह मूव कर लेंगे. Next, I need to apply my VAV box along with the thermostat. There are two rooms and there are two branches into the rooms. In this place, I can very suitably apply the VAV box until here, in between. Connection जिसका should not go very far also ताकि मैं connection ना दे सकूँ thermostat का अपने room. Thermostats are usually to be supported near the wall. Okay, near the walls you can place them anywhere. यहाँ पर भी ये जगह है और यहाँ पर भी you see I have somewhere near to this wall or somewhere near to this wall, right? So I can try to place them, and to create the VAV I need a different layer. VAV box, thermostat. VAV box is going to be in bluish color. Thermostat mera is going to be in same color. सेम कलर भी रख सकते, थोड़ा सा हल्का सा लाइट ब्लू कर देंगे, डिफरेंट कलर ले लीजिए, कोई बात नहीं. आ गया. यहाँ पर आए VAV बॉक्स, कोई भी स्टार्टिंग प्लेस पर, नॉट वेरी फार. यू कैन ड्रॉ इट इन अ स्क्वायर, ठीक है? थोड़ा सा आप उसको गोइंग टू मेंटेन दिस मच. This is going to be the front face of the VAV box. Zoom in and try to create one more rectangle in order to show that there is a sensor switch to which, using the SP line, is my thermostat connected. As room के अंदर की तरफ. Suppose this is where I'm trying to place it. As from here, try to create a circle. My thermostat, I'm trying to show it in circular mode. TR double enter. We do not need the wire inside. Maintain at some text. T enter. T 50. Okay, that is slightly bigger for that. 30. That is a thermostat connected. This is a sensor, and here again I'm going to use my VAV box name. Oh, that's pretty small there. That is good. These two things match with T, thermostat. All right. Same thing आपको इस तरफ भी create करना है. You can try to take the mirror, but you are not aware that the same walls are going to be on both the ends, right? So the duration or the indication for the thermostat can change. Better try to maintain or try to create once again. Keeping the VAV box not very far. I'm going to draw it from this end, this much of gap. Once again, a small sensor switch. SPL, enter. So remember, sensor switch के ऊपर के end से ही your wire has to begin, and you can frame it in any direction. Some people try to frame it कि actual try to make it look like a wire by making it of this particular shape. You can do it anyway. Wire है वो, कैसा भी रह सकता है. ऊपर से वो जो भी रहेगा ऊपर की तरफ रहेगा, आपके physical area में नहीं दिखने वाला कैसा. Only the thermostat and the buttons are going to be seen inside the zone. You're going to create a circle here. TR double enter. Just do that. T enter. T. That is done there. Selecting these two, match with T. यहाँ पर भी, यहाँ पर करने के लिए I have copy command. VAV box with thermostat is also done. I require a VCD damper here. LA enter. Any new item that we are going to apply, उसके लिए new layer होगा कभी भी. Take this one. VCD damper आपको यहाँ पर place करने के लिए simple method is use a polyline of some width. It is 75 mm currently, the last entered width. इस तरीके just place it. Use a normal line from this end, इतना सा, from this end थोड़ा सा. You can just take 400 mm also, not a problem. This is how your VCD looks like. All right. And what you need else, where I have the trapdoor also, I have that also. We are ready to swing with the insulation, right? सब कुछ तो हमने apply नहीं, butterfly damper है ना वहाँ? That is going to work the same way. Yes, we are going to look forward to do the insulation for the main duct. And main duct में, as I told, it is going to be पहले से pre-insulated always. उसको निकाल कर उसके ऊपर से ducting नहीं कर सकते. So we are going to do some hatching in order to show the insulation from inside. H enter. Use a different kind of swatch. I'm going to use one among the ANSI. I'll take 135, 137. Color to be used is going to be very, very light color. This one. Selecting this part, this boundary, and the last one. Mouthpiece. Pick point. You have to click there. You have to click in here. You have to click in this end. Check for the preview. Can't see anything. Make it 200. Too big for the eyes. 50. Pretty decent. 30. Perfect. And done. Okay. ये insulation है, इस तरह से पता चलेगा. The insulation is done on this side. I'll do I have to create for that also a caustic insulation. Now for the thermal insulation, I'm going to take green since it is related to thermal, and I do not want continuous lines but hidden lines for thermal insulation. Hidden line is also done. The remaining part is for doing the insulation on overall ducts from यहाँ से लेकर यहाँ तक. That is insulation on outside. For doing the insulation on outside, I'm going to keep my thermal insulation active. Since this is single part and every duct is having a single part there, it becomes easy for me to take the offset. I'm taking an offset of only 12 mm. Very less doing it outside. This offset जो बाहर आ गया है, select this and try to match it with the insulation. You can see there are dotted lines along with that. I am taking only very less, half of a 1 inch, what do you say, inch again. Right, 25 mm becomes proper 1 inch. आप 25 mm भी लेके कर सकते. यहाँ पर मैं आपको बताऊंगा कि 25 mm लेकर आपको किस तरह से वो लिखने वाला है. MA enter ये और यहाँ पर. This much of gap you can understand, right? Take 10 mm again. I'm going to do for this side, then we are going to do it for again this side, here again. यहाँ पर भी सब चीज के बाहर आएगा. यहाँ 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 insulation does not go inside the duct since it is privileged to be the thermal insulation. हमेशा बाहर की तरफ रहने वाला है. हर तरफ, हर जॉइंट पे कंप्लीट करना पड़ेगा उसको इस तरफ से. यहाँ पर भी, यहाँ पर, very conveniently on the other side. Lastly, what you have to do is select most of them or maximum of them and match it with the layer. दूसरे जगहों पे you can just match, MA enter. यहाँ एक match, यहाँ पर. Be very keenly to do that. Do not do the mistakes. You can see there are no joints applied. Joints हमको करना है. यहाँ पर you have to trim the part that is inside. यहाँ पर आके you are going to end it ऐसे. अंदर नहीं जाना चाहिए. There are some joints that we need to work on. किस तरीके से इसको join कर सकते हैं best way. Fillet radius with 0. F enter, R enter, 0 enter. जल्दी हो जाएगा ना काम. और कहाँ करना है. ये देखो इसमें भी से भी जा रहा है. जहाँ जहाँ से जा रहा है वहाँ से ट्रिम. ड्राफ्टिंग में आपको कभी भी चीजें इसलिए ट्रिम कर देना इंपॉर्टेंट हो जाता है. यू हैव टू, जब सामने वाला आपकी ड्राइंग रीड करे तो ही शुड नॉट फेस एनी कंफ्यूजन, राइट, कि व्हाई दिस थिंग इज आल्सो डन देयर. नाउ यू सी this one, this much part, all has to be very neat. The more representative you make your drawing, that much creative it is going to always be. Clean these parts. और यहाँ पर भी इसको F enter, R enter, 0 enter. Right? So with this you complete the DLD for Airside. Alright, यहाँ पर नीचे if you want you can mention the text, how you are going to take it as double line drawing done by HDE 94. Scale applied is maybe 1:25 depending upon the paper size. Rightly done, right? इतना आपके पास काम होता है उसको अप्लाई करने के लिए, for you to do it and finish it and make it properly in place. I'm going to save this file again with a new name. I'm going to call that DLD Airside. Save it. So let us begin today with the chill water pipe SLD drafting. And until now that we had seen related to the water side, now we are going to start doing the drafting skills for chill water piping water side along with the help of chillers. So until yesterday what we were dealing with was DX system, that is direct expansion. Today what we are going to do is with chill water pipe system. So what is the basic difference between the two? We know that one. DS system is not involving any particular external source for cooling measurement. Whereas the chill water piping is having the normal refrigeration compression along with the external chill water piping. With the means of water it is cooling more. Alright. So the chill water piping is also going to be totally centralized. And as we know, International Airport has many terminals. So this is a part of first terminal, terminal 1. Alright, so that way we're going to see the chill water pipe designing for this one. Today we're going to deal with SLD, but before we even do the SLD, what we actually have to deal with is key. We have to understand key what way is the conversion between the TR and GPM and etc. Okay, so that way what we're going to understand very easily is I first need to ask you how much is 1 TR related to in terms of GPM. 2.4 GPM exactly. All right, so we know that the chill water pipe that we are going to consider is having connections going to deal with into which application. If the chill water pipe is going to be connected to which product or which element? AHU, right? It is going to be connected to the AHU. Alright, so today what I'm going to explain before you is we're going to deal with some examples, and that way and after that we are going to understand how the chill water pipe is going to be connected inside the AHU, how the water is going to be supplied and how it is going to be returned back. Okay, so very quickly I'm going to deal with the main designing standard, that is the conversion, that is 2.4 GPM. And if you are going to open your notes, and inside the notes we have a table that you have to follow at the time of suggesting the pipe size. Until yesterday we were dealing with 800 by 300 for the duct size. Now we have to take that in terms of a diameter. all right, in terms of mm or in terms of inches. So open the page number, I think inside your notes. Yes, page number 30. And you can see it is a closed piping system and the complete all will on page number 30, so that it will become very easy for you to do the designing. Okay, so keeping this in mind, we know where it's located on page number 30. So you can keep this open and we can understand directly from the screen how it is going to continue. So before you, I'm going to create one AHU. I'm going to call that a 5TR. How much is 5TR in terms of GPM? How much would that be? Quick calculations, Kelsey is outside, and because we are going to do that very, very quickly. 5 into 2.4 in terms of GPM. Everything we're going to deal here in GPM. What is GPM? Gallons per minute. How much it is? 12 gallons per minute. So in this one, I'm going to create one green entry and one red entry, which is going to be the supply and return into the AHU. Down below is I'm going to deal with creating my chiller. I'll take water cooled chiller, and that is going to be 600 TR. Very quickly, how much in terms of GPM? Yes, 1440 GPM. And from here as well, we are going to have a connection green and a connection red. I think we already know why I'm taking green and red. Return and supply. So what happens is when you're going to make a connection, let me take a pathway. The water that is generated inside the chiller as per the drafting standard, it is going to be supplied to the supply of the AHU. And how is that same water coming back inside the chiller? By return from the AHU into the chiller. So let me draw one schematic diagram so that you can understand how the pipes are going to be linked. And this is another one. This is the flow inside, and how much flow will go inside the AHU? Only 12 GPM. From how much? 1440. So now minus from 1440, 12. How much will be remaining inside the chiller? 1428, right? 1428 GPM will be remaining inside the chiller once the supply is left for going to one AHU. Now you might be having not just one AHU. In between there can be another AHU connected like this. AHU, and I'm going to call that with 7.5 TR. How much in terms of GPM? Calculate 7.5 into 2.4. 18. So 18 plus 12 becomes 30 GPM. So at a time 18 GPM is going to be dropped here, and from 1440 the rest remaining will be moving forward and the 12 will be dropped there. So at the end of all the supply to the AHUs, chiller is still having some amount in bulk, right? And that is why you can see the content. This is 600 TR chiller and this is nearly single digit AHUs. They can be as per the example. This is only example. You can have maximum of 10 TR, maybe 12 TR, 15 TR AHUs, depends. Depending upon the application where you're working, airport or hospital or hotel, etc. What you need to understand is the moment 18 GPM is moved into this, 18 GPM will be accessed, and the rest, how much ever water was required for the cooling segment, that will be done inside the AHUs related to your evaporating coils and etc. And after that, directly 18 GPM will be left back again in through the return pipe, and that will be moving back to the chiller. Directly the same situation is with this AHU. Maybe I'll call this AHU1, this AHU2. From both the AHUs, 30 GPM, 12 plus 18 is going to go back to the chiller. And if this return is not going to go back to the chiller, chiller will be left with how much? 1440 minus 30, 1410. 1410 means convert that into TR, divide by 2.4. 587.5 TR is remaining inside your chiller. All right. So why are we actually taking care of these calculations so deeply? Is because when your supply from the chiller is going to move, maybe your plan is going to have 10 AHUs at one instance. So now dependent upon the GPM level, okay, the GPM level is what you're going to decide the pipe size. Now we know that what is the main riser of a chiller? What is the main riser? Which pipe is called the main riser? From where the water is actually supplying. The main opening of the supply connection. So that can be, I can call that this is a riser, right? This is the main connection here, that the pipe is actually, the water is moving inside the pipe. All right. So from here, this is going to be your head, and this is going to be the individual supply into the AHU. Now, if I am going to mark the fittings, here is I'm going to get one elbow. I'm going to get one elbow here at the turning. This is another elbow, and this is another elbow. Nearly 4 to 5 fittings are applied. Clear? And in between, if I'm having an AHU, so this is going to be one different connection. This is going to be another fitting. We're going to talk about that a little later. Fine. So there has to be taking a turn. This has to go, and then it has to follow. Now from the table on page number 30, what you have to tell me is look for the table and search for 1440 GPM range and tell me what should be the riser pipe size. I'm going to open that again. Look for 1440 GPM range and tell me what should be the pipe size in terms of mm, not inches. 200 mm. That is the main riser size coming from the chiller. Now look forward for 7.5 TR, that is 18 GPM, and look for 12 GPM also. 12 mm. 12 GPM. So 32 mm, right? Yes. So if I'm going to come back to my, this is going to consider these 40 mm pipes are this one, the ones through which the water is moving into the edge. Now what will happen if I'm going to keep 200 mm of pipe here also same as the riser? Can I only get 18 GPM? No, there is chances of more water flowing. Why? Because the orifice of the pipe is much more larger. All right. So I cannot do that one. The pipe size totally depends upon your GPM. That is why so much of calculation is required. Is it clear? And now in the table that you can see, not one particular standard reading of the GPM is given. There is given flow range. All right. Why? Because after we subtract, in this situation it becomes 587.4. It is 1410. Now 1410 is also going to range between 800 and 1700 on serial number 12, where we have suggested 200 mm. All right. If I'm going to calculate that for every GPM, the table would become very, very long. Is it clear? Now you calculation here. Now this much of connection is understood from the chiller, how the water is moving into individual HUs and all. Now I'm going to rub the whole thing, and I'm going to draw that again. I'll draw one AHU. Now we are going to understand the levels. Considering the same example, 5 TR, 12 GPM, green, red, CH, 600 TR, 1440 GPM. One elbow, second elbow, third, fourth. Yes. Now what we are going to understand is, after we understand that the supply of chiller is connected to supply of AHU, return of AHU is connected to return of chiller. Now how does the propagation of water flow depending upon your levels? In the chill water piping, level understanding is very, very important. If you don't understand the levels, you're not understood anything with chill water piping. You will be left empty with the knowledge, right? So when I'm going to talk about levels, in the complete setup where the water is supplied and it is returned, listen very carefully and observe the drawing. The water that is moving inside the riser of the pipe of the chiller, the water that is moving inside the riser of the pipe in the chiller is called level 1. That is the main main level through which the water is generating to flow. Clear? Now until the water is moving above, until this level it is level 1. From here what is having, the pipe size is changing? It is changing, right? Because it has to supply only 12 GPM. So this was, how much we considered that one? No, it was how much size for 1440? It was 200 mm. Yes, 200 mm, and here what we are going to consider is only 32 mm. I think so. 32 mm, right? 32 mm. So from 200 mm it is reducing to 32 mm. So this becomes your next level, level 2. That is supply level. All the supply levels from the chiller to the HV is called level 2. And now what is the only parameter remaining? Return. Return becomes level 3. So what you have to understand is every supply is from level 1 to level 2. Is it correct? From level 1, water is moving to level 2. Every return is from level 3 to level 1. Is this correct? Water is moving from level 3, moving back into the same pipe which is of level 1, and it is moving down here. Now you can see that I have drawn the pink color, magenta colored line over the gray colored line. This is to make you understand that if you are going to look at this complete setup from the top view, now since my level 3 is above level 2, and if I'm going to look at the pipe connection from above, can I see the gray color pipe which is below? No, I won't be able to see. Now suppose this is the level 2 pipe and I'm going to look from above. I can only see level 3, which is a red colored pipe, but there is actually a level 2 pipe beneath that, but you won't be able to see. Why? Because we're looking from the top view. Is it clear? So always whenever you're going to see any particular drawing of related to chill water piping in the HVAC segment, you have to understand that when you're looking for the drawing from the top, you will be looking only considering the return pipe. That means only level 3 to level 1 flow you can see. But you also have to design level 1 to level 2, that is supply. So designing is going to look like this different. This is like a section drawing that I'm drawing before you. Agar yahi same cheese if I'm going to show in the top view or the this one total top view, you cannot see the gray colored lining at all. Is it clear? So inside the drafting parameter, we have to give from level 1 to level 2 and also from level 3 to level 1. Now depending upon the levels is what is your fittings going to work. Alright, because the water that is the riser here, it is going to take a turn and it is going to be in the same level. So if the pipe is going to be in the same level, just taking a turn, I can use 90-degree elbow. If it is going above and then it has to move above, means water was flowing until like this. This was level 1. It is taking a turn above and then moving into level 2. So there is an upliftment here, right? So there is a height increased for level 2. So this particular segment here is not going to use my same 90-degree elbow. It is going to use a dropper, downward dropper. All these I'm going to show you. All right, all the fittings I'll be showing you. You're only understanding now. Then after this particular thing, what you have next is if you're returning. So when you're returning, you see it is from level 3 dropping directly to level 1. From level 3 to level 1. So there is a throw of water. So here also there will be a different fitting, same like this. And then it is coming down. It will be in the water has to again from 3 it is now flowing into level 1. So it will not be taking the 90-degree elbow. Same kind of an elbow will be applied here. And then the water will be flowing inside the chiller. Aai baat samajh mein? So if you don't understand levels, you won't understand fittings. These are only some nominal fittings that I have told you. You will be getting a T section, a dropper T section inside your plan. Okay. Now, for example, I'm going to give a small test. That is to understand if you have understood the complete setup. What I'm going to do is I have created one complete riser this way connected to the chiller. Try to consider this as 500 TR. You're going to calculate that in terms of GPM. And I'm going to connect first, second, third, fourth. 1 HU, 2, 3, 4. This is the chiller. We already know that. And I'm not taking any supply and return. That is understood now, the connections. I'm only naming AHU1. This is AHU1 6.5 TR. Every calculation is supposed to be done. AHU2 is 7 TR. AHU3 10 TR. AHU4 8.4 TR. Now I want the GPM reading for individual, starting with the chiller. 500 TR, how much? 1200 GPM. For AHU1, 6.5 TR. 15.6 GPM. Yeah, Mr. Sriram, you can do this one. What do you say? Recheck. Yeah, let Asad do the calculation. You recheck if it is coming correct. Yes, 70R. 16.8 GPM. Okay. 10. It will be 240. 24. Okay, 24. Last. 8.4. 20.16. Now individually tell from the table the pipe sizes for individual AHUs. That is this connection. This is, I'm just shown one connection, but it is indirectly two connections. Otherwise I'll draw the two connections for you. Supply and return both. Yes. For 15.6 GPM size. 32 mm. Okay, next 16.8. 32 mm. Next 24. 40 mm. 20.16. 40 mm. Shriram, it is rechecked properly. All correct. And for this one, 1200 GPM for the chiller riser pipe size. That is going to be 200 mm. Right. Now you see, I'm going to minus each and everything from 12,000 GPM. Keep your calculators ready. Minus 15.6 GPM first. Then you have 16.8 to minus 24 minus 20.1. Tell me the last remaining amount inside the chiller. How much gallons is present? Mr. Sriram, please check. 1100. अच्छा वैसा है. Please do the calculations once again. Reconfirm. Correct? 1123.44. Now check for 1123.44 what is the pipe size? Same 200 mm? Right. So what you actually now have to do is, I'll just increase this in size to delete very quickly. So that was 1123.4 and 1200 GPM. Size for both is coming 200 mm. Right? So now with 4 different connections inside the AHU, the main riser size is going to remain the same, 200 mm, because water is reducing inside the content of the chiller, but the size will depend if the JPM is totally going to be down. So now the question rises, if it is going to happen like this, what size should we actually keep for the riser? The one that is after supplying to different AHUs or from the starting? What would you do? We will consider the pipe size depending upon the capacity of the chiller first. Later on, depending upon the segment where the chillers are only, where the AHUs are only available. If you have the capacity to reduce the pipe size to depended upon the 4 calculated AHUs. Now after doing the subtraction, next task is to add all the 4 AHUs and tell me the final GPM. I'm going to write here the sublimation of that one. 15.6 plus 16.8 plus 24 plus 20.14. Very, very quick. 75.54. Confirm. That is the total GPM. 75.54. Chalo, 5654, same. Now check the pipe size for this one. 75.54 or 56. It comes to 65 mm. Now the same situation what you have to consider is, because suppose this is going to be the last portion where the chiller is supplying to the 4 HUs. Uske baad there are no HUs, there is no supply, there is no return. That is the last segment. So in that situation, what you should do is you should not keep your riser dependent on 200 mm of pipe size of the chiller. Okay, you can make that as a riser from here to here. That is for showing that the water is entering. But the other header, what it is getting connected to the chiller AHUs individually, that can be confirmed depending upon the last capacity or maximum capacity of GPM flowing inside individual AHUs. Now for 75.54 GPM, capacity of the pipe should be 65 mm. So if I'm going to keep the header 65 mm, it is better, or if I'm going to keep the header also 200 mm, that is better. 65 mm is better. Why? Because we are saving the cost on the material of the pipe. Is it clear? We have to check the initial as well as the running cost. And in chiller, we know that the machine is having the least or most less maintenance cost. Why? Because initially everything is going to be set up in the design. It is not like the DX system or the other central AC ductable package systems. Fine. So that way you have to keep and remember so many calculations. Now see, chill water piping is having more things to remember rather than the ducting and the SLD and DLD of the ducting. Is it clear? Now when you know about all these things, any confusion in this one? Is it totally clear how to make the calculations? Each and every calculation will be coming at individual timing. Okay, how to do that one. Now the next thing that you have to understand from the notes, page number is 26. Open page number 26, chill water pipe drafting. In that one, you have to highlight and understand that the chill water pipe drafting is going to be totally similar for air-cooled chiller and water-cooled chiller. Now, before we proceed with the actual single line diagram inside the connections, what I'm going to understand or make you feel is the precautions that you have to do while doing the SLD drawing. That is, you cannot run the pipes anywhere as you like. There are some precautionary measurements. First point is the chill water pipe should not run or go through the structural parts like beams and columns, etc. You cannot disturb the structural conductivity of the building for running your pipes. Fine. So they cannot run like from beams and columns, etc. But they can go through walls, but not in a continuous manner. How is that? The chill water pipe should not go through the wall continuously. You can just break the wall, make a hole, and then you can proceed. But breaking the wall that way and then totally coming, dragging the complete, disturbing the complete elementary situation or the elementary function of the wall is not purpose. All right, because you're totally breaking the bricks. How are you going to actually understand where the pipe has to end? The wall will become very weak. Clear? So you have the diagram here. You can see you can create a hole and continue, but not disturb the construction. See, this way you have taken the pipe. In the first diagram, you have taken the pipe and you are moving totally laterally in the direction breaking the bricks, which is incorrect. But the correct procedure is you can make your pipe flow through one end from the other end. Making it left and right connection is not possible. Okay, you have to keep these things in mind. Last point, the distance between CHWS and CHWR, that is chill water supply, chill water return, after installation should not be less than 50 mm. The total distance between the pipe after installation should be not less than 50 mm. Matlab minimum should be 50. You can keep above that. Though I'm going to consider 1 feet, 300 mm. I can use that, but I cannot make it 25 mm. Both the pipes will be stuck together. There will be no place for thermal efficiency to lead. There will be no place for your energies to confront. There will be no space for changing the material of the insulation at the time of maintenance. Correct? So should not be less than 50. It can be more than 50 after insulation. Please highlight, very important point. Lastly, we can get the riser stack from the civil duct after the opening of the building. You'll have to contact your civil contractor for letting you know where is the opening of the building so that you can place the chiller, and then from there you can take the pipe through the OTS. All right. So these were all the important points that you have to remember. Now we are going to actually do the piping inside the plan. So for that, what we are going to do is we are considering the drawing, and you can see there are some cars available. There is a symmetricity of the drawing. The right hand side portion looks similar to the left hand side, right hand side, both look similar. This looks the entrance, this having the stairs and etc. And we are considering this is going to be the civil shaft. So we have placed our chiller there, and inside the chiller from the top you can see where the connection, supply and return is available. Correct? So the green color thing is the supply, red color thing is my return. You see the return is outside, supply is inside. That means if you're going to look from the outside region, if I'm standing at this position of my chiller in this location and trying to look at the project, which is the first pipe I'll try to see? Red color one, right? Because I'm standing at this particular location. Suppose I'm going to draw a line. I'm standing here. And if I'm going to stand and look at the pipe connections, the first thing is the red pipe. Even though the green pipe is there behind, the only red pipe will be visible to my vision, right? So this is my particular chiller where it is placed. I'm going to zoom out and you can see all the blue colored things are my AHUs. They are possibly available in different locations. That is as per the design consideration that is provided to you. All right. Here what I'm going to do is try to remove these pipe connections, because we are going to do that again. That is the lastly submitted project by the last batch. These AHUs are having the content, means what capacity they are. 3.3, 5 TR, 4 TR and 3 TR. Fine. So you can see these are left empty. So this much position or this much space is for assignment. You give your own quantity for the AHU, decide your own pipe size and let me know how you have done the connections. Is it clear? So for that particular thing, I have left these 4 AHUs in 4 different places unentered. Next, what we're going to understand is we have a catalog table here which is going to give us all the fitting details. And the drop down elbow that I was telling you is this particular thing. It is going to connect with the pipe from this end. It is going to move above and then flow down. If I'm going to tilt this and put the other way, it will take from above, pull it down. If it is in this position, it will take from below, put it in the side. That's why 90 degree downward. The other one is 45 degree downward. It's dependent upon the angle. After that one, what you have is 45 degree normal elbow and 90 degree normal elbow. The one that takes a turn for equal levels and similar levels. This is your riser stack or the opening of the pipe, how it is going to look like. Fine. From the interior. After the hatching, it looks like this. You have different amount of reducers. You can see each and everything is mentioned with a size. Now for the diffusers, this is 80 by 64, so 65. So which is 80, which is 65? The other end, that is the mouth, is 80 and the other end is 65. That looks smaller. This is 100 by 65, 100 here, 65 here. Similarly, that way we have something for a T-joint. So the T's are going to be connected in those positions where all the 3 pipes are running in the same level. Suppose my main level 1 pipe is running from this side and also the water has to move the other side, and in between, in 3 different directions, water is running in the same level. Remember when I say about levels, if it is level 1, you can apply that. Level 2 alone, you can apply that. If level 1 and level 2 are in connection, you cannot apply this. Lastly, you have the dropper T that we are going to use, which is going to give you not in the equal levels, but in different levels. You can see something is lifted up here. So a pipe of level 3 will come, drop into this, and it can supply in the below level. that can be supplied, that can be returned, depending upon the situation. All right. So this is all about different categories of the catalog pieces that you have, and this will be generated and created only and only on scale of 100. It will be provided to you by the manufacturer whose manufacturing fittings you are going to use. You should never try to move any of these catalog pieces. You cannot use the enter command and move them for using inside your drawing. You should only copy them, because you will have to totally change the scaling depending upon your design and your pipe size. Now I'm telling you that it is totally made on 100 mm. My pipe size is only as per 12 GPM only 32 mm. How can I make a fitting of 100 mm on 32 mm? Possible? It is not possible. So you'll have to scale that particular thing to make it to 2 mm and then connect inside your pipe. Fine. So there is a lot of work that you have to actually do. Inside this particular fitting here, what we are going to do, if you're going to zoom in at the chiller and start to do the chill water supply and return, before that, once you start the project, try to click on the layers and check how many different layers are applicable inside your drawing. You can see there are so many different layers available to you, and because of that is what the drawing looks this way. Now you cannot actually ask a question that said, how did you draw the car? We are not having to do anything with the car. That's in the parking area or in the placement. All right. So what we are actually having to do is only with the chillers, the chill supply. So we are considering inside this complete project to do the chill water piping in the left hand side of the building, which is a waiting launch area of Terminal 1. This whole thing is Terminal 1. Present day situation in Dubai airport, it is exactly the same way. And this is a still empty file. I will be showing you the completed HVAC drafting file of this project. And you can see how beautifully the ducts are connected, exhaust ducts are given the connection, everything. It is very, very good experience for you to sit and study that plan only. Minimum 2 hours you will require to understand the complete plan. Minimum 2 hours. 2 hours it will take for you to totally zoom and read how, from where the water is coming, where the air is supplied, to which zone, how much of CFM is going. Minimum 2 hours. It is only then that we can say that you are professionally, technically sound in the HVAC designing process. Okay, so you have to take a little bit of initiation and interest. Otherwise, nahi hoega. Fine. So from here, what I'm going to do is we are now letting us understand how to do the SLD creation. So for that, if I'm going to zoom in and click on my this connection, you see it says the layer created is CHWS, chill water supply. And this one is CH, not connected there, but you will be having a layer for that. Sometimes layers don't really work correctly. There is WCHR, that one. So this is my WCHR. This is WCHS. Yeah. So this is different and this is different totally. All right. And currently we are in using Legend as the current layer. So I'm not going to use that one. I'll try to use my layer as a current layer. Before you start doing the chill water pipe, you need to select it and delete. Otherwise also it will be deleted. You don't really need to do that. I can delete this one also. I only need the segments. It is not necessary that the return connection be below or the supply connection be above. They can be in the same level as well. Like this. Is it fine? Now if I'm going to check what is the distance between the center point to center point, you can see how much is the distance between them in x-axis. 300, nearly 300 mm of distance between the two pipes, between the two risers. That is how much feet? 1 feet. I'm keeping that for proper understanding so that you can actually understand how it is going to be. All right. So now what I'm going to do is I'm going to keep my ortho turned on, keep my layer active. Here the layers are going to be very, very important. And you see inside the complete plan, these kind of symbols are your structural elements. This is going to be the column. This is going to be the column. This is going to be the beam. I cannot actually move the pipe from these ends. I can try to drag that between the walls. Now what I want to do is I'll start the pipe from here and until I reach the last AHU. Till here I want to make the piping very proper, very simple, very crisp. So what we're going to do is we can come out with different methods of giving the piping, same like how we have done the low terminal design ducting. The best possible is to keep it the most simplest. Let me use PL enter, polyline, start from this end, and I'm going to drag it a little bit until this position here so that I can break through the walls in the side. I'm going to click there and you can see this is the first wall that I'm breaking. Okay, I'm not moving continuous on the other end or this end. I'm just making a hole and moving forward. Now I can have multiple walls ahead and I can keep going through that this way. I cannot stop here and try to take on the straight line. Why? Because what I have there? The door. See the structural element. If I'm going to suppose click until this position and can I move till here? I have a column there. So what I need to do, I need to drag the line more further, right? So what I'm going to do is I'll click this up, extend this until this segment because I need to get into the wall because I have to take a space from the wall, right? So from there, use polyline again. And then you can do that one. You are breaking through the wall. That's possible. How many walls? 1, 2, 3, 4, 5. And from here until where do you have to stop? Can you go there and then take the turn? It's not necessary to take the pipe of so much of length because you're wasting the material. This is the HU. Just above or very close to the HU is what you can click once. And then you can go this way because you're going to break through the next wall. And don't really feel that you're breaking the door again. The door is only a symbol which will be closed and door is below the false ceiling. This is all that is happening above the false ceiling. All right. So the wall is going to break. This one connection will be getting to this HU. I need to take care of this HU also. From here is where I need to take a turn. Now if I take a turn, see below that will I be reaching the last AHU if I take a turn from here itself? The pipe will be very close to the last AHU and we cannot change the position of the AHUs. That is given by the mechanical engineer. What I can do is I cannot move this way and again I can move down. In between I'm getting a column. Not possible again. So I need to drag it outside. Click there. Come here. Now this particular section of the drawing is applicable for this AHU, this pipe. I can give the connection. Now if I'm going to move little more below the pipe that I'm keeping the riser pipe, this is also AHU is covered in this one. I can give the individual connections there. And lastly, I'm having the last position and the final AHU connection. So I can drag until this position or this position to keep it for letting the water totally drop with force downwards. Or I can try to manage with the end of the AHU. I'm going to not waste the too much material. Click here, move this way, and I'm going to leave that until this position, like this. So this is the complete. Now who can tell me which level pipe? 1, 2, or 3? This is total level 1 pipe. It is starting from the chiller. Not even one AHU is connected. The moment we are connecting AHUs, which level that will turn? 2. The moment I'm connecting the return, it will become level 3. All right. So from here you can see if I'm going to select this, it is a total polyline that is from there, and because we had to break that here, what I'll do is I'll try to join those. And the whole thing is selected at once so that it will become easy for me to take the offset. Why am I going to take the offset? For the return. I don't want to keep tracing the return again of the same level, and maybe I will not get exactly 300 mm. Right? If there are considerations like this coming in between, now see exactly at 300 mm, maybe this is a joint where it is going to fall. So I cannot go there, and because of that return pipe, I'll have to change my supply pipe. So I cannot do the tracing for the return. Instead, what I can do is offset for 300 mm. How did I come to know about 300 mm? Between the center points of your risers, you first have to check that before giving the offset. Otherwise, you will not know what the offset you have to take is. Is it fine? So that way you have to do the designing very keenly. Now what you can do is match this with the next layer. This way. And it will be, your return is also done. Now you have to check for the return pipe if it is breaking any of the structural element. If it is doing so, you'll have to change. See here, not breaking. Here also not breaking. It is taking exactly like the wall. Here also very clean. Here also clean, and here also done. Level 1 is completed for supply and return. Now I'm going to level 2 first rather than directly jumping to level 3. In level 2, considering this particular HU, suppose I'm going to call this as 1, 2, 3, 4. This is the last HU, number 4. 1, 2, 3, 4. I'm going to start with number 4. So it will be, I'm going backward, 4, 3, 2, 1. Fine. So here inside the HU, which is named as 3TR, look at the HU and tell me which is going to be the supply, which is going to be the return. The two connections that is given here. Observe very carefully, because if this stage also you're not able to understand the drawing of an HU, is very difficult for you to then move forward. I want to understand which is my supply connection, which is return connection. Left one is a supply, right one will be return. Can you please give me some explanation why? And how did you understand that? This can also, for making you understand that, I'll have to actually give you the schematic diagram of the HU again. This is HU in a section view. I'll take the green color. I told the supply is below. The return is little above, as per the design set by the HU, by the manufacturer. In between you have one more thing. Which pipe is this? It's all related to pipes. There is no ducts now. This is supply. This is return. What is this in between? You have all... No? Yes, it's called the drain cock. If any excess water condensed or available at the corners or surfaces of the HU or any other component of the HU is going to fall from the drain cock. Fine. So this is going to be your drain pipe. And because this is a return, the return is always behind or the close to the filter of your HU. Why it is going to be like that? Because the return is first going to come from here, get sucked, and then it is going to be absorbed and then compressed, right? So anything that is close to the filter is going to be your return pipe connection. Now this is my filter. The closest to the filter is return, and this will be supply. All right. So always remember that way. It becomes very easy. The filter will be marked like this, which some kind of a hatching, because otherwise you won't be able to know where to apply the duct from. It can be duct will start from other side and this side. Total demonstration will go wrong. So the filter or the back portion of the HU will be given like this. Any connection that is close to the filter is going to be the return. Now if I'm going to select this and I'm going to mark that with a different color like red, I'm going to select this. I'm not changing the layer. I'm just changing the color, green. Very comfortable to understand. Green marks the supply, red marks the return. Now coming to this HU, it is a little different. Tell me the return and supply. Left is the return, right is the supply. Understood? This here, this is return. Supply. Close to the filter is always the return. Lastly, this side. Done. Fine. So now depending upon the coloration and the indication of supply and return is where you have to join the lines. Coming back to the same poly line, from the center point you have to go till the green pipe or the red pipe? Only till the green pipe, because till there is only the supply limited to you. It did not come straight. Ortho is turned on. PL enter. Maybe I'll try to demonstrate this with some amount of width. Level 2 pipe. I'll give 25, 25. Becomes a little thick. TR double enter. Trim this end, trim this end. Level 2 is connected to my level 1. So supply until this the riser, and here it is supplying into the HU. This becomes level 2. Now what about the red one? PL enter, keeping ortho on from the midpoint. Green pipe or red pipe? Red pipe. We did not turn the layers off. This is which level? Third level, where is the return? From which machine the return is coming and going to where? From the AHU, it is going back to the chiller. Alright, so in supply, the water is falling. In return, the water is moving above against gravity. And this is towards gravity. Remember that. These are the scientific terms that you need to understand. Alright, so every turning here requires the fittings, elbows, and etc. Here also, here also, here also. Fine. Coming back to this position here, I have a supply and I have a return to be connected. First, I'm going to connect the return. Maybe till this end. The return, so it has to go till this side. Select and match with my layer. Can I do offset of directly 300? But do we know that if this is a distance 300 or not? I need to first check that one. DI enter this end to this end. How much it is? 300 exact. So I can take an offset. Offset for 300 mm. Connected. You see it connects normally and automatically to the same generation because of leaving the gap here. Alright. So you can try to modify that if you are going to make the connection to the supply. Drag that one till this end. Match with the layer. And you can increase that in height. Until you get a straight. Also done. Here there is direct connection. So we'll take PL enter first. Select the midpoint. Come till here. Drag it outside. That is connected. Change the layer. Come here. PL enter. Center point. Keep ortho turned on. Red to red. That is done. TR double enter. Trim the extra lines. And once again, PL enter. We are into the red layer, so I'll first match with the red. Change my layer. Center point. Zoom out until this end. Done. TR double enter. This is trimmed. This is trimmed. So all the HUs are now connected properly with levels and everything. Here also you can see, if you are zooming out, you can see how neatly is my pipe gone and connected. Is it correct? Now what we have to do is we have to do the inside homeworks. That is nothing but for each and every HU we have to provide how much is the GPM. Depending upon the GPM, how much will be the pipe size. Clear? So very quickly I'm going to start that from the chiller. I'm going to consider a chiller of text 850 TR. How much is that GPM? 850 TR, 2.5 into 2.4. How much? Please tell me. 2000? 2040 GPM. That is completed. Now coming to individual HUs here, it says this is 3 TR. How much would be the next 3 TR GPM? 7.2 GPM. And how much is that pipe size going to be? 1 minute. Okay, we'll first mark all the HUs with the chill water pipes. I actually also need to mention the CFM. So tell me how much is the CFM for 3TR? $1,200 CFM. Confirmed? All right. Copy that. Next is 4TR. 9.6 GPM, right? 9.6. Mr. Mario, are you following? 1600 GPM. Save. Next. 5TR. 12 GPM and 2000 CFM. .3 TR. 7.9 GPM. This one. CFM. 1320. You can make the calculations for all those ones. Now coming back here, back to 3 TR, that is AHU4. 7.2 GPM. Tell me the pipe size. How much? 25 mm, right? That is 7.2. So what we're going to do is we're going to mark that but with the diameter symbol for the two pipes. How we're going to do that means I'm going to change the layer. I can take any text layer available with me. T for text. I have text that is in green. I'll take text duct. We are going to first draw a ellipse. Circling the two like a rubber band. Okay. Using my LE enter, that is a leader line. Indicating the marking what is the actual size. I'm going to copy the text once again. Place it here. Yes. So for 7.2 GPM, that is having the diameter of 25 mm. So the diameter symbol, how you need to apply is shift plus 5 number and the alphabet C. And you will get the phi symbol. Yeah, 5C, shift plus phi. That is phi is percentage. So shift plus percentage, and no shift and C, directly C. You'll get the phi symbol. That's a shortcut. You can note it down. That is 25 mm is the pipe size. I'm going to close that with a different coloration. I'm going to make it with magenta. Okay. Next, 4TR 9.6 GPM pipe size. 32 mm. So EL enter. LE enter for the leader line. CO enter to copy the text. Place it here. Yes, how much is that? 32 mm. That's the diameter symbol. Once again, EL enter. The two different levels. LE enter. Copy the text. That is for 12 GPM. 32 mm. Same, right? This side 3.3 TR. LE enter. CO enter for copying the text. How much? This is 7.9 GPM. 32 mm, right? Okay, so we have three different or three similar pipe sizes. Only the last one is 25 mm. Clear? Now what would be the actual size of my rise as per 2040 GPM? Find from the table. How much? 250. Pipe sizes 250 mm. Is it clear? Each and every one, each and everything. This way you have to present the SLD drawing which the engineer has to do, which you have to do. It is your responsibility. How to update that with the fittings, with the annotations, with the next connections is totally going to come inside your double line drawing. And this is all about doing the single line drawing. All right. So is it clear? So this way I'm going to now save this particular file with the on desktop. This is chill water piping HDE 92 SLD. That is saved totally. The concept is clear to everyone. The level understanding is clear. The calculation is, so you have to keep keen interest and you have to do that very well. I'll be sending you this file. What you need to do is first turn all the layers off where you have done the chill water piping. The green, the blue, the red, the pink and everything. Keep selecting, just turn off them. You know how to off the layers, I believe, layer on and off. Make a copy of this only as XREF so that you can use multiple times for practice. All right. Turn off all the layers, save that with a different name in a new drawing, export that as XREF and then do your drawing. Is it clear? That is the purpose of not giving you the XREF, for you to understand how to create XREF. All right, because everything if I'm going to give ready-made, it will become a habit for you. I want you to keep working out for it. You should generate the ideas. Fine. So now this Yes, so today what we're going to look forward is to do the double line drawing for the last entered project inside the chill water piping, and we are going to begin from understanding the different levels we have already seen yesterday, and what we need to do today is convert the whole thing to a double line drawing. All right, so for doing that, so we are going to consider first with the 3TR, that is a fourth AHU that we are going to apply from here. So what we actually have to notice is we need 25 mm of total this last length, that is the to level 2, right? And what we have to understand is the riser, the chill water pipe riser that we have until here is going to be till the last segment. So what we are going to do is, as we can select the green pipe, you can see it is totally into a polyline. It is joint venture. So if I have to take individual offset, it will be regarded over all the sides, but all the pipe sizes are going to be different. So what we are going to do is we are going to explode the green end and we are going to explode the red one. So all of them have to be individually exploded so that we can take individual offset of different shapes. Now even these pipes that are of 25 mm, this one and this one, both of them have to be exploded. Why? Because we cannot explode over having a polyline with a width. So the moment I explode, it will become individual polylines. Now what I want to make you understand is I'm going to consider keeping, since this is a last AHU, or in situations when you're going to connect the last AHU, the last connection, that is the level 2 connection, since we have yesterday talked about that this is the last one, what I'm going to do is I'm going to leave my risers until this end. Means I'm not going to connect them from this side. There are two reasons for that. One is, if possible, by tomorrow, as per the design, one more AHU is going to come below. So we should not be in a situation that the riser has already taken a turn. The main pipe should always be straight. It should not leverage, or it should not move into any other direction rather than straight direction, so horizontal and vertical ways. Most probably it has to be in the vertical form, all right, depending upon the shape. So if by maintenance direction or by maintenance engineer there is another AHU that is going to be below this one, we have to move the risers. So if addition you're going to create the risers of 200 mm at this side and 25 mm, it's going to be too much of difference, right? So what we are going to do, every time when there is a last AHU, the last connection has to be totally as per the pipe of my AHU, that is 25 mm, and we are going to maintain the risers until this side. Clear? So what I need to do is very quickly from this first AHU, I'm going to demonstrate very quickly. 25 mm is the required pipe size. So this side and this side, both we are going to offset as per 25 mm. How much is half of 25? 12.5. So offset for 12.5. This side, this side, this side. Here go same with the return, because both of them have to be of the same size, like this initially. Now because this is going to be in the same level, right, this is level 2, the whole thing, this L shape is level 2 for the supply and the return. So here the connection would be of the normal 90-degree elbow, because the pipe is taking a turn, it is not moving down or it's not moving above, it's in the same plane. So we have to use 90-degree elbow. Now, way to get the elbow from, as I told you yesterday, we have a catalog. So we have to select from the catalog. Now my 90-degree elbow is this piece, right? Now this 90-degree elbow, what I'm going to do is I'm going to select this one. I'm not going to move, but just copy, because I cannot move, it is the original piece. So I have to select a point and try to copy and place it where it is required. Suppose in these two positions, I'm just going to place one of them. Now, keeping your ortho mode turned on, what you need to first do is understand the rotation on how to change the elbow. I'm going to do that. RO enter, select. Now maybe you have to tell me in which position to rotate, like this. No, like this. Yes, this is the correct position for it to apply between the two pipes. Right. Now we know that initially I have told that all kinds of the catalog pieces are created on 100 mm of scale. What is the requirement here? 25 mm. So we have to scale it from 100 to 25. So here 100 mm becomes your reference length and 25 mm becomes your new length or new diameter, you can say. So SC enter, select the object, press enter, select a base point for doing the scale command and use R for reference, enter, 100 as the reference length, new length that you require is 25. And you can see that the apparatus is less in size now. So I can now try to copy that again. Use this midpoint and try to place it where it is required by keeping the ortho turned off. Now the placement, how you need to do is you have to zoom in the maximum first for understanding the placement, because the more zoom out you do, you will not be able to understand now, because the pipe and the elbow both are small. So you have to zoom to the maximum eye level that you can see. Try placing it to the nearest, but you can see above or below, some or the other way it will not be placed correctly. Just place that at once. One there, and we have the other one here. So I'll show you how to correct that one. Just place it initially in that location. Come back here. Select it. Yeah, it has to snap in position, but what happens is these lines here are not having any other points other than the nearest points. Right, if they are going to have the midpoint, it will be snapping nicely on the midpoint, that is over here, but we want to do it in the end point. Right, so what happens is, what you need to do is, you have to select the elbow once again, zoom in, the same like what we did for the grills. Use M, enter, select this position, try to place it on this end, and you can see it is placed here properly and it is placed here very well. And lastly, what you need to do is trim what is not required inside and outside. This way. You can also trim the ones that is the pipe doesn't move inside the elbow, it is only till the outside. So you have to delete the inner lines as well. And lastly, you have to use MA enter for matching with the same layer. Very neatly done. Same is the situation this side. We have to zoom in, use M enter, select the whole elbow, select the snap and try to move this way. So it's going to snap properly either on both the sides. MA enter, match the whole thing, that is matched. TR double enter, trim what is not required. That is completed. Now what you also have to do is you have to make some things look like realistic. That is the flow of water, especially in the case of chill water pipes. So I'm going to select this pipe. I'm going to go to my layers and I'm going to search for a property called water, if I have that. I don't have anything called water. I don't have a layer called water. What I'm going to do is create a new layer, LA enter, name it as water, and water doesn't have to look in the blue color, it will be looking in the grayish color. Why? Because representation of blue over white will not be resembling very dark for you. So I'm selecting a gray color. Alright, that is a color, but that is not going to look of the same type. So I'm going to use dotted lines or hash lines, hidden lines. I'll try to take these hidden lines, try to click OK, and that is updated. I'm going to keep that as a current layer. Select this portion, this one and this one, try matching it with the same layer, new layer, water, and then you can see it shows you as if the droplets are flowing or the water is flowing inside the supply. Water will also be flowing inside the return, so I'm going to take that and match it with this, and it has accepted that way. Even I have to do the same on this side. Done. Now we all know that we have the red pipe moving over the green pipe. So if you're going to look it from the top, there has to be a cut section for the green showing that the red is moving above. It has to look like this. Okay, currently it is that the red is moving in between the green. We have to show it this way, that the red is above, green is below, like this. Right? I'm going to come back to that a little later because we also have to do the insulation for the pipes. Next, we are going to come across this side. But before we come to this side is what I want to discuss about this next AHU, because now you have to tell me which type of elbow fitting do we have to apply in both the situations. Firstly, I need to I need to explode both of these. This is done. And the next step I require here, the size is 32 mm. Alright, so for 32 mm, depending upon 9.6 GPM, is that tell me the level of understanding that which is level 3, which is level 1, which is level 1, which is level 2. Let us start with the supply. Yes, so if I'm going to consider the pipe that this is level 1, the main riser, there is a joint moving from the riser in the same level, so this is also in level 1. Here itself, where the water has to move inside my AHU, is where the level is changing. I can do another thing. I can try to lift my next supply level from here itself. Means let the riser connection be same. We are not going to change or apply the same riser pipe size in this level. What I'm going to do is, depending upon 32 mm, I can take total offset of this side and this side of making it 32 mm. right? But what will happen then, these two pipes will become in the same level, that is level 2, and this will be in level 1. So the water has to rise up into level 2 to move directly inside the HU, right? So I will be using, yes please, so I will be using a drop down T over here, and I will also be using a normal elbow this side. That is understood. In the supply region, what happens when you're going to return, because the return has to move from the HU. So water is moving, turning. See, when the water has to turn, there itself you have to remember about the facing, the levels and the flow of water. So if you're going to maintain, you want to drop the water exactly the moment it is coming outside the HU, is you can use the different kind of a elbow, not the 90-degree elbow, because it has to fall from 3 to 1. That happens when you're declaring that this pipe is totally level 1 pipe of the main riser, a part of the riser. If that is not the situation, you are declaring this is and this one, both of them are in the same level, level 3. Water is going and falling directly into the main riser at level 1. That is the best thing to do actually. Why? Because maintaining the fitting at one particular level is excellent as per the design. You bring the one in supply differently, that is okay, because supply has to enter the HU anyway. Return, when it is going to happen, it is going to flush and rush very, very fast back inside the return. That is a main riser of my chiller. So what we are going to do is I'm going to maintain these two at the same level, right? That is my return from the chiller. This is level 3, level 3. It is directly dropping into level 1 at this pipe. But for the supply, what I'm going to do, I want to maintain this as the main riser and this as the main riser. I'm not changing that. I am only going to change the fitting at this position. That is, until here it is level 1. From here the water is moving above and entering into level 2. In this situation, what happens? The water has to move above and then enter into the HU. So what can become wrong is there can be little pressure drop. For the water that is coming in a very, very high velocity, it is taking, lifting itself up and then trying to flow. Now you see that the pipe length here is too short. Is it clear? The moment water is turning above, it is going to flow. The moment it is trying to catch its velocity, it is not getting enough of space. How much ever velocity with what it is entering, it has to directly enter inside the HU. So for not letting that happen is what we have to maintain both the pipes in same level. Level 2, level 2. Let the pipe go and fall here. Means the water is moving, it is moving above in this position. So if the pressure is increasing at this position, till the pipe is reaching halfway through, it will try to balance the velocity. And because it is now into a same level that is entering inside the HU, it will turn and directly move back with the same pressure that with it is coming behind. Aai baat samajh mein? Right. So we are going to maintain this at the same level, this side and this side both. But the connections over here are going to be entirely different. I'm going to use my drop down T, that is dropper T, that is connected. This is a normal T. I can use a normal T also. There are different situations. As I told, in classroom you can have a different drafting design, you can have a different drafting design, but we have to go with the most standard and the most efficient one, where no pressure drop, good amount of velocity, everything is to be maintained. Because I have to show you the one that is best design. You have multiple options to do. You can try to do each and every one as per your concept, right? When you practice, you're free to do that. So what we're going to do is I'm going to select this one machine, this one type, take it back inside, and I'm just going to place it here because it is going to be a very, very good task for you to understand how to scale that, because there are two different portions. I'll try to place two of them, press escape, and I'm going to come back to my original elbow. Copy that, select, and now I require it to do it this position. If you're very intelligent enough and if you're a pro in using the AutoCAD, what you can also do is you can use the same last entered elbow, but this time while scaling, what becomes a reference length? 25. And what becomes a new length? 32, as per the requirement of these two pipes. If you're not very that much of that you can actually understand what the reference length and everything is initially, it is better not to do that. What you have scaled once, just leave it, because you are at the beginning stage. Try to take the one every time so that you will start with the reference length as 100 and you will know the difference what is the next new length that you're going to apply, so that it will become a practice for you. Once you are very well efficient with doing the drawing and the drafting in this one, then you can try to place one elbow Try to scale always the same one rather than copying every time from the catalog. Anyone is possible. So what I need to do now, I'm going to apply both these sides with the elbows, right? So I'm going to scale this to 32 mm. SC enter. But before that, what I need to do is take the offsets, right? So I'm going to take an offset for this one of, if it is 32, how much I should take? 16. Yes, so 16 from this end. That is fine. Right, so now we're going to do the scale. Select the object, press enter, take this as the base point, reference for 100, new length is 32, and enter. And now you can see it is reduced. Now what we're going to do is try to copy that. If you're trying to move it, it will be moved directly in one position, but you see you have to use that twice. So better try to copy, and we're going to place that in this position here, somewhere as I told earlier. Press escape, zoom in out here, either one side where it is not placed properly, enter, select the whole setting, try to snap it with the points, and it is going to fit on both the sides. Same thing to do here. That is done. Now TR, double enter, this side, and everything is done. Once again, I'm going to select this end, and I'm going to clean out everything what is there. Lastly, we have supposed to match with the corresponding layers, this one to this one, this one to this one, and we also have to match with the water layer. So MA, enter, select water, apply them in both the pipes in both these directions. And now what we're going to do is we're going to change the pipe size for this side. But before that, I think you did not notice what was the actual size of my fitting. It is 65 by 100. What is 65 and what is 100? The elbow fitting here, that is from above, is 65. The other side is 100. So now what I'm going to do, I'm going to do one technical mistake here. That is, I'm going to show you one how to do it correctly, and one I will show you how people usually do the mistake. That is why I have copied it twice. So I'm going to bring both of them in the same line. The mistake is what you have to avoid, and I'm going to rotate that, keeping ortho turned on this particular way. Same thing this side. Yeah. Now that you know it is 100 by 65. And what is my pipe size here? 32, right? Now tell me what is the half of 65? 32 and half, right? So exactly the 50% of this size is what it is going to match the nearest quantity to that particular pipe, right? The above side is going to be 100. So how much would be the 50% of 100? 50. Now that you are celebrating these quantities in 50 and 100 too differently, you're creating two different things. What you have to give me the exercise now is calculate the total GPM from 7.9, 12 GPM, 9.6 GPM, 7.2 GPM, and see how much dependent on the GPM is the corresponding pipe size from your page on page number 30. Calculate quickly. 7.2 plus 9.6 plus 12 plus 7.9. Yes, 7.2 plus 9.6 plus 12 plus 7.9. Nearly 36.7 GPM. Now check for 36.7 GPM what is the pipe size. 50 mm, right? All agree to that? Okay. So yesterday as I showed you the diagram, schematic diagram between the chiller and 4 different AHUs, that we can maintain the riser depending upon the last 4 AHUs only instead of capturing a 200 mm of pipe, I can take 65 mm of pipe depending upon the total values of the AHUs. Right now, the 4 AHU quantity analysis that I'm getting is 36.7 GPM, for which 50 mm of pipe is required. If 50 mm of riser pipe is there, is it correct if I say that all the AHUs will be working properly with equal amount of chill water available to them? If 4 AHUs are only available, if I'm changing the pipe size from 200 mm to 50 mm, and because of 50 mm, 36.7 is the quantity, total guaranteed quantities in 4 AHUs. Can I change the pipe size from 200 mm to 50 mm? Yes, we can change. Why? Because we are saving the water supply, we are saving the energy required, we are saving the material of the pipe. Main focus here has to be on the material of the pipe. Mild steel or black iron or carbon steel is not. What I'm now going to do is, from this portion, that is the end portion, starting from this side to this side, I am converting the riser size from 200 to 50. Clear? And this side is going to be maintained as how much is as per this one? As per the, it is 250 mm. So from 250 mm, we are converting the pipe size to 50 mm depending upon only and only last 4 HUs. So I can apply one reducer and change the size. Clear? Or directly from after the turn, I can change the size. No need to put an extra fitting like a reducer. Fine. So I'm going to use EL enter. Mark this as 250. It is already marked below, but I'm using it to mark again so that you don't get any confusion later on. CO enter. $250 mm. Done. So now that I'm changing this size, so I'm going to mark here as 50 mm. I'll change this text duct EL enter. LE enter for the leader line. .7 is the GPM that is flowing. It becomes 50 mm. Is it clear? So now we know what is the actual size that we need above. We need 50 mm on the above side. Why? Because that becomes a riser. This becomes 32. So first thing is how to do the mistake. And next thing is how to correct it. What usually happens is, what people try to do is, by seeing two different sizes, they first want to explode it. They first want to explode this. We have to explode that, but not necessarily we have to break the whole thing. Currently it is 100 by 65. I'm going to explode that. And now it is individual pieces. Now when you do this, it becomes very difficult for you to select the quantities for scaling. Now that this is 65 already, originally I have to make that to 32. Now you see I'm going to select the whole portion like this. I have to use the shift key and come back and select this one. It isn't getting selected. Now it gets selected, the whole thing at once. Nothing has to be missed from here. And I'm going to do SC enter for that. It says select the base point. This is the base point. Take reference. The original length was 65. Original length needed is 32. Now you see directly changes its sizes. Okay, chalo, this we have understood. It sets in the center. Now we are going to change from 100 to 50. I'm going to select that portion again. Complete setup. Scaling, taking this as the base point. For reference, totally it was 100, newly required is 50. Now you see, where does that go and fit? Correct. Now since you have exploded, You cannot move either this one or that one totally. It is one over the other. Becomes very, very difficult for you, right? So in this situation, suppose I'm going to move, I'm going to try to click at this side and I'm selecting individual pieces, trying to zoom and see how far can I go with my selection, and then I'm going to select from the center point and try to bring it or do it this way. You see there is still one line that is not moved up. So such things can happen for you to do. Actually, it can become mistakes. Now this line, keeping either the ortho on also, I don't really know, maybe this is the center position, I have done that one, but you see it is not aligned properly yet. Some lines from here, some lines are not meeting. It becomes too much hindrance for you to change the shaping. So this is totally wrong. You cannot get perfect figures. What you need to do is, keeping this 32 mm in mind, if you directly take the overall scaling of 50%, what all changes? Automatically 100 mm is changing to 50 mm and 65 is changing to 32.5. Is it clear? After you do the overall scale is what you should break. What you should do the explode. Only 0.5 mm I have to change then. Not a big issue for me. So the original way how to do it, first scale the whole thing. Do not explode it at the first position. Take a base point. I'm taking this as the base point. Reference length I'm giving of 100 and I'm going to change that to 50. Now you see when I'm going to move to mark this one, this side to this side, it becomes exactly 50. That is what I want for my riser. Now try to experiment that one, that is using the DI, that is inquiry command. This says in the Y direction it is 32.5. It is now that I can explode this X, enter, and it all breaks into pieces. It did not break. And now it becomes individual portion. Now what you need to do is select the maximum quantity, this whole thing, this side, and this side. Remember, when you're going to do the scale, the whole object has to be selected. Individual pieces, anything missed will not be scaled properly, right? So the whole thing is 32.5. I need to convert that to 32. So I'm going to do scale, select the base point. Best thing is to select the center point, take reference. Now what would be the reference length? 32.5. Remember that, don't make mistakes. And the new length is going to be 32 and enter. Is it fine? So now you can see where you have to make the changes is slightly, if you can zoom, is only this position where things have changed. Very easy for you to do that. Just drag and try to snap it with a point. It will join. Come back to this position, select it, join it. That is totally done. There is no difference. None of the apparatus are changing. Nothing is happening like this. All right. I'm going to select this and delete. Now what you need to do for this one is the sizes are changed. Now when I'm going to move, individual objects will be carried off. I have to convert that to block. This time you have to convert to the block with the new sizes that you have applied. That is 50 by 32. So B, enter, write T. That is my dropper T. So I can use DT, dropper T, for 50 by 32. 50 by 32, that's correct. No objects have been selected, okay. B, enter, DT, 50 by 32, select. Once again, the image is up, pick point, maybe this is a pick point for placement, and okay. It's already defined as block. What do you want to do in the drawing? Redefine block, don't refine. How is it defined already? I exploded that once. Redefine block, fine. It becomes a block. So now that I have the block, I can place it on both the sides. I'm going to copy that, select it, use it to copy in the first position here. But you see the ortho is turned off. This is the exact position in the center point, because I can also take the offset exactly the distance. And the next thing is here. Now what you're left with is to take the offset for 50 mm. If 50 mm, how much would be the offset? 25. 25 on both the sides for offset. You can see this side, in jumping to other side, taking from this side, moving to other side, and it closely, very, very neatly snaps in there. Now I need to trim the inner sides. TR double enter, select the top end, the bottom end, press enter, highlight everything, it gets deleted. Come back here, use TR enter, first point, second point, press enter, from inside try to highlight, it gets all deleted, and you will be getting a clear image of your fitting. Try to manage that with match that with the water layers all over, all across this way. And this is done. We have to match. Is it fine? Is it understood how you did that one? So the changes is very, very important, how you're trying to make changes to individual fittings. Do not forget to do that. And do not make multiple mistakes. Now you have to tell me entirely from the starting to end for this particular AHU. I'm leaving this up to your decision, and the last one is totally homework. Yeah, how do we do this one? First explode, both of them. Done. How much would be the offset? See the pipe size, 32. So offset would be 16. Correct. Next, how would you understand the levels? What should be there for supply? What should be there for return? See that if there is any changes or any turning taking place, how the water is entering, how it is not entering. Tell me as per your results. Yeah, for the supply. Level 1 changing directly to level 2, and the return from level 3 directly falling to level 1. So which fitting can be used? Can we use the same one? Right? This is only possibility that we can use. Suppose I'm going to copy this, select, and remember the sizes are the same. It becomes very, very easy for you. If it was not same, you'll have to do from starting. Select a new piece, rescale it, block it, give a new name, and etc. So one fitting, the water is moving from level 3 directly into level 1, and water coming from level 1 is jumping and moving to level 2. That is clearly understood. What we have to do now, we have to trim the inner lines, TR double enter, everything that is there inside. TR single enter, this side, press enter. Chill water pipe DLD is very, very MA enter. Try to match it. And the watermark is gone.
This is going to be conveying brine water, right? Not pure water.
Which one?
These pipes are meant for brine, conveying brine.
Conveying water means?
Pure water.
Conveying water like as in which type of water are you talking? It has to be the potable water. It is not going to be the hard water. It's going to be the soft water. Because the moment you're trying to use the hard water, the pipes and everything will be corroded very soon because of the chemicals and the minerals that is available inside the hard water. It has to be the soft water or the potable water that is provided for drinking and washing and etc. so that the life of the machine and the pipe is going to prolong for long. And I just missed to have my center line. Where did that go? Offset for 25. That is done, right? So now what we're going to come is we're coming down. We did not apply anything here. Fine. We have done the systems here. We have done the changes here. Why we are not doing anything here is because Now, since this is the last segment for the chiller, that the last AHU. So every time the last AHU is a little special and it is a little more modified available for you. More modifications can be done to that. Now the pipe size is 50 and this is 25. Any fitting that I'm going to apply here, suppose I will have to apply a downward elbow, which is nothing this one. I'll first get the fitting, 90-degree downward elbow. This is the selection of the fitting that we have to do there, even though despite of rotation, it is going to look very different. I'm going to apply one of them here, one of them here. So once I'll try to rotate that, RO enter. I can apply that this way, this way, this way. I can apply that this way. Fine. So now that I have to explode this to make changes, what I can do is, it above side is 50, side below is 25. Same is the case for return. Return goes to 25, mixes with 50. What I can also do is, since it is the last AHU and only the last entered pipe is 25 mm, I can try to apply a reducer in between and try to reduce the size even more than 50 in only situation when you have the last AHU connected. And that AHU's size has to match the size of my chiller pipe, that is a riser pipe. But you see the levels are still different. Only the pipe sizes are becoming same. Do not get confused there. Alright, the 25 mm pipe that is coming is still a riser. It is only changing its size. Level is not changing. If the level had to change, then this fitting did not have to apply here. You will be applying the normal 90-degree elbow. But remember, the levels are not changing, only the size of the pipe is changing. So in order to apply the change for the pipe, what I need to do is I need to create a reducer. I need to apply a reducer, but at what distance do I apply that? How can I understand? When you have entered the last fitting, what you can do is, from here, minimum of 1 feet of distance, you can leave for the distance pipe. That means distance pipe is nothing but the same carriage of pipe of the same size above and below the fitting. Suppose you directly apply the reducer here, the water that is going to move back to inside the riser, it directly has to engulf itself into the small size of the pipe. So you cannot do that. You have to leave 1 feet of minimum distance. That is a same size pipe distance, and after 1 feet of the distance pipe, you can cut the pipe and make it smaller. Correct? So what I'm going to do is I'm going to draw one line here. Maybe I'll use a different color. L enter. This position to this position is one line drawn. From there, I'm taking a different line because it will become easy for me to take the offset. Minimum is 1 feet is what I told you. 1 feet is how much in terms of mm? 300. To take 12 inches, or you have to take 300 mm. I'm going to maintain this here of 500 mm, near to 2 feet. How much exactly is 500 mm? Calculate and tell me. Is 1 feet with 6 inches. So क्या होता 1.5 feet? Nearly. ठीक है? So I'm going to take an offset for 500 mm from this blue line to below. And you can see this is where I can apply the reducer. And this whole thing is my distance pipe. So do I need a distance pipe only for supply or for return also? Return also is needed. Why? Because if this pipe is coming in short, the return also has to go and flow in the same position. Correct? So we are going to draw that line again. L enter. Offset for 500 mm and below. And we will get the positions for supply and return. This one, diffusers, reducers. Now coming back to the catalog, inside the category of reducers, now from the pipe drawing, tell me how much should be the above size and the below size. mm is the above head of the reducer, below is 25, right? So for me to change that, I need the smallest one so that it is easy for me to do the scaling. Always now, till now we have started doing with 100, keeping the maximum scaling limit as reference. So that will be keeping us in the mind key. Most probably this will also be 100. So if you're going to choose that way, you can select this one because the above portion is 100, below portion is 65. You'll have to do individual scaling. You'll have to break totally do individual because the overall, suppose you're going to make to 50%, this will become 50 above. This will become 32. Again, you'll have to change and try to change only this portion. You can do that also. Not a time waste. Suppose if you have selected this one and you have applied the reference length as 100, it is totally disagreeing. The above side is 80. It will try to change you as per 100, not as per 80. What you require is 50, it will give you 70. Right, that will become a big mistake. So try to take what you are aware of. Fine, so I'm going to copy this size, 100 by 65. Keep my the ortho off. Move here. I require it to place here. Place once. I need to rotate that. I'll be rotating. You can tell me which position to rotate. Like this. This way. This way. Right. So above is bigger. Below is smaller. So it is 100 by 80 or 100 by 65? 100 by? Yeah, check again because the confusion can make us do a lot of mistakes. It is 100 by 65. Okay. So below portion is 65. Remember that one. So which way, what do we want to go? We want to break it the whole thing, or we want to do the whole scale first and then block? We want to do the whole scale first. Okay. I'm going to scale this. Base point. Reference is 100. I require is 54 top. Come below. Do DI, enter. Check what is the size. It says it is 32.5, exactly 50% of 65. Now for that we have to make it from 32.5 to 25. Now I can explode. I can explode or no? Yes, totally explode. Then I am going to do the scaling only for this much portion. So we have changed this from 50 to 25. And now I need to convert that to block again. B enter. Enter the name. I'm going to be reducer 50 by 25. Try to keep that in capitals. Select the object, whole thing, enter, pick point, this point, click OK, and it is updated. It is updated in blue color. Fine. We all know how to create block. So I'm going to copy that. This side. Keep my ortho turned off. Place it here. Place it here. Now I need to make proper offset below of 25 mm. How would I do that? I'm going to sketch a line. I'll first try to take my supply layer on this one. Use my line from this end, totally move over the dotted lines. Reach until the bottommost position here. And after that, come very closer to this side, use TR double enter and delete these two lines. Now I'll be getting enough room for doing the offset. How much of 25? How much would be the offset? 12.5. This way. Lastly, match with the water layer. If it just delete the line, the water layer is already there, but it will be deleted from above. Same thing here again. You can do the offset directly with this line also. Offset for 12.5 on both the ends. This way, TR double enter, trim this side, MA enter, match with these two. It's ready made, available for you. Very nicely done. You can come below and you can see it is matched with the properties. Now the only thing you have to do is you have to apply this fitting. This was 100 earlier, directly of one size, it becomes to 25. to scale it. You don't need to explode that. Select a base point, R enter, 100 is original, new is 25. Move, okay, otherwise we'll copy. Select the base point, bring it here, turn off ortho, and you can see the moment I place it in the center, everything is going to be closely wrapped. Use TR single enter, this side, try to trim everything inside. Here again, TR enter, single enter key, this end, this end. Use match command, match it, and that is done. Do the same thing here, match with the layer that is substituted with. Is it clear? So this way we have completed the chill water piping DLD. Now the next thing what you need to understand is you have to make the insulation for the pipes. And insulation for the pipes is, I think if you have insulation, INS is insulation. I'm going to take the insulation with maroonish color or purplish color, and I want to do that with different kind of a line type, maybe dash and dotted. So now we are going to see how to create the insulation. For the insulation, what you have to do is you don't have to create any new line. Select this last line and take an offset of 10 mm. Offset for 10 mm, and outside, this one outside, this one outside, this one outside. Select one, match it with INS, and then you can see this kind of an insulation is taking place. Now you can match that everywhere. It is an insulation to control the thermal efficiency of water for supply and for return both is what you can do. Now maybe if I can take an offset for this one also at 10 mm, how it will come? Can we take an offset for that? Yeah, I will have to explode that, so it cannot be. So what I'll be doing is I'll be matching it this way. F enter, R enter, maybe I'll take 10 from this side and this side is what it will come this way. So that should be going to give me a little good look. F enter, R enter, 10 once again, this side, this side. Fine. So you have to do that same thing for return as well. I'm just showing you the example here for the supply, and you have to continue that all over the drawing. None of the pipe has to be left without doing the insulation. Now that we are coming here, because we're having enough room this side, maybe I'll just calculate how much is going to be the distance so that we can just finish the complete chill water drawing. This says it is 116. So what is the half of 116 exactly? 116, 50, oh, I just multiply that. 58, yes. So I am going to show you how to make the cut drawing. All right, how to show that the green pipe is moving below and red pipe is moving above. So for that, I have a cut geometry. You can see here, I have a cut geometry that is for single type and double type. I'm going to show that in the single type. I'm going to copy, and remember the cut geometry is also created at a scale of 100. And I'm going to place it somewhere here rather than placing it above. So 116 is this side, and this side I'm also going to take 116 for that matter. But the cut geometry does not need to, you're just showing the opening. It is nothing very important. You're just showing the opening for a very proper understanding purpose. So what I'm going to do is I'm going to create a new layer. Sorry, I'm going to make that one. Use L enter, draw one line to this side, keeping the ortho turned on. Going to take an offset of not 58. 58 would become exactly the half of it. I want to take much less. Maybe I'll take 40. This much from there, and I'll want to draw that line here, and I want to see where is the offset of 40 mm coming. Because if it comes very close to my fitting, you'll not be able to understand. Right. So this way, now what I want to do is I want to take this and make it the size of the pipe. How much is this originally? It is 10. Sorry, 100. Make it 50. SC 100. SC enter. Select it. Specify one base point. Take reference. It was earlier 100. Newly I want to make it 50. And that becomes small. When you're going to move that and place it directly on this midpoint, it has to fit this way. Now see, when you're trying to trim or do anything on this side, TR double enter, it will trim, it will trim. This one will not trim because it will become my single line. Now what I need to do is I need to mirror this exactly on this position. So I have to keep my ortho turned on, M. If I copy, it will come in the same position. I'm doing mirror because I want the opening on the opposite side. Now you see, this side is the opening, means this side it has to be closed. And this side, if it is closed, this side has to have the opening. Fine. So MI enter, select this object, and I'm going to select this portion here somewhere, and I'm going to go on the other direction. You can see it is forming below. Click there, erase source object, no, and enter. Come back here, select this, and if I'm going to delete this totally, what will happen is you won't be able to trim this portion. So I'm going to use TR double enter. First try to trim this much area. Now if I try to trim this area here, you see things are going to change in between. So I'm going to select all these lines, delete, it's not required. The black lines for the offset, delete, and this is how things are going. But you see my line, the water line in from between, that just moved out. That is because we did not have any particular line there to select from, trim from. So what you can do is you can try to undo that. Yes. So first I have to trim this portion so that it does not trim from this side. And then I can try to delete each and every one that is not required. This is done. So this is a cut opening, and then from here you can delete this line for you to understand that the red pipe is moving above the green pipe. So wherever this kind of congestion is coming, you have to do that. Now maybe here, once again, you can do that one, right? And where else it is coming? It is coming here. Yes, the red pipe is moving above, so there has to be a cut section from this end. Fine. So with this, you can conclude that you know how to do, and here the pipe size is now changed. So you'll have to mark with the ellipse. This one and this one, I'm just going to copy that. And did not place exactly in the proper zone. EL enter. That becomes 25. And last GPM level also flowing will be 7.2 GPM inside this one. So we are changing that one to 25 mm, same as the last size. Now whatever we have done, I'm just going to delete that. And very neatly. Now from here, since the riser is turning and it is maintained at 50 mm, what fitting would you apply? Because since it is in the same level, elbow, 90-degree elbow, and the size would be 50 mm, depending upon the main riser size that is here, right? So until this, you have one AHU left for with the known quantity. You can do that as homework, and the rest complete examination you can do for these 4 AHUs of your own quantities. It is up to you. So I'm leaving that one for homework because you can just see how we did these things, and you have to do one at least. We have done 3, and everything is of the same quantity and same type. Fine. So what I'm going to do now is I'm going to save this file. And call this DLD, chill water pipe DLD. Save it. Now let us continue the next segment, that is the last portion of understanding what we're doing with the chill water piping is for the section drawing. Okay, and what we have to learn inside the section drawing usually is people usually want the engineers to prepare, or the engineer wants the draftsman to prepare some kind of a section view for you. If this is the whole plan of yours, this is the actual plan. Maybe you are cutting down a section this way, like this, to view only this much zone. Okay, maybe you're cutting down a section this way to view only this much zone of the complete plan. So how do you actually do that is what we're going to study today. For understanding this, you should know 2 or 3 different things. One is called your FFL, the other is FCL, and the last is SSL. This is finished floor level, FCL is false ceiling level, SSL is your structure slab level. Okay, so you should know the full forms, you should know how it is going to be. And now what you have to actually understand from this particular elevation drawing, this is also a project initialized with SM Techno here. So this is the drafting done by one of our draftsmen in the institute, and this is a creative project already into existence presently. And from this complete plan, what you have to understand is it is a multi-story building, directly starting from your ground floor until 20 to 21 flooring area. You can see there's 21 floors, and then lastly there's a terrace area, roof area. So here this building is what we are going to see from the front view, not the top view. We're looking at it from the front view, and you can see each and every distance, the second floor, the third floor, the fourth floor, all of them is maintained at one particular height called 3650 mm. Now calculate that and tell me how much is that in feet. It has to be nearly 10 feet, 9 feet, 11 feet. How would you do that? You should know that better. You have to tell me how much is that in terms of feet and inches. Nearly 12 feet, right? So 12 feet, that is the total from your FFL to the SSL. In between is where your FCL level rises. FFL is nothing but the place, the ground floor level where you keep your legs, and the top level, that is the next floor for the next FFL of the next floor, is marked with the SSL of the existing floor. Where you will get the slab level, and over the slab level is what the finished level for the next floor will generate. So each and every height is maintained as 12 feet. That is okay. Now if I'm going to come to the interior of this, is what you will be seeing that every segment is marked very, very clearly between all type of levels. You can see here, this is the double line existence is your FFL, finished floor level, up to the false ceiling level. This is your false ceiling level. It is how much? It says that is 2720 from FFL to FCL. Next, you have from FFL to the SSL without the slab thickness is 3270. Next, your total thickness of your false ceiling is 550 mm. That is nearly to 600 mm, like 2 feet. Okay? Yes, the false ceiling. The space over the false ceiling for the services to run. Now the thickness of the false ceiling is 25 mm, 1 inch. Then you have something called 280, which is nearly to 300 mm. That is, this particular segment is your slab thickness of 1 feet before the next floor is started. And between that also you have another thing called 100 mm, which is called the air void space, thermal membrane, air thermal membrane. You are going to leave that much of gap in terms of an insulation. You can do that with any kind of insulation depending upon the structural engineer is going to decide. But you have to leave at least 4 inches before the next tiles of the next floor is going to be applied. Fine. So this is how different levels are accommodated and elaborated here. This is for your example that how the levels have to be applied. So we are going to take the example of this one, and I'm now going to open before you the complete, this is where we did the chill water piping, right? This is the complete area with your complete HVAC drawing. You can see there are FCUs and AHUs connected with the ducts. The insulation is provided. You have your, if I can just turn and try to show you my pipes. If I'm going to go here to my layers, in this one we have your chill water pipes here. That is, they are taken from the last portion, not from the center. Fine. So this is your chill water pipes that you can see. Chill water return, chill water supply, and etc. All the annotations, the dimensions, everything is given to you. And inside this particular plan or this complete view is what we are going to create a section drawing only and only where I feel that there is a complication in understanding. So usually you should see that the section drawings are drawn only and only created by the draftsman on the authority of the engineer for proper understanding of only that particular segment, which is called a section drawing. So from the complete plan, maybe I'm going to try to focus on this much area. You can see that with the marking A until to this place where there is a kitchen hood. Why I'm selecting only this portion is because I have every supported quantity of the HVAC listed. We have the chill waters, we have the ducts, we have the flexible connection, then we have so many things that are all over it, so that everything becomes very handy for me to understand how to deal with the section drawing. Fine. So what we are going to actually do from here is we have created this section drawing, but remember, whenever you're going to do the section drawing, you do not have to work in one single viewport. We are going to change or duplicate the complete screen into two halves, where same plan is going to be looking below and above both. For that, we have a command called viewport center, and you will be getting a viewport screen. From there, currently you are using a single viewport, that is this one. Now, because I have my original plan above and I want to draw something below, I cannot actually have my vertical type of viewport. I need to have it equal above and below. So maybe I'll take 2 for horizontal. Now maybe if you're going to work in a completely MEP drawing by trying to look for same drawing but different segments, you can suppose this is going to be MEP, from this is HVAC, electrical, plumbing and firefighting, all 4 different designs of the same model. So what you can do is you can try to change that to 4 different viewports. Alright, so we are going to do that for 2 in horizontal way. One, I'm going to keep the original section above and create my section drawing below. I'm going to click OK, and you can see my screen divides into 2 equal halves. Now if I'm going to move here and try to zoom, only this portion zooms. This portion is not touched. If I'm coming here and if I'm going to zoom again, you see that is only being zoomed. Why? Because theme coming back here, take the offset for 3800 directly from here and above. Zoom out a little bit, then you will get the portion this way. Fine. So that becomes extremely huge. Suppose if I have taken the offset of 3700, just 50 mm more than that one, you can see it comes very close to that one. So let us continue with 3700 and rather not this portion. So where do I actually click and where do I actually not click? All this that depended over your original plan view at this end. This is only the initial drawing. If I'm going to click here and try to look up the starting wall position, because we're going to create the architectural part, so we need to start with the walls. But if I'm going to start with the walls, remember the portion A from where it is starting, only the section will be seen from there. So why to create from the wall? I can start directly creating from this end. Fine. So what I'm going to do is we are going to use the construction line in vertical axis. That is, if I'm going to click at this end here, the starting point, you can see the line is developed in this viewport also. Fine. So that is the starting portion. And if I don't want to do from there, I can also do from here. So let that be the starting portion. I'm going to select this and I'm going to delete that. From here is this arrow mark. So use Excel enter V, enter once more, come to this position, snap it, and it will draw the next probable area for you. Now coming back to my second viewport, I can select these lines, stretch them across for creating the architectural view. column and the slab level that we have. Now from this complete drawing, what we need to do is we are looking at everything from the side. All right, from the side view. So you are standing on the black line and you're looking at each and everything. So the complete HVAC drafting is going to look and I'm distributing totally 2 feet for them. All right, 2 feet, or maybe I'll keep 1.5 feet for them. The rest 1.5 feet is left for HVAC drawing. So from here, 1.5 feet means how much mm? Mm. 300 mm is 1 feet. Huh. So for this side, totally this side, and I'm not going to do that below. First, I'll show you how to do the thing. Turn off the ortho. flexible duct is applied, I can select these two lines and I can just delete them. I don't require the reference anymore. So this is we have next is if you're going to come on the other side after the HU, we can find inside the above the section is you have a lines. So now we have completed each and everything very clearly, very neatly. We can just clean up what we